Siri_bot says Siri_bot has joined Cerebro Love.
Nice. Hopefully there's no more mistakes in the Khan Academy stuff.
Eras Mazapa says hey guys.
Oh, that was fast. Hey, Terrace. Um,
Eras Mazapa says fast.
Fast, like someone joined fast. Usually get to be by myself for 5 minutes at the beginning of a stream or so. Dang, I didn't stream for like 3 days, so I probably forgot literally
Eras
everything.
Mazapa says sorry if I violated your personal space.
You didn't. You didn't
Laughing
violate
face.
my personal space. I meant it as a good thing. Like it's like, oh, cool, someone's here. Don't worry, you don't stream if you want personal space. That's like not what people do. Like, I wonder if this like music is new or if it's just for the lower grade levels because it plays like this music every time you finish like a lesson, which is interesting. Okay.
Eras Mazapa says what is your goal with streaming/learning?
Just learning new things. Honestly, that's about it. For real goal. And then just see where things go. I would like to stream most days, but I did miss like 3 days, but I was really busy, so I guess I don't feel too bad about it. But yeah. I'd like to at least be kind of consistent.
Corrupt Converter says you're late.
Oh, I know, right, Corrupt?
Eras
Very
Mazapa
late.
says have you completed high school/college?
Well, I'll tell you I am. I don't like sharing too much personal details online, but I'm an adult. Yeah. As for the specifics, those things
Eras Mazapa says sounds good.
come up when they're relevant.
Eras Mazapa
If
says
and
grade
when.
5 math. Laughing face.
Yeah, well, I'm trying to complete. Oh, you might not know this. I've told a lot of my viewers know this, but I'm trying to finish everything in Khan Academy. Like, I want to have every single math course in Khan Academy completed, so I can be like the only one who is like
Corrupt
crazy
Converter
enough.
says they never graduated.
He's lying. Actually, even Corrupt doesn't know.
Corrupt Converter says but they aren't in high school anymore.
Yeah, because I went to
high
school at
school for them was
Aristotle's,
like
right?
30 or 40 years ago.
Okay. Anyway, when was it doing? 90. I'm trying to think where I put the decimal here.
Charisma Zapa says okay, good luck, see you around.
$45. What if you do it like this with the decimals?
Corrupt Converter says fingers crossed I don't have HIV or some shit when my blood work and urinalysis results comes back.
Yeah, I mean, I hope we don't have anything bad. I think you just do it like this. Of course, I don't get calculators here. Though I spent like forever yesterday after I set up all the stuff in Visual Studio Code. Like I spent like forever trying to get a library to work that I wanted. Not that I needed it, but like damn. Wait, that was annoying. But I got it to work after like forever. I ran out of space. Damn it. It's too hard to draw on the trackpad. Too difficult. Seven, 5.
Corrupt Converter says 95 asterisk 62 slash 1000.
95 times 62 for 1000. Oh yeah, because of the decimals. You're right. Hope I did I add these things right? I'm gonna check with the calculator, but oh damn it. 0, 9. This is probably supposed to be a. I thought this was a 7, but I guess it wasn't.
Corrupt Converter
Actually?
says 10, 620 to 62, 10, 62 halves, slash 1000
What the
methanes.
hell? Times 10. Wait, let me think about that. What did you write? 10 times. Oh, you do. Okay.
Corrupt Converter says whenever I see ax multiply by 9, I do 10x, x.
Oh, you meant, okay, you wrote plus the other one. I guess you meant minus?
Corrupt converter says times 10 because it's 90 and not 9.
But then again, wait, 10? And then the 5. Where's their 5?
Corrupt converter says so 10 asterisk.
Oh my god, I'm
62
reminded of when
halves.
Win said, like, oh, this is why, uh, when Win said this is why math teachers use whiteboards.
Corrupt converter says I'm doing 62 asterisk 90 and 62 asterisk 5.
So because you're like, 90, 62 times 5. Oh wait, there was a 95? Oh yeah, there was. No, that's like more, that's like too many steps to keep track of. Wait, what did he wrong here? 9, 18, 19, 6, 7.
Of me says 07.
Yeah, I see.
Corrupt converter says less actual thought needs to go into it.
But you do at least have to remember what your results and stuff for the other steps. Even if like I guess the actual calculation part's easier.
Corrupt converter says like, if I said what's 123,456 asterisk 9, it's much easier to do. 1 2 3 4 5 6 asterisk 10, 123,456.
Yeah, probably. I guess. But you still have to do that subtraction thing. I don't know if the subtraction is easier necessarily than just straight up multiplying it the long way. Because subtraction the long way is almost just as annoying. Subtraction is annoying.
Corrupt converter says subtraction is easy, yes.
I said annoying. 3, 4. Wait, what did I...
Corrupt converter says maybe it's just a difference in how we do it.
No, wait. 0. 5, 6, 12, 18, 19. Maybe. They can make things worse. If my handwriting wasn't as bad.
Corrupt
okay, after this I'm using a
1,
tablet.
2,
this is
3,
stupid.
4 5 6 0. 123,456 equals 111,104 by mental math, I think.
See, subtraction is annoying. It's annoying.
Corrupt converter says missed a 1, I think.
5, 10, 0, 30, 4. Oh, wait, that was a 7. Wait, why is it a 7?
Corrupt converter says 111, 1104.
45. Well, my memory's so fucking bad. Ugh. Oh yeah, it's a 5. I think this is actually supposed to be 23. I do.
Corrupt Converter says if I had it written on paper I wouldn't miss that.
Yeah. But I guess honestly the better way, since your way, I mean, you know, it involves less writing. Whatever involves less writing is better because, Jesus. At least when you're writing on a trackpad. I don't even remember what I wrote here. Like, that's how messy this is. Like, damn it. Okay, I give up. I'm rewriting the whole thing. This is stupid. I hate this. Where's my pen? They don't give you enough freaking space to write with.
620 to 62 equals 558.
Ugh. Hold on. I'm looking for something. Oh, there we go. There it is.
Corrupt Converter says just be better at writing better.
I know. I can't write clearly on a trackpad. It's so freaking annoying. We should do it again. I'm not even going to try to read what I wrote anymore. I'm done.
Pixels.
It's too difficult. I think I'll just do it over here. So annoying. Well, this is what I was originally doing, so I'll just... Okay, so I have this. Do I have enough space? I don't know. Wait, what is this? 0? Okay, I don't know if this is the right answer or not. What did I have? There we go. I'm not gonna try to use my trackpad ever again. That was too much. It was too much. Let's see. I don't know. If I wasn't gonna do this like the boring long way, like the way I just did earlier, what would you do? You would probably do something like 50 times 31 and 6 times 31 or something. I don't know if that's more efficient though.
Corrupt Converter says so where the 1000 comes from, if you multiply 6.2 by 10, you get 62, and 0.95 by 100, you get 95, so 10 asterisk 100 equals 1000, the result will be scaled up by 1000 and needs to be scaled back down.
Wait, what's a good place for a nice trick of reusing computation? What you were just talking about in the last message, so where the 1000 comes from. 6.2 by 10, you get 62. Oh yeah. And 0.95 by 100, you get 95. So 10 times 100 is 1000.
Corrupt Converter says you can use the 5x equals x/2.
It needs
10
to be
trick
scaled
to get
back
531.
Down. Oh. That's actually really cool.
Corrupt Converter says or 5 asterisk 3.1.
Oh, this new one. Let's see what you're gonna do. You can use the 5x. Wait, 5 times 5x.
Corrupt Converter says and then reuse that for the 6.
X over 2 times 10. Wait, how did you come up with that? Oh no, is this one of those rules again? What's 1/2?
Corrupt converter says what's 1/2?
Maybe use it for the 6. Oh,
Corrupt
5?
converter says or actually.
Oh, 5. Wait. Oh, okay. Because 1/2 x over 2 is 5.
Corrupt
Well,
converter
that's
says
10.
yep.
5 times 10 is 50. So then the answer is x is... Wait, why do we have algebra now? X is 10?
Corrupt converter says so
Is
what
this
we're
useful?
doing is dividing by 2, and multiplying by 10, so multiplying by October 2nd.
Multiplying by October 2nd. We should... I want to read all fractions like that from now on. I love my TTS. It's funny. Which is multiplying by 5. Wait a second. What? 5 times... Oh, so you're saying divide by 1/2 times 10 to get 5 times. That's what you get for multiplying. Instead of multiplying by 5, you can just divide by 1/2, multiply by 10.
Corrupt converter says
Oh
it's
yeah,
a
you
useful
did tell me
trick
last
for
time. I just
mental
forgot.
math because multiplying by October 2nd is easier than counting up to times 5.
Yes, it's easier to multiply by October 2nd. It's true. Okay. So I should try to do that. But is that really easier if I do that? 5. Okay. So I take 3.1 or whatever.
Corrupt converter
But
says divide by 2 is really easy to do quickly, and
3.1
multiplying
divided by
10 is
2.
just shifting a decimal point.
It's like annoying. But maybe I just need to turn it into 31 divided by 2. It's like 14.5. And then it's like 1.45?
Corrupt converter
Times
says
10?
honestly.
Am I doing this right? I don't even know anymore. Would it be like 1.45? I'm trying.
Corrupt converter says 3.1 times 5 is actually just easy.
Yeah. See, I could have just did it the long way instead of doing it like this, but it's just 15.5.
Corrupt converter says
oh wait,
IR is
yeah,
just
you're right.
15.5.
It's true. 15.5. If it was 31, but then I guess you'd move that, so it'd be like 1.55. If it was this. Oh wait. Oh, but then you multiply by 10, so you're right. 15 point. What you said.
Corrupt converter says 5350.1 equals 15.0.5.
15.5. So this is what it would be if it was times 5. 15.5. I see. Okay. I said I wouldn't use my trackpad. I lied. So then you would just have this 0.6.
Corrupt converter says so 15.5 yes.
Okay. Got you. 6. 18.
Corrupt converter
1.
says so that's 5x.
So you would just
where
add...
x equals 3.
You could just add 15.5 and 18.6, right?
Corrupt converter says and then 6x
oh,
is
you did
5x
plus x.
So 15.5 3.1.
15.5 plus... Oh, wait. What the hell? I did something completely wrong then. Not 18.6, but it should be 15.5 plus... Damn. What you said. Plus 3.1. Oh, wait. 18.6. And that is 18.6. That's what you're saying.
Corrupt converter says 18.6 yes.
Actually, you know what? I like the way you broke this problem down. It's pretty elegant. Honestly. Okay, that's cool. Right, so then it's like 5 plus 5. 15, 14. Oh my god.
Corrupt converter says it's an optimization trick that you'll learn in programming too.
Really? That's pretty cool. Okay, so, what are they? 11. 1, 2, 3. Okay, so I think this is 34.1. Let me double check I did that right.
Corrupt converter says so 15.5
Oh, damn it!
1.86.
I don't know how to add numbers. Wait a second. I totally completely missed something. What did I do wrong? 11. 14.
Corrupt converter says it's not 15.5 18.6, because the first is times 5, and the second is for the times 0.6.
Shoot. Oh, it's plus 1.0. Damn it. Oh, I see. 1.86. What did I do here? Why did I come up with 18.6?
Corrupt converter says need to shift decimal point.
Oh, because it's supposed to be 0.6, but you were doing 8. I see, 18.6 is times 6, so you have to shift it, the decimal point over, so that's 0.6. Then it's 1.86. Oh, okay. I see, so 6. This decimal's over here now. 1.86. Is it just like move it over? Oh wait, why did I come up with a 3? Jesus. Yeah, my things are already looking messy. Wait a second. Okay, I'm just gonna write it because I'm getting confused where things are placed. Okay, 6, 3, 5, 6, 7.
Corrupt converter says none of these tricks were very necessary here, but they're good in the long run, especially for trickier problems.
Yeah, it's true. Honestly, it's worth it for the later. You're right. I know they weren't necessary here because I could have done it faster just doing it like the long way, but it's good to know like how these things work for later on. Because I do want to be able to solve more difficult
Corrupt converter
problems
says yeah.
in the future. I mean, this is like 5th grade, so like, not very interesting. But later on, when numbers get more complicated, and then it's like, you know what I mean? Like what you said, it's much better to use tricks like this once numbers get like significantly bigger and stuff than trying to brute force it like, you know, the long way, I guess. I agree. What was I doing again? Oh yeah. 7. So 17.36. There we go.
Corrupt converter says 34th grade uses 34-digit numbers that you have to do with mental math.
What the? Oh no. I don't want to go to 34th grade then. That sounds like hell. Please. Please not 44. Wait, there's half. I'm gonna try. Okay, I'm gonna try something. I'm gonna do the times divide by 2 times 10, but then I'll have to shift the decimal point or something. I'll have to do something afterwards. Wait, let's just. I'm just gonna pretend this is a 5. And then yeah, I think I have to shift the decimal point over 1 after I'm done. So, right. Divide by 2 is 45, 46 times 10 for 60. Wait, this is. Wait. This doesn't seem right though. Oh, yeah, yeah. I don't know. The decimal doesn't seem right. It shouldn't be over here. Hmm. I think I'm not moving the decimal over enough. But then how do you do this? Maybe I have to move it over 3? Oh, yeah, because it's not 92. So 0.46? Is that what it is?
Corrupt converter says you likely missed a decimal shift somewhere.
Hmm. So, like, here, what would you say to this? 0.46? Oh, wow! That was a lot faster than
Corrupt
if I had
converter
done.
says
Well, actually, I don't know if it was
0.46 yes.
faster, but I did it. I did the mental thing, like without writing a bunch of numbers and getting confused. Like just divide by 2 times 10, and then I have to move the decimal over enough times to, you know, yeah, 3 times actually. Honestly, without you around, Corrupt, I would be super lazy. You're like,
Corrupt converter says the fastest way for this specific one is divide by 2 and stop there.
oh, because then you can just shift the decimal over one less place. Like, that's all you have to do. Because times 10, then you have to undo the times 10. So why even do the times 10 in the first place? Just you can cut out the times 10 step. I get it. That's true. Optimization. Damn it, you're right, you're
Corrupt
right.
converter says yeah.
You're so right. But yeah. Okay. What do I do now? I feel like I've done enough math now. Is it possible to achieve the same exact result?
Corrupt converter
Agreed,
says do
agreed.
as little work as is possible to achieve the same exact result.
Yeah. Not harder and stupider. Mm-hmm. I like that. Lazier. Oh, hey, Sigrid. Hi. Okay,
Sigrid
I'm gonna
says
go
hey
back to
Leah.
reading CPU Land. Um, okay. Where is it? I bookmarked it. Alright, I'm
Sigrid
just
says
gonna
through he.
do things the easy way. But I was almost done with this. And it talked about something interesting. Like, I finally got to an interesting part where it's talking about, like, linking libraries or something. Or date, the DLL things, so. Yeah. Let's see. It was a few days ago that I tried reading this. I probably forgot everything. I have another
Corrupt converter
stipulation.
says oh I forgot I need to add another stipulation to
Oh
the
no.
assembly stuff.
Oh no. Not another stipulation. Wait, where did I do off? I think here. Dynamic linking in the wild. On Linux, dynamically linkable libraries like bar are typically packaged into files with the .shared object extension. What the? Okay. These shared object files are ELF files, just like programs. You may recall that the ELF header includes a field to specify whether the file is an executable or a library. Just like programs. Okay. In addition, shared objects have a .dynsim, dynamic symbol, I guess, section in the section header table, which contains information on what symbols are exported from the file and can be dynamically linked to. Huh. On Windows, libraries like bar are packaged into .dll, dynamic link library files.
Corrupt converter says you are not allowed to write the problems in C, or anything larger than
What the
C that
hell?
contains the solution to the problems, and use or reference their
Oh
compiled
yeah, that
assembly
is
as your
cheating. You're
solution.
right. I wouldn't do that. That's because that literally is cheating. You're right. Because C gets compiled into, it turns into assembly, and if you just copy and paste that assembly, like you didn't solve it in assembly, you just copied you had the compiler do all the work for you. That's fair. I accept that. Just like Mac OS apps and Windows.exe files, these are formatted slightly different from ELF files, but are the same concept and technique.
Corrupt Converter says you can, however, code it in C first, and then reference the C source code as a guide for writing it in assembly.
Oh, okay. Oh yeah, yeah. You mean code it in C just to see like the logic of what I'm doing in C, but just don't peek at the assembly. Yeah, of the C part. Yeah. Okay. That's fair. Where was I again? Oh yeah. Dynamically linked library. Wait a second. Oh, here. macOS uses the dynamically linked library extension, so they just name it differently. Dylib. Just like macOS, apps and Windows.exe files. These are formatted slightly differently from ELF files, but are the same concept and technique. Okay. An interesting distinction between the two types of linking is that with static linking, only the portions of the library that are used are included in the executable, and thus loaded into memory. Are included, oh. That's cool. With dynamic linking, the entire library is loaded into memory. That seems like a waste, doesn't it? Dynamic linking.
Corrupt Converter says you may code smaller things in C to see how to do specific small things in assembly, like converting float to int, or reading a memory address, or writing an if or for statement,
okay,
etc.
That's fair, so I can get like these little pieces. Just don't code the whole program. Because then I could just cheat and copy all of it. Reading a memory address or writing an if or for statement. Yeah. Okay. So just very, very simple little pieces I'm allowed to look at the assembly
Corrupt
for.
Converter says yet.
Oh, cool. Isn't the, you use, what is it? You have, like, you showed me you have a program that lets you peek at assembly. But you said it was, like, difficult to use. Remember? It wasn't
Corrupt Converter says Godbolt.
Godbolt. Oh, yeah. Because otherwise, like, oh, yeah, I'd have to use, like, something like that. Or, oh, yeah, or Gidra. How do you
Corrupt
pronounce
Converter
that?
says Ogidra.
Gidra? Or is it, like, Jidra? GIF or GIF? Gydra. Damn it.
Corrupt Converter says Gydra.
Gydra. Okay. Which one do you recommend? This might initially sound less efficient, but it actually allows modern operating systems to save more space by
Corrupt
loading a
Converter says
library into
Godbolt.
memory once and then sharing that code between processes. Oh wow, really? Loading that into memory once. Oh, because it doesn't have to like keep
Corrupt Converter says
loading
by
stuff?
300 miles for this small thing.
Go between processes. Oh my god. Only code can be. I think I get this. That's cool. By 300 miles for this small thing. Wait, what's 300 miles? What miles? Oh, Godbolt for what we're doing. Yeah, okay, then Godbolt then. Oh, Gydra was the one that you said is hard to use. I guess that's what you meant. Oh wait, yeah. Only code can be shared as a library. Needs different state for different programs.
Corrupt
Oh,
Converter
okay.
says yet it takes longer and slower to read from hard drive than it is to read from RAM.
Oh, are you talking about the difference between static and linked? With your comment? Oh, because then it would have to read it from hard drive. If it's static, it has to read from hard drive, and if it's dynamic, it just puts everything in the memory. And that's why it's like it can be more efficient to just put everything there. Only code can be shared, as a library needs different state for different programs. But the savings can still be in the order of tens to hundreds of megabytes of RAM. Oh, 1 byte, 8 bits. Mega means 1,000?
Corrupt Converter says I wasn't paying much
Oh.
attention, but from the 0.1%
Okay.
that I paid attention to, sounds like.
But yeah, a megabyte is 1,000 bytes, right? So 10 to 100 times 1,000 bytes of. Oh wait, no.
Corrupt Converter says no.
Million. That's a lot. Then a million bytes. So then it's like a hundred or hundreds times millions of bytes of RAM, which is like seems like an ungodly amount of RAM. Code we shared with library needs different states for different programs.
Corrupt Converter says megabyte is 2 superscript 2 bytes.
Oh damn! 2 to the 20 bytes, about a million. That's a lot.
Corrupt Converter says which is about a million.
And then if a megabyte is that big, then Jesus Christ, then a gigabyte. A gigabyte's bigger than a meg. Wait, is a gigabyte bigger than a megabyte? Megabyte's bigger, right? Actually,
Corrupt Converter says but the word mega in measurement usually means million.
Well, giga's 1,000 then, so mega's bigger. Oh Jesus. Okay, gigabyte's a billion.
Corrupt Converter says gigabyte is about a billion.
I like that the EDS calls it a gigabyte. Kilobyte's 1,000. Oh, then gigabyte.
Corrupt
Then
Converter
oh my
says
god.
kilobyte is 1,000.
So then terabyte must be like a billion, trillion, jillion gigabytes. Billion. Oh my god. Computers can store way too much information. This is this is TMI.
Corrupt Converter says kilobyte equals
Oh, God.
1024, megabyte equals 1024 superscript 2, gigabyte equals 1024 superscript 3,
Oh,
terabyte equals 1024.
1,024. Wait, why is kilobyte? Why is it 1,024 and not 1,000? Why is everything done in the order of? Why is 1,024 the base? Power. Oh yeah. Oh, 1,000 isn't a power of 2, is it? Oh.
Corrupt Converter says powers of 2.
Okay. I kind of just assumed that 1,000 would be a power 2, but I guess it's not. Anyway, this part though I don't understand. This part, it says the library needs different states for different purposes. Like, oh wait. Oh wait, I read it. Okay, now I read it wrong. It says different state for different
Converter
programs.
says yeah, 1000 is fucking ugly in binary.
It's ugly. It really is in binary. Yeah, yeah. Code shows the library needs different state for different programs. Only code can be shared. But I'm thinking in my head when I read this, only code can be shared. Like the library is only code. So like what else would you possibly share? Cuz literally the library is just code. So like what? As the library needs different state for different programs. Oh.
Corrupt Converter says libraries can be data too.
Oh. Oh, so I guess that data has to be read then. Like it can't just be loaded up. Like only the code gets loaded into the RAM or something. It's just weird. Oh yeah, because the different programs might use different data, I guess. Wait, what you said? Execution.
Corrupt converter says like if you have LUTs.
What's an LUT? Let's hop on back to the kernel running L files. If the binary it's executing is dynamically linked to.
Corrupt converter says lookup table.
Oh, yeah, lookup table. Pre-computed values. Okay. You used those when you made Langton's ants. You pre-computed stuff, and then that's what you said. You called them lookup tables. That's cool. Cool. Oh.
Corrupt converter says yes.
Let's hop on back to the kernel running L files. If the binary it's executing is dynamically linked, the OS can't just jump to the binary's code right away because there would be missing code. Remember, dynamically linked programs only have references to the library functions they need. I thought that was statically linked. I thought dynamically linked loads everything. Wait. Where did it say that? Yeah, with dynamic linking, the entire library is loaded into memory. So what's it saying here? Dynamically linked programs only have references to library functions they need. Isn't it literally saying the opposite in the sentence that they just said? Like, aren't they like contradicting themselves? I think they mean like static. And this is a mistake. I don't know. I could ask ChatGPT. Now you don't need an account to use it, so that's nice. To run the binary, the OS needs to figure out what libraries are needed, load them, replace all the named pointers with actual jump instructions, and then start the actual program code. This is very complex code. Oh.
Converter says when you're
thank
in
you,
12th
thank
grade,
you.
this will all make more sense
hope
and
so.
you'll know for sure whether that's a mistake or not.
Why? This makes sense to you? There'd be missing code. Oh, I guess I just have to like. Oh, okay. Oh no, you don't.
Corrupt converter says no, I don't use libraries.
But why don't you just like make your own libraries? You know, you should use libraries. Isn't it supposed to make things more convenient to keep things, organized? I guess is that what this is? I think that's what this is for. What these library things are for reusing your code. So you could like you could make a corrupt library. Let me go quick shared. Copy pasting.
Corrupt converter says my version of using my own libraries is copy pasting the source code.
Lol. Look at this. This is very complex code that interacts deeply with the ELF format. So it's usually a standalone program rather than part of the kernel. Interesting. A standalone program, not part of the kernel. ELF files specify the path to the program they want to use. Typically something like library 64, linking dynamic. That's why I think that stands for, I don't know, Linux 8664.so.2. What do they call the SO? Shared object in a PT interp entry in the program header table. After reading the ELF header and scanning through the program header table, the kernel can set up the memory structure for the new program. It starts by loading all PT load segments into memory, populating the program's static data, BSS space, and machine code. If the program is dynamically linked, the kernel will have to execute the ELF interpreter. So it also loads the interpreter's data, BSS encoded in memory. Now the kernel needs to set the instruction pointer for the CPU to restore when returning to userland. If the executable is dynamically linked, the kernel sets the instruction pointer to the start of the ELF interpreter's code in memory. Otherwise, the kernel sets it to the start of the executable. The kernel is almost ready to return from the syscall. Remember, we're still in exec-v. It pushes the arguments. I forgot what these are called. I know I read about these, but I kind of forgot about them. But this one's for like, oh wait, argv and environment variables. Oh, separate. To the stack for the program to read when it begins. Oh. Oh, if the executable is dynamically linked. Doesn't make sense. The registers are now cleared. Before handling a syscall. Oh wait, when these get cleared, you said when you wait, no, never mind. Oh wait, didn't you say like when you take stuff off the register in assembly, it's like the command or whatever you write is like pop? You pop them off the register? Something like that. Before handling syscall, the kernel stores the current value of registers to the stack. Pulls off the stack. Oh, but not necessarily the register.
Pulls off the stack.
Oh, it's for the for the stack. I see. To the stack to be restored when switching back to user space. Register to be restored. Okay. Before returning to user space, the kernel zeros this part of the stack.
Corrupt converter says, oh, also funny thing, it doesn't zero out the value popped from the stack.
It doesn't? In memory. Why does it say before returning to user space, the kernel zeros as part of the stack? Does it just store them somewhere else? Finally, the syscall is over and the kernel returns to userland. It restores the registers, which are now zeroed, and jumps to the stored instruction pointer.
Corrupt converter says, I don't know what the article is talking about because I'm not paying attention.
That instruction pointer is now the starting point of the new program, or the ELF interpreter. And the current process has been replaced. To user space, kernel 0 spark the stack.
Corrupt converter says if you do MOVEX, 4 push EX pop EX MOVX, ESP4, then EX, EX, and X will be set to 4.
EAX4. Push EAX. Pop EB. What? Move ECX. Yes. The stack.
Corrupt converter says push onto the stack.
Oh, push EAX pushes whatever's in EAX to the stack. Oh, wow. Pop off the stack and store into this variable. Oh, damn! That's what.
Corrupt converter
Oh,
says
so you're
yes.
popping it off, taking 4, and storing it into EBX. Move ECX. ESP. And then the ESP, you said that's like where the pointer is to read from the stack or something? Like where it is. Something.
Corrupt converter says
where
yes.
It's reading from. Oh my god. From my sort. Oh god. Okay. Then EBX. Oh, you're setting everything to 4. Right, EBX is 4. Move CX -4. Why is the ESP memory cursor thing at -4 or whatever that is? ESP move 4 to the right.
Corrupt converter says
crap,
ESP
I
move
forgot
4 to the right, so reading from 4 to the left reads the value we just popped off.
I did forget that ESP moves by itself when you're like doing stuff. Like it'll move and add as things are added onto the stack.
Corrupt converter says reads from where ESP was before we did the pop.
For the I love how assembly uses pop. It's so funny. It's funny to me.
Corrupt converter says it moves automatically.
Oh wow, okay. So ESP moved 4 to the right. So reading from 4 to the left reads the value. Oh, you just pop off. Okay, I'm gonna reread the whole thing that you wrote and try to understand like each time ESP moves. So I know like when you push something. Wait. Pop off the stack and store any straight. Push onto the stack. So when you push something, then that ESP will definitely move. But why 4?
Corrupt converter says push EX rightward arrow sub ESP, for MOV ESP, EX.
Wait, what? Oh, push EAX means, okay. Subtract ESP? 4. Move ESP.
Corrupt converter says pop EX rightward arrow MOV EX, ESP add ESP, 4.
Pop EBX, move EBX. ESP. Oh, damn. Now, this is the time where like, I would love to see a Microsoft Paint drawing of how they're moving.
Corrupt converter says I'm saying that left and right are equivalent operations.
Oh, yeah, because you have an arrow saying that it's the same. Yeah, that's what I assumed. You're saying push EAX is the same as do subtract ESP 4 and then move EAX to ESP or something. Let me think about that. Push EAX. Subtract 4 from ESP.
Corrupt converter says subtract 4 from ESP, then store EX at address referenced by ESP.
Oh, and store EAX at address referenced by ESP. Oh, at the average. Oh. Wherever the address is referenced by ESP. Then store EAX. Oh yeah, that makes sense because you're pushing it onto the stack. So wherever EAX is, or wherever ESP is, put it.
Corrupt converter says other one. Store value at ESP into X, then add 4 to ESP.
What's other one? What other one? Oh, the second, the I know, the pop EBX, you're saying. That one. I just realized it right now. Okay.
Corrupt converter says other one equals pop.
Store value at ESP into EBX. I have to look at it. Store ESP. Where's that pop? At ESP. Oh, into EBX. And add 4 to ESP. I'm gonna have to think about that longer. Value at X, value stored at the memory address referenced by.
Corrupt converter says value
Referenced
at
by
X, rightward arrow value stored at the memory address referenced by X.
I'm gonna start back at the top and read it again. Move EAX4. So take 4, store into EAX. Okay, and then let's push EAX. So when we're looking at this at the beginning.
Corrupt converter says because I don't want to keep typing out memory address since it sucks to type.
Yeah, it's true. That's fine. Okay, now we're gonna push EAX. ESP.
Corrupt converter says value in is not equal to value at.
Subtract 4 from ESP. And store EAX. Address reference by ESP. Push EAX.
Corrupt converter says visualize the blocks.
I mean, why are we even in the first place? Just going from the first instruction to the second instruction. Why are we even subtracting 4 from ESP at all? Why are we moving ESP? Why do we even have to move it that far back? 4. Because we didn't add 4 things onto the stack to have to move it, I think. I'm thinking of the box. Value in not equal to value at. Okay. Oh crap! Oh.
Corrupt converter says because we're popping 4 bytes onto the stack, EX is a 4-byte value.
Oh, that's what that means. It means 4 byte value. I thought that meant. Wait, I thought that meant literally the number 4. 4 written in binary. Or am I wrong? Oh, wait. Yeah. Are you saying 4 is a 4-byte value? Because I forgot. How much is a. It's a number hold. It's wait, 4 bytes. Wait, what number shouldn't it be 4 bytes, right? Because 4 bytes is 8 bits, and you don't need 8, 16, 24. You don't need 32.
Corrupt converter says well EX can be
314-1592. Pushing what EX can be. Three, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5. It's 7. Wait, what? 3141592.
Corrupt converter says ESP4 reads 4 bytes to the left from ESP0.
So if you had said move, what did you say at the beginning? Instead of 4, if you had said like, I don't know, where was it? Move EAX 9, then it would be 9 bytes and not 4 bytes, or it's still 4 bytes. Oh wait, it's because so then it's 9?
Corrupt converter says sub ESP 9.
It would move by 9? What the heck? That seems weird. So we're not really working with actual like integers. We're just working with bytes. We're just moving bytes around and that's it. I don't know.
Corrupt converter says should I get invoice?
Man, typing does suck. Yeah, if you want to. Though I'm still gonna be doing like jumping around doing different things as long as that doesn't bother you. Like, doing like occasionally jumping in doing math and stuff. Okay.
Corrupt converter says I'll voice.
What were you gonna tell me? They were gonna tell me about
So So the
Yeah.
value in
Go ahead.
E
Sorry.
when you're pushing EAX onto the stack or popping some value off the stack, it doesn't matter what the value is stored in EAX. That's the value being pushed onto the stack. It could be 4, it could be 0, it could be negative 300,000. It doesn't matter.
That's what I thought.
What we're talking about with bytes, like that value doesn't have any real correlation to the number of bytes of anything. What matters for the number of bytes right now is ESP, because that's the thing that's pointing to the memory address on the stack. That's the thing that we're moving around. So like it points to like some number of bytes in memory, like some address in memory, and if you move it up by 1, it moves the byte that it's pointing to forward. Like it moves the pointer forward by 1, so it's pointing 1 byte further ahead.
Yeah, but I just don't
If you
understand
move
why.
it forward back,
Why is
you move it 4 back, it's 24 bytes further back. And what it's doing, what that line is doing there, is it's saying, okay, so move that ESP pointer 4
Yeah.
bytes to the back, and then in those 4 bytes, store the value of EAX.
But what
of
I
the
don't
A register.
understand, I understand that the pointer is moving 4 bytes, but I don't understand why are there 4 bytes on the stack? Like, why is there not like one? Like, why is there 4 bytes on the stack? Like, how many bytes get pushed onto the stack?
Because the EAX register is a 4-byte register. It's four.
Oh,
it's a 4
because
byte
it's a
number.
4-byte register, so always push
Yeah,
4
you
onto
can't
the
push
stack.
4 bytes
That's right.
into 1 byte.
Okay, that's fair. Okay, I see now. I'll have to remember.
Yeah,
that.
I think if it was AX, then it would be 2 bytes instead of 4 bytes because AX is a 2-byte register.
Oh damn.
I don't think it would be 1 byte if you did AH or AL, because I think push and pop are only 4 byte and 2 byte. They don't have a 1 byte version.
Okay. So this is why. So it's actually super important. If I'm going to be doing anything assembly, I have to know how many bytes each of my registers is, or otherwise I won't know how. I won't know where to move the ESP.
If it starts with E, then it's 4 bytes.
4 bytes.
If it doesn't, but it ends in X, then it's 2 bytes. Otherwise, it's 1 byte.
Okay. Wait. I'm gonna try to repeat that. E always 4 bytes, and then what are the other ones again? So I can try to memorize this.
If it's 2 letters, it ends in X, then it's 2 bytes.
Okay, 2
Otherwise,
letters
it's
and
1
an
byte.
X. Otherwise, it's what bytes?
Yeah, otherwise it's 1 byte. And there might be that's just for the main register. There might be exceptions for some of the other weird registers. I'm not entirely sure. Like
fine.
ESI and SI, I think are an EDI and DI. I think are the exceptions there. Like the DI is 2 bytes, but because those ones don't have 1 byte versions. But like for the main registers, the A, B, C, and D, that's pretty much the rule.
Okay, I guess I'll just start with the main ones because I'm basically just going to be using the main ones, right? Especially the beginning, the early challenge.
Yeah, so pretty much, you'll mostly be using A, B, C, and D. But you're probably going to run into some situations where you just need to have all that stuff in your registers, and you need more registers, so you use the S and D registers, the ESI and EDI. Those ones are, again, just regular registers you could just use for whatever. The tutorial said use those for specific things. Who gives a fuck? Just use it for whatever.
I just realized, I realized why I'm getting confused now, because I'm really bad at switching. I know, like, people sometimes they'll talk about bytes, and sometimes they'll talk about bits, and then if it's bytes and you're switching to bits, you have to multiply it by 8. People can just switch between them, but I keep forgetting, like, we can say 4 bytes, or we can say 32 bits, because I'm used to, like, 32 bits, so that's why I was getting confused, but it's
So one thing that's going to be important for like the memory is you cannot read by bits. Like you have to read a byte, 2 bytes, or 4 bytes as a whole. So like if I increase ESP by 1, I'm not moving it up by 1 bit. It's pointing 1 byte forward. So 8 bits, because pretty much it's like an array of bytes. That's pretty much what your reading is an array of bytes. If you increase your index by 1, it moves 1 byte forward. That's basically what it is.
So you could even say then, because it's just what you said, it's an array of bytes. So the pointer itself can only move 4 bits at a time. Like you can't divide. You can't have what you said. Yeah.
It moves 8 bits at a time.
Oh, 8 bits. Sorry, I'm dumb. I said 4 bits. I meant 8 bits at a time.
Increased by 1 is 8 bytes. I mean, you can't put a decimal number in there because then it's trick. If you try to add 0.1 as a float into there, you're gonna have huge problems. Massive problems.
Heat problems.
As in it's gonna end up somewhere random.
I thought you were gonna say the computer explodes, because that's cool. How make computers
Your
explode.
program might crash.
Okay.
If you do like a if you do like a regular binary addition with the floating point number 0.0.2 or something, or 0.125, that's 1/8, then you're gonna have some huge problems because it's gonna be a really weird number that it gives you.
Weird.
But yeah, so that's what that whole thing is. It's the number 4. We're subtracting 4 from ESP and adding 4 to ESP because we're pushing and popping a 4-byte value off the stack and onto the stack.
Pushing and popping. It sounds like the name of some like old dance move. Like, I don't know. Let's do the push and pop,
And also,
everyone.
it's gonna be this other weird thing. If you try to like push, I wonder if it'll let you just push the number 4 onto the stack without specifying the size of that number. So one of the things that you might run into is if you try to push the number like some constant onto the stack, it'll either assume it's a certain size or it'll give you an error saying you need to specify the size of the operand.
Oh.
So
Okay.
basically, one of the problems you can run into is, and it's also actually a better example is if you try to store something in memory. So like if I said move and in square brackets ESP and then I put the number 4, I'm gonna get an error because it says, do you want that 4 to be a 1-byte, a 2-byte, or a 4-byte value? Because the interpreter doesn't know how many bytes you want to move there, or how big of the number you want to
Why
store
would it
there.
not know? Because it should be 4
it's
bytes.
4 because basically if you're trying to store 4 into memory like that,
Like the actual number 4?
It could be a 1-byte. Yeah, the actual number 4. It could be a 1-byte value of 4, or a 2-byte value of 4, or 4-byte value of 4.
Oh, yeah, that's
It'd be
true.
the same number in all those different cases, but it could be different sizes of that number. So it's like, well, do you want to store it as a 4-byte number or a 2-byte or a 1-byte number?
Okay.
In that case, what you do is you use the D word keyword. You use like D word or byte to specify the size of the number. I forget, you either put that on the 4 or you put that on the memory. I forget. Maybe it matters, maybe it doesn't. I'm not sure.
Okay.
It might matter.
Okay. Well, good to know.
Yeah, it's good to know.
Very good to know.
I mean, you'll know because if you try to do that without specifying the size, it won't let you. It'll basically give you a compiler error.
Oh, cool. I love those. I'm so used to those. I eat compiler errors for breakfast, lunch, and dinner.
Yeah, it'll give you something like when you try to store 5.0 inside of a float in C#, it'll say you can't store a double in a float. It'll be something like that.
Wait, that's because isn't a float like a lot more bytes than a double? Or is it?
No, a double is 8 bytes, a float is 4 bytes.
Oh, damn! It's less bytes.
This is why it doesn't let you implicitly convert.
I'm dumb. Double, sorry.
To float. Yeah, it's why it doesn't implicitly let you convert from double to float, because if you do, then you can lose information. So it makes you say specifically convert to float.
Mm-hmm.
Who's helloing?
I was getting mixed up. It's this Genesis.
Genesis 31 says
hey.
hello.
Pretty good. It's called the current stores the. Oh wait, I was looking at this part. Oh, that was funny that you mentioned like the whole like whatever you were saying about the stack not zeroing, because it just so happened that in the article I read about something zeroing on the stack, which ended up being like the opposite. But I think you were talking about something different.
Yeah, I would assume, yeah, the kernel most likely does that, like as a security measure. That's what I would assume. Because
how is this security risk?
If you don't zero out the stuff on the stack, then other stuff, like other programs, you won't have this problem on J0. But other programs that then might have access to that memory later on, they can read what you stored in the stack, and they might be able to get information that you don't want them to have access to.
That's fair.
You're right. That would be why the kernel zero is part of the stack, because that's information that's just for the kernel operating, and you shouldn't have access to that information.
Okay, that makes sense.
As a user space program, you shouldn't have access to that
Genesis
information.
31 says, WTF is this?
We're talking about like low level or stuff. That's my explanation.
Yeah, they're learning about how computers work, so that way then they can use how computers work to code in
Hell yeah!
Python.
You're much better. That was much more well spoken than what I just said. But yeah, that's what I'm doing. Thank you. You're officially my spokesperson now. You explained that well. But yeah, that's what I'm doing. And I'm also taking part in Corrupt's experiment to try to learn some assembly and see if that significantly improves my high level programming, thought process, problem solving skills.
Yeah, they've got like we've got like a month or 2 months or something to figure it out before I get shipped off to Marines boot camp.
And then Corrupt's gonna become
Then I'm
slow as
there. I'm there
hell.
for yeah, and I'm there. I'm gonna be there for 3 months. On the 31st day, on the 31st day, I get put in the gas chamber. So I was actually there's someone who was there at MEP, so I was talking to who was
Yeah.
It was very fun to talk. They were re-enlisting to the Marines, so they've gone through all the stuff
Cool.
for me. They're telling me some good stories.
Did you?
Now,
Did
one of them,
you?
one of the funny things I told a bunch of my family as well. It's like one of the funny things
What?
they told me is if there's ever a plane flying up ahead, never ever look at it.
Why?
So what he said is there's a one time when he was in boot camp, there's this guy who was right next to him who looked up at the plane as it flew by, and the drone instructor, he said, "Swear to God, you just spawned right next to him and just went right by his vision, right up to the recruit that looked up." And then he asked the guy, he was like, "Where's that plane going?" And they said, "This recruit does not know, sir." And the drone instructor said, "Let's go find out." So they made them chase after the plane.
Holy!
And
Oh
they're
my
gone
god!
for a good couple. They're gone for a good couple hours. And he said you could hear their screams get quieter as they got further away.
That's intense.
So basically, what happens is if you look up at the plane as it flies by, the drone instructors are going to make you chase after it.
Okay, cool. That's like me asking a question about like, oh, what is this computer language? And it's like, well, you're gonna learn it right now. And then it's like, well, damn, I wish I never asked. Like, crap.
Yeah.
Jesus. It's just too much. It's too intense. Oh,
Yeah,
Hook,
but
did you?
your teacher's talking about Python, and then you said, "Hey, I heard about this thing called brainfuck. What's that?" And you're like, "All right, it's time to learn.
Oh,
Let's
now
learn
you
about
have to learn
brainfuck.
it because you asked the
Let's
question.
learn about brainfuck." For the next 3 weeks, you're learning about brainfuck.
And instead of learning instead of learning Python, you just learned that instead. That's what you have on your resume. Like literally, it's like all I know how to use is brain.
Well, if you know how to use brain, that's probably good.
Well, you know what I mean. Anyway. Oh,
Well, you said, it doesn't matter what you mean. It matters what you said.
I guess you're right. I was gonna ask you. I mean, did you remember to? Did you ask the guy for his like contact info so that you guys can like stay friends?
I did not.
Aww, I'm sad. You should try to like
Yeah, I should've,
make contacts with people, and so then you have like a good list of people you can reach out to and be friends with. It's worth it.
Yeah, I should have. But also part of it was that like the entire time that I saw him was pretty much during the time when we didn't have access to our phones.
Oh yeah.
We
Well,
weren't
you
allowed to
have a
have
pretty
our
good
phones
memory. I
on.
bet you could have memorized it. Honestly, be like, hey, I was wondering, like, do you have any socials we can? That's a good way to ask it, by the way, because it is awkward asking people that. But you can always ask, like, oh, do you use like any like? Do you have? You can just say like, do you have any socials? Like, do you like to use Discord or?
Yeah, Discord. Yeah, I'd be like, do you have Discord?
Oh, yeah. That's the easiest way to do it. Like, do you have Discord, bro?
Yeah, Discord. And they're also talking about this one guy who was like especially bad. It was like really annoying and causing them a lot of problems. So they basically went whole full on Full Metal Jacket on them, and did like that one iconic scene from Full Metal Jacket where they covered the guy in blank. They filled their socks with soap bars, covered the guy with a blanket, and just started beating them with the socks.
Okay.
And the guy I was talking to was like, you guys watch too many movies. There are so many better and funnier ways to do this, but it worked. So it did what it was supposed to do.
Mm-hmm.
And they're also telling me about the rucksacks that we have to put on. Is that I have to brace myself before I swing that thing over onto my back, because if I don't, it's gonna pull me down with it, and I'm gonna fall on my ass.
Which is not
Which
the end of the world.
apparently is something that I'm going to see when other people are doing it. There are going to be people who end up getting knocked on their ass from pulling that over their back.
Mm-hmm.
So,
Or
just
worse
be prepared for
things.
that. Yeah, he said that like boot camp is like one of the funniest places on the planet, but you're not allowed to laugh. So whenever something funny is happening, he has to cope with it by pretty much like pretty much pretending to be angry at it, and like during pretending to be angry, and like muttering under their breath, like stupid freaking like you stupid, like I guess to pretend to do that in order to avoid laughing. Because
Mm-hmm.
if you laugh, you're gonna be pushing the ground for a bit.
Yeah.
Yeah, it's fun stuff. I'm looking forward to having a lot of good memories that I can look back on and tell stories about after I graduate from boot camp.
Oh, I bet you'll have a ton of great
Yeah.
stories.
Yeah, and then when I get out of boot camp, you'll be better than me at everything.
No. If only. Actually, I might even be. My brain might shrivel up to even worse than before I met you because if you're gone, it's like who's there to like push me to like do all this, the extra work. I'll just like, you know,
Bully the other people in chat.
bully the others.
Make them your slaves. Make them teach you how to do things.
I can't. Anyway, I'm kind of wondering though if it does zero. It talks about. It's just weird how it says like in this part where it's like it takes the values of the registers, puts them on the stack so that it can restore them later, but then it zeroes them out. So then how does it restore them if they're all zeroed out? Like how does it find that
It
information? Yeah.
let me read what this says.
I feel like maybe they just did a bad job explaining.
Stores the current value of the registers to the stack to be restored when switching back to user space before
This
returning
part,
to
it
user
restores
space.
the registers, which are now zero.
To be restored when switching back to user space before returning to user space, the kernel zeros this part of the stack. Okay, so
Oh,
so what it does is
yeah.
it puts them on the stack and then does its stuff, and then it returns them to the original registers, and then after doing that, it zeros the stack. So it's just order of operations that you're getting confused on.
Oh, I'm
It
getting okay. It puts
it,
in the
it puts them
registers
onto the
and then
stack
zeros them.
temporarily. Yeah, and then when it puts them back in the registers, then it zeroes out the stack, and then it goes back to user space.
Okay. Yeah,
Just
they
order of
just.
operations. That's all.
Yeah. Well, I think it's because they explain the order of operations very poorly. But okay, I see. Restores the registration now zero. The instruction pointer is now starting point. New program. The interpreter current process has been replaced. Yay. The translator in your computer. Ooh.
I think they got a whole lot of like drawings for all this stuff.
I know they need more. There's not enough drawings, but
Yeah, see, I'm not artistic, so I can't do those kind of drawings.
yes, you can. All the drawings you did in Microsoft Paint, I thought were very good and very helpful. Mm-hmm.
Well,
Shukot says, what is this about in simply term?
it's squares and lines and
It's about
letters.
how the computer executes a program. That's in the simplest terms. That's what it is. Like, what steps does the computer take when you click on a .exe? Like, what is the computer doing? That's about it. Up until now, every time I've talked about reading and writing memory, it was a little wishy-washy. Yeah. For example, ELF files specify specific memory addresses to load data into. So why aren't there problems with different processes trying to use conflicting memory? Oh yeah, specific memory addresses. That's true. Why don't they fight with each other? Why does each process seem to have a different memory environment? Also, how exactly did we get here?
Okay, so thinking about this,
Are you making a guess?
yeah,
Shukot
having
says
two
input
processes
slash
read the
output or
same
while.
memory. It's asking why aren't there problems with that? There are.
LOL?
And it's called race conditions.
Oh, it has a name. What is it called? Race or what?
Race conditions. So pretty much imagine this.
Yes.
So let's say there are certain operations that are called atomic operations.
Holy hell.
And there are other operations that are called not atomic. Basically, what an atomic operation is it means you can't break it up into smaller parts, and you can't you can't interrupt it in the middle of it. So,
Oh, it has to
let's say
finish
for
it.
example, if you were storing a string into some part in memory, like you're storing it like one character at a time or something, theoretically, another program could read that while you're in the middle of storing it and read halfway through your store while you're saving it.
Lol? Like, it makes sense,
And what
though.
happens is they get part of the string, but not the whole string, and it's all corrupted data.
Okay.
That's one of the
Cotton
problems
says
that you
K.
can get when you have multiple programs accessing the same memory.
Okay. So, like,
And that's also a problem you get with multi-threading.
oh, so it's like the more things you have open, the greater the chance that something can happen like that, like a conflict of memory, where it like makes, you know,
If
it
they're reading the
F's up
same
to your
stuff,
programs that are open. Damn.
yeah.
That's good to know. I like how it's just like memory is fake. Fake. It's like we should make like an exposed video on memory and like call it out so that it like, you know, gets canceled. Cancel memory, let's cancel it. Memory exposed, all capital letters. Also, how exactly did we get here? We understand that execve is a syscall that replaces the current process with a new program. But this doesn't explain how multiple processes can be started. It definitely doesn't explain how the very first program runs. What chicken process lays, spawns all the other eggs, other processes.
The power button.
Okay. We're nearing the end of our journey, thank God. After these two questions are answered, we will have a mostly complete understanding of how your computer got from boot up to running the software you're using right now. Well, yay. Memory is fake. So, about memory. It turns out that when the CPU reads from or writes to a memory address, it's not actually referring to that location in physical memory, RAM. Rather, it's pointing to a location in virtual memory space. Okay? The CPU talks to a chip called a memory management unit, MMU. Oh, look, there's Q. Oh, wait, where is it? Is it the MMU? No, it's the CPU. The MMU works like a translator, with a dictionary that translates locations in virtual memory to locations in RAM. When the CPU is given an instruction to read from memory address, I'm not going to read that whole thing, it asks the MMU to translate that address.
No, they're the TTS right now. You got to read the whole thing.
Okay. No. The MMU looks it up in the dictionary, discovers that the matching physical address is, oh damn, so this could be what it says, but then this is the real address, and then sends the number back to the CPU. This seems really unnecessary. But anyway, the CPU can then read from that address in RAM. Hey, what's blah 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 blah? This book says pointers. Nice.
Pointers 0, 0 to
Zero. Cute. Wait, what did it say? What lays all the other eggs? Is it not?
To my knowledge, the way the computer starts up is it has like a specific. I think it has like maybe like a specific chip on there that stores read-only memory. What it does, and that read-only memory is the code. Like it's like very small amount of code that it uses to start up the rest of the code.
Oh damn.
So it might be like 1 kilobyte or something, or like 500, like 512 bytes or something like that of machine code that you can put there, and you need to work within that in order to start the other things, like start the other stuff on the computer.
Like it does like the kind of the beginning stuff, laying out the foundation so that things don't get mixed up.
And then from there you work your way up to starting the rest of the computer.
That's cool. Maybe it's about I wonder if it's about to say exactly what you did, because if it does, then it's like you were right with your guess. When the computer first boots up, memory accesses go directly to physical RAM. Okay. Immediately after startup. Oh, like literally the computer boots, I say. The OS creates the translation dictionary and tells the CPU to start using the MMU. That's cool. This dictionary is actually called a page table, and this system of translating every memory access is called paging. Wow. Entries in the page table are called pages, and each one represents how a certain chunk of virtual memory maps to RAM. These chunks are always a fixed size, and each processor architecture has a different page size. That makes sense. 8664 has a default 4, then it's kilobyte. This kilobyte? Why is it
Yeah.
written as kib instead of kb? Page size. Meaning each page specifies the mapping for a block of memory, 4096 bytes long.
Honestly, that kind of reminds me of like one thing that my shop teacher
What?
had told me about, how sometimes you have different people write different parts of the same thing, and then you get weird stuff where that's written differently in different parts of the document.
Oh.
But I don't know if this is like multiple people writing this or if it's just one person. And if it's just one person, it could just be that they write it slightly differently in different contexts.
Interesting. Oh, which is maybe why they use like a virtual one, so that it can handle like different. I don't know. Like it can be translated and it makes sense.
Examples like
The
people was
table.
giving us is mostly in like instructions for like food, right, cooking food or stuff, and on some packages they'll call something one thing in one part, and then it will be called something different in a different part. I forget. Like I think I found like an example on like a Pop Tart box or something. I don't remember what it was though, but it was stuff like
Okay.
that.
Okay. Oh, okay. So, okay. I see.
Okay.
Each processor is different. KIB size. I don't think. Well, yeah, this is kilobyte. I think they just wrote it as KIB, which is weird. Mapping for a block of memory. Each page specifies a mapping for a block of memory. Okay. In other words, with 4 kilobyte pages, the bottom 12 bits of an address will always be the same before and after MMU translation. 12, because that's the amount of bits needed to index the 4096 byte page you got post translation. That is not intuitive.
N_sweep says
Oh, hi,
early
N_sweep.
start today.
Yeah, I'm like, it's a more. Well, actually, I used to stream even early. I used to stream at like 12 o'clock my time, which is more like 3 Corrupt's time. I've been streaming later recently.
That sounds like a good idea.
I should stream a lot earlier, though. I don't know.
N_sweep says still gonna be on in 9 hours when I get up.
To be honest,
LUL.
no, to be honest, hopefully not, because previously I was kind of staying up all night, and then I was like tired during the day when I have to get stuff done. So I'm trying to start sleeping more during the night like a normal person, ideally.
No more phasmophobia at 5 a.m.
Oh, well, maybe every now and then. That is fun. I like playing Phasmo with you.
N_sweep says hopefully not is right.
Sleep is important.
Sleep is
Yeah,
important.
it is.
What do you mean?
When I'm low on it, like I do feel it. It might take like a week or so, but eventually it catches up to me, and I'm like really tired. It's actually part of the reason, but not the whole reason. I was just really busy. But part of the reason it's kind of been like a day or two since I streamed. I was like catching up on my sleep.
The way I see it, if it takes you like a week or two in order for it to start catching up to you, that means you get a week or two to do it.
N_sweep says I highly
guess I'm
recommend a
efficient
book called
then.
Why We Sleep by Matthew Walker.
Oh, well, why read that when I can just actually sleep for real? You know?
Yeah, who needs to know why we sleep?
Yeah, I'll
Just
just
do
sleep.
it. Just do it when you need to.
I'm teasing though.
That's like a lot of effort.
N_sweep says
Oh, there are some.
LUL.
Well, speaking of sleep, I just want to point out that there are some like really interesting theories on why we sleep, and one of them that I think is the most interesting, that I found most interesting, is that. Oh, well, actually, no, it's not why we sleep, but why we dream. That's a different topic. But one of the reasons why we dream, apparently, is like the way the brain works is it naturally, like, connections that aren't used naturally fade. Like, that's just how the brain can adapt and learn. And so it's just built so that if we don't access certain pathways, connections fade. But they actually fade really freaking fast. Like, they start fading within like 6-7 hours. Like, certain connections will begin to fade. So the idea is we dream because we want to keep certain connections, even though we're trying to sleep, but it's still important that certain connections are maintained, especially the visual system, because most of our brain is specifically for the visual system. And if we F that up, we're screwed. So the brain is very careful about trying to preserve it.
N_sweep says yeah, and the brain gets bathed in spinal fluid while you sleep.
Yeah, and it cleans itself too. It's beautiful. That new system that they
Oh.
discovered. I forgot the name. The something something system, but it's like a whole new like system, which is
What
cool.
about like nightmares?
Not Mars. Well, you know.
Can I get rid of those a little bit?
Happens. But yeah, where was I? Oh yeah, 12 because the amount of bits needed to index the 4096 byte page you got. You get post transition.
Yeah, 4096 is 12.
I don't. Why is 12 like? Why would you need that amount? Yeah, I don't know. It seems really arbitrary to me. Like they're making it sound like 12 is such a special number, but that just seems really arbitrary.
Probably,
Does it not seem arbitrary to you? Does it seem like it has a pattern?
your options
Why
are.
12. What would you say the options are?
Let me think about this. I feel
Okay.
like your options are like 4, 8, 12, 16. Like a multiple of 4. I'm guessing 12 is just hits some sort of balance
Okay.
between it probably hits some sort of balance between giving you enough for most situations and not giving you too much for pretty much any situation. It's like if you need more, you'll get more, but if you don't need more, you're not getting too much.
But wait, oh,
That's probably
okay. But the meaning of
because
index.
basically, you don't want to allocate 2 gigabytes to every tiny program.
Oh, because that would be excessive.
Yeah, that would be really excessive. I think that's what I think it is. It might be kind of arbitrary, but I think it's just to strike a balance. So that way you don't have there's not a whole lot of excess use.
I mean, it talks about indexing. So when you talk about indexing, just in general, doesn't that mean ordering things in a specific order? So these 12 bytes determine like the order that those addresses are listed. Is how I interpreted it.
Those 12
something.
Those 12 bits are pretty much those 12 bits pretty much are like your index in the page, like your index in the 4096 bytes.
Oh, this part.
And then the other ones.
But what is an index?
Are index in the table. So like those
what
ones.
What page it's on? It's like saying
page.
which page you're on. You're on page number 3 or page number 5. That's the index. Exactly.
The numbers on the right, those index the byte inside of the page. That's my guess. And the numbers on the left index the page that you're using.
The actual.
That's something like that.
Wait, what does that mean? Number inside of the page, though. I get the one on the left. Like it tells you the page. The one on the right. It's like what the.
Yeah, the blue ones. So like you have 4096 bytes. Those blue numbers there index one of those 4096 bytes.
Where's
and
blue?
Then the black ones index the page that the CPU is going to read.
Dude, that is definitely green. I'm just saying, it's not blue. It's green.
Close enough.
Says
okay, that's fair.
It's greenish bluish. I just picked. It's neither all green or all blue. I just picked the one.
No, it is like definitely green. Oh yeah, good night. Night and sleep. Get good sleep. Remember, sleep's important. So yeah, get enough of it, and don't stay up all night reading Why We Sleep. You should just sleep. I recommend. But thanks for stopping by. I love seeing you. So, no, not aqua. It's green. Okay. Wait, but what did you say you think it is? Sorry, I got distracted by the color.
If you imagine you have like this big block of 4096 bytes.
Yes, I'm imagining it. 4096 bytes.
That number in the green blue is an index of those 4096 bytes. So it just picks one of those or 4 of those or whatever, how many of those to read. And then the black is saying pretty much saying like in the dictionary which page are we reading from, and then that tells that kind of gets translated to the RAM.
Isn't it like this one on the right is saying which page are we on? The one on the left saying which word are we looking up? Which address are we going to?
No, the one on the right. No, you see the lowest 12 bits indexes the page. So that's what I'm like that. That would be the 4 kilobytes of the page. The one on the so that index is inside the page. That's what that says. Like that's pretty much what that is. The index is inside the page. That's what it means.
Okay. So it's like
So
this is
like,
the
yeah, so
page, and this is the. Oh
the
wait.
numbers on the right. Yeah, the numbers on the right are saying where inside the page. The numbers on the left are saying what page.
Oh, where? Oh, okay. Oh, so this
Yeah,
one's
where
more
in the page
specific.
and
That's
then
so
what page.
okay. Oh, index is the page means where on the page. Okay, left one's what page are we going to? That's what. Okay, that's what you're saying. Okay, thank you. I hit it. Reverse. 8664 also allows operating systems to enable larger.
My means of explaining that is to say the same thing over and over until it makes sense.
Well, finally it did. It was effective, so it's fine. You know, you gotta just keep like restarting the computer until it does what you want, and then you're good. Yeah, keep running it, and then eventually you won't get the compiler error anymore. It'll go away.
Yeah, just keep writing the same code eventually.
Yeah, over and over and over again. Yeah, because remember, there's a small possibility that like things can quantum teleport and atoms can shift and stuff, and then so if you run it enough times, it just might work
so
one day.
I mean, you
The
have
code will fix
you have a
itself.
practically zero chance, but you don't have a literally zero chance of your code doing what you want it to do.
Exactly. It's practice. Just keep doing it forever and live forever and keep doing it and do it and do it over and over again. It will work one day.
I mean, my computer could be running Doom right now if the quantum waves worked in my favor.
Exactly. Which would be hilarious, especially if this is doomed. It's like, oh,
yeah,
must be a sign from the universe. More portion that's translated by the larger the page. What would I? Oh yeah. What is this? What is MIB? Millibyte? Well, GI is
megabytes.
Shouldn't it be MEB? Because mega is spelled as ME. Like this is stupid.
It's stupid. It's
2 megabytes. Megabytes. Why are they writing it like this? Which can improve address translation speed.
Maybe they just want you to almost say the N-word.
I know. But increase memory fragmentation and waste.
I think because you said that you're banned immediately. That's what's going on. You're banned.
Sure. The larger the page size, the smaller the portion of the address that's translated by the MMU. Wait, as the page size gets bigger, the smaller the... Interesting.
Civitatum says "'Tis not stupid feels dank man, quite the contrary."
The larger the smaller the portion of the address translated. The page table itself just resides in RAM. While it can contain millions of entries, oh my god, each entry's size is only on the order of a couple bytes. So the page table doesn't take up too much space. I mean, that seems like a lot of space, but whatever. Smaller the portion of the address is
Civitatum says a megabyte should be 10 to the power of 6th, whereas MIB denotes megabytes 2 to the power of 20th.
Oh, it's not a megabyte. It's a meB byte. That's so cute. meB byte. Whereas I've never heard of a meB byte. 2 to this 1. Oh my god, that's huge then. Well, that sounds really big. meB byte. Have you heard of that before, Grub? So then this is a gigabyte? I don't know. And then this is like...
Civitatum says megabyte.
I guess that must be their way of getting around the meaning, the literal meaning of mega and giga and all that stuff, and then kilo, because like in measurement that is it's with a base of 10, but with computers it's basically, I mean, nobody ever says maybe byte or gibby byte. Nobody ever says that, but.
No, literally, no one fucking says that.
That might be like the technical way that they get around calling it mega and giga because, you know...
Oh, it's technically incorrect.
It's not a billion.
Because it's not really... Oh, yeah, it's not really 1,000. Like, kilo, it's like 1,024. Oh, damn. We have to be technically correct. We can no longer say megabyte. We have to be like, meB byte. That's hilarious. I wonder what these... How I say these all. Like, kibi byte? I don't know.
Kibi byte.
Kibi byte? Gibi byte? I don't know. They're so funny.
Kibi byte.
Gibi byte. I'm just imagining what they sound like.
Gibi byte.
Gibi byte. Oh, whatever. This is crazy. The page itself just resides. Okay, I read that. Blah, blah, blah. To enable paging at boot, the kernel first constructs the page table in RAM. Then it stores the physical. So this is why, maybe part of the reason why it takes time for your computer to start up,
And
among other
Stucky says
reasons.
what intarnation is going on har?
Yeah. So apparently, like the words like megabyte and kilobyte are technically inaccurate because those are for powers of 10, but we're working in bytes. So you're supposed to say like meB byte and GB byte. Imagine your
Civitato
friend
says
says
at
to you,
Stucky07.
your friend shows up and they're like, "Oh, I just downloaded a 5 GB byte file." You'd be like, "What the? What is wrong with you?" Okay. Anyway, I love it. Sorry. This is cool. Maybe I'll clip this. What time am I at? Oh wait, no, you guys wrote stuff in chat, so I'll be able to find this. Never mind. To enable paging at boot, the kernel first constructs. Oh, I read that. Then it stores the physical address of the start of the page table in a register called the page table base register. Oh, this is probably one of those registers that were grayed out when I was reading about assembly, and it was like not telling me what all the names of the registers are because you're not supposed to like. This is only for the kernel, probably. Finally, the kernel enables paging to
This is
translate.
grayed out. Wait, where is it grayed out?
Converter
Remember?
says boneless byte.
When we were
No.
reading the the tutorial point thing about assembly, it didn't give me the
Oh,
name of
maybe.
every register. It just gave me the name of like a lot of them. But there were some that it's like the names were missing because they were. I guess it wasn't important to know. That's my guess.
Yeah. I'm just wondering if that's like actually a thing. Well, it must be. It must be. Maybe it is.
What's
I
the
don't know. I
thing?
haven't.
This page table base register?
I was wondering if that's like an actual register in the language, or if that's
Oh.
just like something added by through software.
Well, it's part of the kernel, so I don't.
Well, the
Oh.
kernel is software.
Oh, so maybe then software. Oh.
Yeah.
Well, what is assembly then? What does that count as?
Assembly is also software.
Okay.
That's like a register that's added through software and is not just like part of the CPU or anything.
Oh,
Like,
I feel like
the registers are part of the CPU. I'm wondering if like PTBR is strictly like a software related thing.
my
Like, it's
guess.
just added through software.
I don't know, but my guess is yes. I think it would be part of the actual because I think that's what we're talking about. Like part of we're talking about like pieces on the chip itself. That's why they were. That's just what I guess is. Like they didn't really explain.
I don't know.
Sure.
Maybe it is, maybe it isn't. I don't know.
Yeah.
I can't be bothered to figure it out. It's too much
Me
work.
neither. It's not.
I
It's
don't
not
know.
important. I
Just wanna figure
guess.
it out.
But yeah, finally the kernel enables paging to translate all memory accesses with the MMEO. On 8664, the top 20 bits of control register 3 C control register 3 function register 3 function is the PTBR.
So are they using a different? So wait, they're using different registers for this then.
Why
So
do
it
you think
isn't.
so?
It is pretty much like software implementation.
Really?
That's what it sounds like.
What made
Yeah,
you
it
think
sounds
so?
like software implementation. It sounds like they're using a different register, a different like register on the CPU as the PTBR.
But that's still a register
But they're
though if it's on the
using-
CPU.
yeah, that's what they're doing. What?
That's still a register though if it's on the CPU, right? I mean, it's register.
Yeah, but what I mean is PTBR isn't a register on the CPU. That's not like a dedicated register on the CPU for PTBR. It's just they're using a different register as the PTBR.
Oh,
register.
okay.
So it
Yeah.
sounds
Maybe.
I could be wrong, but that's what it sounds like. Sounds like software.
Okay. Bit 31 of CRO, designated PG for paging, is set to 1 to enable paging. Okay. The magic of the paging system is that the page table can be edited while the computer is running. This is how each process can have its own isolated memory space. When the OS switches context from one process to another, an important task is remapping the virtual memory space to a different area in physical memory. Oh crap! That's cool. So it's just I think that makes sense. Like it by itself, it's automatically choosing which area it gets put in, but the program itself is actually using virtual memory. But the computer decides where do we want to put the virtual memory in the physical space. Like you're not actually you're working with virtual memory the whole time, and it's the computer's job to decide where it wants to map it, which makes sense. Because then, so things can't, like, accidentally overlap. Let's say you have two
Yeah, I
processes.
imagine it's probably
It's
easier
cool.
to work with that, like from a security standpoint, than it
Mm-hmm.
is to just have everybody read the exact same memory directly. Because if
Yeah.
everybody's reading the exact same memory directly, well,
You're right.
how do you easily and effectively check without slowing the hell out of the computer whether or not someone is reading somewhere they're not supposed to?
Oh, yeah. That's true. Then it
And
would be
also, how do you manage the memory of the different programs as the programs need more memory? Because if you have like a program that uses some memory somewhere and they need more memory, but the
later
memory
on.
after is a different program, how do you break it up?
That's true.
Well, paging has to do that.
Yeah, you need to be constantly able to, like, you're right, shrink it or grow it depending on what you're doing. All the different
Hmm.
programs that are running at the same time.
Yeah, yeah, yeah,
That's cool.
yeah, yeah, yeah,
Um,
yeah.
yeah, yeah. This is how when the OS switches context from one process to another. An important task is aware of that. Let's say you have two processes. Process A can have its code and data likely loaded from an ELF file at whatever the hell this is, and process B can access its code and data from the very same address. Those two processes can even be instances of the same program because they aren't actually fighting over that address range. The data for process A is somewhere far from process B in physical memory and is mapped to blah 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 by the kernel when switching to the process. Mapped to the. Okay. So process A, process B, physical memory somewhere else. Even being Okay. Aside, cursed elf fact. Oh no. It's gonna be cursed. In certain situations, binary format elf has to map the first page of memory to zeros. Some programs written for Unix System 5 release 4.0 and OS from 1988, which I'm not using, that was the first to support elf, rely on null pointers being readable. Oh wow. And somehow, some programs still rely on that behavior. It seems like the Linux kernel development implementing this was a little disgruntled. Oh, Linux kernel dev implementing this was a little disgruntled. Why this, you ask? Well, Unix system version release 4.0 maps page 0 as read only, and some applications depend upon this behavior. Since we do not have the power to recompile these, we emulate the release behavior. Sigh. Sigh. Okay. Security with paging. Oh yeah, you mentioned this, Corrupt, that like there's a security thing with this. Like it's probably good for security. The process isolation enabled by memory paging improves code ergonomics. Processes don't need to be aware of other processes to use memory. Okay, but it also creates a level of security. Processes cannot access memory from other processes. This half answers one of the original questions from the start of this article. If programs run directly on the CPU and the CPU can directly access RAM, why can't code access memory from other processes? Or, God forbid, the kernel? Remember that? It feels like so long ago. Kinda does. What about that kernel memory, though? First things first, the kernel obviously needs to store plenty of data of its own to keep track of all the processes running, and even the page table itself. Every time a hardware interrupt, software interrupt, or system call is triggered, and the CPU enters kernel mode, the kernel code needs to access that memory somehow. Linux solution is to always allocate the top half of the virtual memory space to the kernel, so Linux is called a higher half kernel. Windows employs a similar technique, while Mac OS is slightly more complicated and caused my brain to ooze out of my ears reading about it. Amazing. So, yeah, Linux and Windows are more similar. Memory for executing program, kernel space. Oh. Fix error for everything kernel related. Top half to the kernel. Okay. Oh, so this must be halfway, and then this is like the max it can be. Yeah. It would be terrible for security if userland processes could read or write kernel memory, though. So paging enables a second layer of security. Each page must specify permission flags. One flag determines... These are pages? Okay. One flag determines whether the region is writable or only readable. Another flag tells the CPU that only kernel mode is allowed to access the region's memory. This latter flag is used to protect the entire half kernel space. The entire kernel memory space is actually available in the virtual memory mapping for user space programs. They just don't have the permission to access it. Oh, damn. Page table entry. Oh, present, true, read, write, read only, user kernel, all modes. Dirty. I know. I said that too. Dirty. Access. True. Interesting. I like how they didn't explain.
Says the base physical address of the paging structure hierarchy is contained in control register CR3.
Oh, do you know about this stuff? SPQ? Oh, damn, that's cool if you do. I'm learning about all this for the first time. All these things are completely new. Paging lore is too deep. I don't understand what this... What is this talking about?
Civitatum says paging lore is too deep. I don't understand.
Well, it did. It mentioned
PTBR.
It mentioned PTBR up above. Like it was like right. I just said, where is it? Here. PTBR stores a physical address at the start of the page table in a register called the page table base register, and then it talks about CR3 too. Top 20 bits of control register 3 function as the PTBR. So I think you're on the right track, because that's what, yeah. Oh, it was a quote from Intel Docs. Oh.
So what does that mean? That they don't know what they're talking about? They're just quoting?
I don't know. But they've heard of these things, so at least they were reading the Intel Doc. So they know more than me. Access true. The page table itself is actually contained within the kernel memory space. Oh, wow. Oh yeah. Oh wow. Okay. When the timer chip triggers a hardware interrupt for process switching, the CPU switches the privilege level to kernel mode and jumps to Linux kernel code. Being in kernel mode, Intel Ring 0 allows the CPU to access the kernel protected memory region. The kernel can then write to the page table, residing somewhere in the upper half of memory, to remap the lower half of virtual memory for the new process. Wow. When the kernel switches to the new process and the CPU enters user mode, it can no longer access any of the kernel memory. Just about every memory address goes through the MMU. Wow. Interrupt descriptor table handler pointers. Those address the kernel's virtual memory space as well. Hierarchical paging and other optimizations. 64-bit systems. Did you know this whole thing, all of this that I'm reading, did you know this was written by a high schooler? Isn't that crazy? They were in like a hack club or something, and this was their project. Like, holy hell.
They were in what club?
What'd you say?
They were in what club?
They were in some kind of like computer club, and so this was like their project they were doing for it. Like a hack club.
What grade
or
are they
something.
in?
I don't know. I just know like that it was.
Yeah, I mean that's
the author.
See,
was.
this is the sort of thing that happens when you actually have people, when you actually have school like teach, you know.
Oh, like people actually go off and do their own and stuff, you know, is that what you're saying?
Well,
like,
I mean, yeah, when school actually
motivated.
teaches, then you have people do this. You have people do this as high school students.
Yeah, it's just like part of their club.
But, you know, like a lot of schools now, they don't their focus isn't to teach you. Like their focus is
Pass
is
the
to
test.
get you to go to college.
Yes. Oh yeah,
And
that mainly. Yeah,
and the
that.
way they get you to
pass
go
test.
to, like they're not like to prepare you to be an adult and be prepared for the workforce or anything. That's
Yeah,
this is
no.
just to send you to college. And the way they prepare you to go to college is by under preparing you to be an adult.
Hierarchical paging and their optimization. 64-bit systems have memory addresses that are 64 bits long, meaning the 64-bit virtual memory space is a whopping 16 XB bytes, because we have to use the E thing, XB bytes in size. 16.
Civitatum says high schoolers have become too advanced. All I knew back then
Not high
was that the
school. No,
memory
trust
and
me.
CPU
It's
exist.
it's whatever school they went to is just really good for especially in this sort of thing. Most high schoolers,
No,
that
this is
99.9 with a lot
they
of
did this.
nines
This
after
wasn't
it.
for their school. They were in a
Was it?
club. This was just their
They're in a
club.
club. You count that. You
I'm
count
just
that as
saying.
part of
I'm
the school.
telling you. I'm just saying like their age. Like they were in high school. This isn't. I don't even
Yeah,
think this
and
is related to
if
their
it's in a
school.
club, if it's in a club at school, you count that as part of the school. Like I mean,
No, I
most
didn't
of
say it
those
was a school club. There's a lot of clubs you can join. You don't have to be in a school. It's just like you can
Oh,
be
okay.
in like hack clubs and
Well-
not be a part. Like there's international organizations and stuff you can join, and they were a part of something like this.
Yeah, well, okay, so what I was saying about that SBQ is that, like when you're saying high school has become too advanced, this is like one person. This is like one person, and out of my school, I'm also just one person who's I'm also not on this level of understanding, but I have a pretty all right, like good understanding of computers. But like my understanding is far better than the person in my school with the second best understanding. So it's just the people that stand out. That's all it is. So it's not high scores becoming too advanced. It's just one person who became really good.
XB byte. 2 to the 60th. Wow, that's a lot. PB byte. Oh wait, that's XB byte's bigger. Damn. Let me guess. I bet Tebby byte's a word too.
Happy bite, baby bite, kitty bite, baby
It's
bite,
so
happy
funny.
bite,
Tebby
baby
bites.
bite, baby bite.
Just-
Just go through the
Giggy
whole
bite.
alphabet.
I know. Jibby bite.
Jiggly bite.
we should be technically correct from now on that. Well, I'm never gonna say megabyte ever again because that's technically incorrect. It's a mebibyte. Well,
I think it's a good idea to still say it because literally everybody else is going to be saying it.
I
And
know,
the
but
way
it's
I
so
see it
funny.
is if everybody else is doing it, it's going to cost you more time to explain to them what it is than it is to just be correct about it.
You know,
It's
it's
going to be
just
inconvenient.
inconvenient but hilarious. So it's worth it.
Megabyte.
Why is the only pronunciation is like an English accent? But yeah, mebibyte.
What, do you want it in a Japanese accent?
No, I wanted it in an American accent. Maybe bite.
Maybe bite.
Civitatum
Yeah,
says
like
maybe
quantum
bite.
bits. Like, it's maybe 1 or 0. It's got a 50-50 chance.
This is incredibly large, far larger than any computer that exists today or will exist anytime soon. Wait, how is that even possible? If this is far larger than any computer that ever will exist anytime soon, then how is the virtual memory space? How can it be this big? Oh wait, it's because they're storing things in like hexadecimal or something? Probably.
Because 64 bit is kind of big, a little bit.
Yeah, that's true.
Basically, what they're saying is that like you could technically store up to that. That's what they're saying is you could technically store up to that, but
we got 64
we
bit
don't
registers.
yet because we can't.
Oh, that's I get it now. If you had a computer this powerful, then you would be able to store. Okay, I get it now. But we just don't have a
Then if
computer
you got
that good.
computers more powerful, then you need to
Okay.
go up to 128 bits.
Oh damn, 120. Wow, because I got 64. Oh, okay. Will we ever get higher?
Yeah, we're at 64 bits now because 32 bits wasn't enough for some things.
Damn, I want
Civitatum
128
says, which
bits.
is the
That sounds
next step
cool.
after 32, but provides much more addresses than we need.
Okay, I see. which is 16 XB bytes, which is like way more than we could possibly ever need. And we don't have a computer that can reach the max yet.
Civitatum says many more.
Damn. As far as I can tell, the most RAM in any computer ever was in the Blue Water supercomputer with over 1.5 petabytes of RAM. That's still less. Well, they say petabytes instead of like bytes or something, which is okay. That's still less than 0.01% of 16 exabytes. Oh, damn. Oh, an exabyte is huge then. It's humongous. If an entry... Because the best supercomputer was only 0.01% of an exabyte. Yeah. If an entry in the page table was required for every 4 kilobyte section of virtual memory space, you would need... I can't read this number, it's too big. Page table entries. Okay, page tables required for every... Oh. With 8 byte long page table entries, you would need 32 PB bytes of RAM just to store the page table alone. You may notice that's still larger than the world record for the most RAM in a computer. Aside.
I like this next paragraph.
They should have explained this at the beginning, not like right now. It's too late.
Yeah, they put this like an entire page after they
using it like PB byte. Like,
hey, by the way, this is why we're using weird units.
I know, like put this at the top. God damn. I know it's uncommon and really ugly, but I find it important to clearly differentiate between binary byte-sized units, powers of 2, and metric ones, powers of 10. A kilobyte, KB, is a what does that stand for? Standard in... I forgot what those stand for. Standard in something. Unit. Imperial? Standard Imperial?
What? I don't know.
I think it's probably Standard Imperial.
Look it up. Just look it up.
That's true. But it's not even like important. Lol. International System of Units.
International System of Units, okay.
Okay. Standard International Unit, that means 1,000 bytes. A KB byte, KIV, is an IEC recommended unit, that means 1,024 bytes. In terms of CPUs and memory addresses, byte counts are usually powers of 2, because computers are binary systems. Using KB, or worse, KB, I don't think it matters, to mean 1,024 would be more ambiguous. Since it would be impossible, or at least incredibly impractical. What?
Yeah, so the thing is, like, it's all powers of 2, because like powers of 2 are extremely easy to represent in binary.
Mm-hmm.
You just have 1 1. You just have a single bit set to 1, and it's shifted somewhere left or right.
Mm-hmm.
So it's just a single 1, and everything else is 0. It's really easy.
Yeah. Okay. Since it would be impossible, or at least incredibly impractical, to have sequential page table entries for the entire possible virtual memory space, CPU architectures implement hierarchical paging. In hierarchical paging systems, there are multiple levels of page tables of increasingly small granularity. Okay. The top level entries, so it keeps like dividing them in half, I guess. That's my guess. The top level entries cover large blocks of memory and point to page tables of smaller blocks. Oh. Creating a tree structure. The individual entries for blocks of 4 kilobytes, or whatever the page size is, are the leaves of the tree.
Kilobytes.
I know, kilobytes. Leaves of the... Okay. 8664 historically uses 4-level hierarchical paging. In this system, each page table entry is found by offsetting the start of the containing table by a portion of the address. Oh my god. This portion starts with the most significant bits, which work as a prefix, so the entry covers all addresses starting with those bits. Oh. Okay, the entry points to the start of the next level table containing the subtrees for that block of memory, which are again indexed with the next collection of bits. The designers of 8664's 4-level paging also chose to ignore the top 16 bits of all virtual pointers to save page table space. 48 bits gets you a 120 kilobyte virtual address space, which was deemed to be large enough. Okay. The full 64 bits would get you 16 exabytes, which is kind of a lot. Oh. Since the first 16 bits are skipped. Oh, so they're cutting out bits because it's like we don't even have like the level, what you said, like the computers. We don't even have powerful enough computers to use all 64. So it's like just skip
You
some.
have the shit we need in order to use that, so why think about it?
Exactly. That makes sense. The most significant bits for indexing the first level of the page table actually start at bit 47 rather than 63. This also means the higher half kernel diagram from earlier in this chapter was technically inaccurate. I see. The kernel space start address should have been depicted as the midpoint of an address space smaller than 64 bits. That actually makes sense. Oh well, let's look at this diagram. So do we start on level 4? We start on level 4. We're indexing the table by adding the
Imagine having to
value.
go through all of the research materials in order to find all this information without like a guide like this.
I know. They said they took them 4 weeks of going through like scientific papers and stuff to try to understand how all this works. And like reading
4 weeks is
universe.
pretty short.
I know, so they're pretty good. But they also said that they had been, before they started researching this, they already were involved with like low-level coding. It's just that they wanted to understand all the nuances, so that's why they went on this like down this rabbit hole. Because they knew how to write it in code, they just didn't know what was happening.
I was gonna say, like,
Mhm.
the only way that you complete this in 4 weeks is if you already have a really good understanding of what you need to look for.
Yeah, makes sense. One single top level table.
One thing I don't like that I'm seeing a lot,
What do you not like?
that I don't like when you're using a browser on laptop, is it's so easy to accidentally go back a page.
Yes, that's true. It's annoying. What happens? Address of an L3 table.
I really think, I wonder if there's a way to turn that off, because it is just, it's like one of the most annoying features of laptop when you're using a trackpad. If you swipe too far to the side, it goes back a page. That's just an annoying feature. Want to
Yeah,
go
like
back a
this.
page? It's like I have a dedicated button on the laptop, and there's also a button in the corner of the screen. If I wanted to do it, I'd go click it. I'd go out of my way to click it.
Yeah. Luckily, it doesn't happen that often to me in this one, which is nice. But it is annoying when it happens on laptops. Table adding the value of the bits to the base address. Qt browser.
Civitatum says I have
Indexing
Qt
the
browser
value.
installed.
Adding the value of the bits to the base address. Wait, all addresses.
Civitatum says a weird browser written in Qt that uses Vim-like key bindings.
What does Vim stand for? I keep hearing. Wait, Vim, isn't that an IDE? Right or no? The table by adding the value of the bits to the value of the bits to the base address.
Civitatum says that prevents silly mistakes, also prevents the user input since it requires you to actually enter the insert mode.
What? Level 3. Many different N2 level 3 tables.
You should do Khan Academy on that.
On what? Level? Table start address bits.
Civitatum says it is I use NVim, which is basically a glorified Vim, and it is good.
I don't even know what Vim is. Address starting with XXXX.
Look it up.
You're so mean to me.
Do you have caps
Oh
lock
God.
on?
No, well yeah, I put it on. But I turned it off.
I think it's just a text editor.
Oh wow, it's just a text editor. What the hell?
Oh yeah, yeah. It says that it's just a text editor.
Wow. Okay.
Okay, well, good thing I know that. Oh, that also reminds me.
What did it remind you of?
Now, there's talking like a Linux thing. That reminds me.
Okay.
When I was up at MEPS, they made me take another test. That I didn't even know existed.
N3 level 2 tables. Oh. That's cool. And an L1 table. Why do you think they're using n with like powers? Like, why does that matter? Like the n3 and n to the power 4. Like, are these really powers? Like, it's not like the same in math, right? Because they're not really multiplying something by itself. This looks different.
Well,
N2 and 3 than that.
Well, I'm assuming that n is some power of 2. In which case, if n is a power of 2, then it makes sense.
It does.
Yeah.
How? Curious.
So if you take a number in binary and you multiply it by 2, then it shifts all the bits like to the left one. If you multiply it by 2 squared, it shifts all the bits to the left 2. 2/3, it shifts all the bits to the left 3.
Oh, and because they're adding more numbers onto the end, like for the address, they're shifting.
I'm assuming that n is some power of 2, because otherwise, because if n isn't a power of 2, then it really just doesn't make sense. Like if n is 10, it doesn't make sense. But n is probably a power of 2.
Yeah. Oh, thank you. I didn't know about that pattern. Like if you go up a higher power, if you start with a power of 2, then it just like shifts the bits.
Yeah, that's binary math. If you multiply by 2, then it's basically multiplying by 2 in binary, which is base 2.
It's like multiplying 10 in decimal, as you're gonna say.
Decimal, which is base 10.
You're right, because instead of 10,
it just moves the decimal point.
Oh, this is a really important point. I'm glad I asked this then, because that's important later on if I'm doing binary math.
And then multiplying by 2 squared or 4 is like multiplying by 100 in decimal.
Oh,
or 10 squared. The 2
cubed
is like
because 10 times 10 is 100 times 10 is 1,000. Yeah, you're doing the same thing.
Which moves it all to the side even further.
Oh damn, that's awesome. What is a 3? What is a hex digit? Hex. Last 12 bits. N4. Oh damn. Oh, because things are getting shipped over. So okay.
That's probably a typo. They probably meant hex.
Oh, okay. Heck. Okay.
Yeah. I was like looking around. I was like, where do you see hex? And
yeah. To the 48th. N to the 4. Oh.
Civitatum says 2 to the power of 48.
Yeah, also a fun thing, properties of exponents you'll learn at some point as well.
So 2 to the 48th is the same thing as shifting all those things over 4 places? Is that what SPQ is saying? Something like that? Does that sound right? I don't know. That they said 2 to the 48th is like equal to shifting all those things over 4 places because binary math, like or something. Okay.
Multiplying a number by 2 to the 48 is shifting all the decimal places to the left by 48.
Oh. So damn, you're right. Yeah. By 40. Okay. To PTE RAM address. The PTE points to the start of the 4 KB byte block in RAM.
Or killing bytes.
Oh yeah, Keely. I guess it's Keely.
For Kiwi bytes.
Kiwi bytes. The MMU adds bits 0 to 11.
Yeah.
What? The MMU adds bits 0 to 11 to the address to get the final physical address. Bits 0 to 11. 12 bits equals 4,096 values equals 4.
Corrupt converter says 4 Kiwi bytes.
Kiwi bytes? Is that actually what it is? Kiwi bytes? Wow. That's cute. Bits 0 to 11 to the address. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, 0 to 11? I don't think that's 11
It's
digits.
4 bytes of the kiwi. That's what it means. It represents
Four,
that.
the key. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12, but I guess that. Okay, whatever. Oh, 12 bits, bro. I didn't need to count that. But zero. Okay. No, okay. For the musical values. Actually, the final physical address. So then the final physical address is this whole entire. Actually, I'm not sure. I wonder if the final address will just be the last 12 bits, or if it's this whole entire thing that.
Civitatum says 11th bit is 12th bit, feels dank man.
Yeah, 0-bit indexing and 0-based indexing. You start all your arrays at 0 and not
Oh
1.
yeah! Oh, now it makes sense. Because I was thinking, I was confused for a second too. I was like 11, 12. What? 11 and 12. But 0 index. Oh, 0 to 11 is 12. Okay. Lol. That got me. Add specific to that address to get the final physical. Okay, I think this whole thing is the physical address. Like, I'm guessing. I don't know. But okay. Maybe that's 3. Hierarchical paging solves the space problem because at any level of the tree, the pointer to the next entry can be null. Okay. This allows entire subtrees of the page table to be elided, meaning unmapped areas of the virtual memory space don't take up any space in RAM. Really? Oh! Oh, that's smart. They're like created. Subtrees are like created when they're needed, but then it's like if you're not going to use like a lot of the subtrees like on level 1, then they won't even be like mapped to, I guess, kind of, because they'll just be null. Well, they'll be null like on a higher table, I guess. Lookups at unmapped memory addresses can fail quickly because the CPU can error as soon as it sees an empty entry higher up in the tree. Page table entries also have a presence flag that can be used to mark them as unusable, even if the address appears valid. Okay. Why would you do this? Why would you want just to mark them? Why would you want to mark an entry as unusable? That's weird.
Not being used, maybe.
Oh, like temporarily it could be unused. Okay, for some. Okay.
Yeah, but it's not being used, so don't. So if someone tries to read from it, just throw an error because
Oh
that's
crap.
not allocated to anything.
Oh yeah. Okay. Oh, okay. Another benefit of hierarchical paging is the ability to efficiently switch out large sections of the virtual memory space. A large swath of virtual memory might be mapped to one area of physical memory for one process and a different area for another process. Okay, the kernel can store both mappings in memory and simply update the pointers at the top level of its tree when switching processes. Okay. If the entire memory space mapping was stored as a flat array of entries, the kernel would have to update a lot of entries, which would be slow and still require independently keeping track of the memory mappings for each process. Oh. I said 8664 historically uses 4-level paging because recent processors implement 5-level paging. 5-level paging adds another level of indirection, as well as 9 more addressing bits to expand the address space to 128 PB bytes with 57-bit addresses. Okay. 5-level paging is supported by operating systems, including Linux, since 2017, as well as Windows 10 and 11 server versions. Wait, is Windows 10 and 11, whatever this server version is this the same thing as just regular Windows 10 and 11? Or is the server one special? Like for,
I don't know.
yeah, servers. Aside, physical address space limits. Just as operating systems don't use all 64 bits for virtual addresses, processors don't use entire 64-bit physical addresses. Makes sense. When 4-level paging was the standards, 8664 CPUs didn't use more than 46 bits, meaning the physical address space was limited to only 64 kilobytes. With 5-level paging, support has been extended to 52 bits, supporting a 4 PB physical address space. Huh. On the OS level, it's advantageous for the virtual address space to be larger than the physical address space. As Linus Torvalds said, it needs to be bigger by a factor of at least 2, and that's quite frankly pushing it. And you're much better off having a factor of 10 or more. Anybody who doesn't get that is a moron. I'm a moron then. Wow. End of discussion. Interesting. Why does it... I don't really see why the virtual one should be bigger than the physical one. Shouldn't they... Doesn't it make sense for them to be like the same size? Or unless there's something wrong with the virtual one, then maybe you want like extra virtual memory in case, like, I don't know, there's some error. Maybe that's why.
I don't know. Maybe it has something to do with like memory changing or something like that. I don't know.
Oh, okay. Yeah.
I'm not 100% sure either. There's a
neither.
reason somewhere, but
Yeah. Swapping and demand paging. A memory access might fail for a couple reasons. Okay, the address might be out of range, it might not be mapped by the page table, or it might have an entry that's marked as not present. Oh, so like weird things can happen with you know, when the addresses get effed up. In any of these cases, the MMU will trigger a hardware interrupt called a page fault to let the kernel handle the problem. Okay, cool. In some cases, the read was truly invalid or prohibited. In these cases, the kernel will probably terminate the program with a segmentation fault error. Oh, damn. You've had this error before, right? Segmentation fault? Or have you?
I probably have.
Oh, okay. I thought I saw it in a video once where someone got this error. Segmentation fault. Shell session. Program. No. Segmentation fault. Core dumped. Aside. Seg fault on ontology. Segmentation fault means different things in different contexts. Oh, it can mean different things. The MMU triggers a hardware interrupt called a segmentation fault when memory is read without permission. But segmentation fault is also the name of a signal the OS can send to running programs to terminate them due to any illegal memory access. Okay, so access memory you're not supposed to, get a segmentation fault. In other cases, memory accesses can intentionally fail, allowing the OS to populate the memory and then hand control back to the CPU to try again. Oh, okay. For example, the OS can map a file on disk to virtual memory without actually loading it into RAM. Okay, and then load it into physical memory when the address is requested and a page fault occurs. This is called demand paging. Wow, and then load it into physical memory. Oh, that's cool. That seems very, like, save resources-y.
On my LinkedIn Dance stuff, I had to do a whole bunch of, like,
What'd you do?
I had to keep track. Like, there's a line somewhere in the JavaScript code that calculates exactly in bytes how much memory the program needs.
Oh, damn.
I need to allocate enough pages in order to use, to store the data for the program.
That's so cool. Wait, did you have to do that though, or did you just like?
Yeah, I had to do that. Otherwise, I would run into segmentation faults. So
damn.
What I had to do is I had to take into account how many bytes does it take for the pixel space for the grid, for drawing the grid. How many bytes is that?
Oh my god.
How many bytes are allocated for the data of the grid? of like the state of all the cells. How many bytes are allocated for the start, the start data that are loaded in, that basically passed in. How many bytes are for the other lookup tables and all that stuff. So it was all like it's all a bunch of it's all a bunch of calculating how big that memory is and how much, and add it all together, and then be like, okay, so now this is the size of the whole thing.
Yeah.
Use
So
it.
if you put in too small of amount, then you would get what you said, an error. But if you put in
If I
too
put it, yeah,
much,
if it's too
it'll still
small,
work
then
though,
the
right? If you
program will crash.
overestimate.
Yeah, if it was too small, then the program would crash.
Oh, okay. But too big, well, it'll still work. It'll just be more inefficient because you're allocating extra memory.
Yeah, too big, it'll
Mm,
work. I mean, one of
okay.
the things is that I wasn't able to make it go back down, as far as I remember. So if it was too big, then, well, I just leave it there.
Hmm.
And the maximum that I could get it up to was 4 GB.
Or or maybe gigi bytes. That's
Yeah,
cool
four
though.
giggly bytes.
Yes, but why did you have to do that in JavaScript? Because I thought JavaScript handles its memory all by itself. Or it's
But
like
I was
one.
using WebAssembly.
Oh, I forgot you did this in a. Oh, okay. Assembly. That's crazy. You're crazy.
Yeah, you
Crazy.
should learn about WebAssembly. I mean, it's kind of unfortunate that the website that I use
Oh.
doesn't exist anymore.
Wait, is it
Maybe they
just
never
assembly
something.
but different?
It's
It
basically how you can
seems.
take language, you can write code in languages like C Sharp or C
That's.
or Java or whatever, and then run
Oh.
that in web page.
And then run it. It cut out. I think. What'd you say?
Yeah, you can write language, you write in stuff like languages like Rust and C,
Mm-hmm.
C Sharp, Java, Python or
And it
whatever,
turns to
and run
assembly.
it inside a web page.
Oh, run it inside of a web page.
Yeah, like run it in your browser.
Oh, damn.
Because
But
what it
then.
does is it compiles it down to basically pretty much assembly, like pretty
Oh,
much byte code, and then
that's
and
cool.
then it's loaded through special stuff in JavaScript
Mm-hmm.
that. So basically that's the sort of thing that you can do to get like C like performance inside of your browser in a web
For.
page. So that's also
Wow.
how they're able to do things like make games, like full on games run inside of your browser at not ridiculously slow laggy speed, and
Lol.
also how they can like emulate operating systems in a web page in your browser.
That's
Like you can
insane.
run Windows 98 in your browser,
That's crazy. That's
which
so
is,
cool.
which is crazy, yeah.
Now I know what WebAssembly is, but
And then you can also do like video editing software or stuff like that, or rendering stuff in the browser as well.
oh, so basically, if I'm ever using like an
So yeah,
application in the browser,
WebAssembly is
that's
pretty much used. WebAssembly is pretty much used for like the is
heavy.
usually used for like the heavy intensive stuff that you need to optimize a lot.
Okay, but that's
So you do it all in C.
yeah. So then assembly that's really cool. Right, in other cases, for example, the OS can map a file on disk to virtual memory. Oh, I read that. Demand paging. Oh yeah, pictures. Read. Page faults. Page fault handler. Loading data into RAM. Done. Return from interrupt. Oh hey, the page is present now. Here's your memory. Thanks. This is definitely what happens in the computer. I think they actually talk to each other and use English words because they're
You
alive.
fucking idiot. You know I don't have that. What are you doing here? Like, shut up. Leave
Yeah,
me alone.
get
I
it
don't
out
want
of
to
here.
talk to you right
Error,
now.
error.
Go figure it out. Figure it out. You're on your own.
Hell yeah.
You did it wrong. Your math is wrong. You're bad. I don't want to talk to you. Leave me alone.
Oh my god, I'm just imagining MMU saying that. You're bad, you're bad. Go away. Initiate system shutdown.
How many gigabytes do you have? You have 30 gigabytes. Can I read the 40th gigabyte? No, shut up. Go away.
Go away. You're bad. Have a
No.
blue screen.
Leave me alone.
Okay. Here's your memory. Okay. That's cool. Page 12. For one, this allows
I don't have that.
syscalls like mmap that lazily map entire files from disk to virtual memory to exist. Huh. If you're familiar with LLAMA CPP,
Llama?
yes, a runtime for a leaked Facebook language model. Oh wow. Oh. Wait a second. This is a real language model then, because I've heard of like Facebook has an LLM called Llama. But I wonder if it's this one. Justin Tunney recently significantly optimized it by making all the loading logic use mmap. Oh. If you haven't heard of her, it's her. Damn, she's good. Oh, Justine.
Well, Justine.
I said Justin. I feel so sexist. Her name is Justine. If you haven't heard of her before, check her stuff out.
Yeah, you can only be a guy if you want to be a coder. That's how that works.
Damn. It hurts. Oh, it is Llama. It's actually Facebook's Llama. Damn. This is impressive.
Yeah, it's better than stuff I do. I don't do anything.
Yeah, you do. Liar. Cosmopolitan, Library, C, and Ape are really cool and might be interesting if you've been enjoying this article. Aw. I love how they're saying, oh, these might be interesting, but they don't explain what the hell it is, but okay, it's fine. Using mmap from disk. Huh. Apparently there's a lot of drama about oh no, not drama. About Justine's involvement in this change. Oh, okay, so she's in drama. Just pointing this out so I don't get screamed at by random internet users. I must okay, it links. The lot of drama has a link. Let's see what drama. Hacker News. Llama
Is that
drama.
multiple links?
Yeah. Oh damn. Oh, they linked holy hell. Yeah. Multiple links. I bet they're saying it's probably something like, oh, she stole code, or they're probably, I mean, isn't that the type of drama that happens with like coders? It's like, oh, you stole it, or you didn't really write it, that type of thing. Interesting. Well, that sucks. I don't know what it is about, but it's not important. I must confess that I haven't read most of the drama, and everything I said about Justine's stuff being cool is still very true. Oh, so it's not related to the llama stuff. It's just related to
But
her.
like that's a whole other problem. I'm just talking about the code. Leave me alone.
Yeah, he's saying like leave the drama. Like I don't care. I just like to talk about the code, the llama code.
So I didn't do any of that. I don't have.
Like don't hate on me.
Like I have nothing to do with that.
When you execute a program and its libraries, the kernel doesn't actually load anything into memory. That's crazy. It only creates an mmap of the file. When the CPU tries to execute the code, the page immediately faults, and the kernel replaces the page with a real block of memory. Oh, who knew? I didn't know this. Demand paging also enables the technique that
So whenever you run a program, it immediately crashes.
I know, that's the best when that happens. Demand paging also enables a technique that you've probably seen under the name swapping or paging. Operating systems can free up physical memory by writing memory pages to disk, and then removing them from physical memory, but keeping them in virtual memory with the present flag set to 0. I forgot if 0 means like read it or something. Oh wait, present flag, so it means is present. Because 0 is, true, and that's right. Physical memory by, writing memory pages to disk. False. This is cool. If that virtual memory is read, the OS can then...
Is 0 true here?
Huh?
Does 0 mean true here?
I just mean false. 0 means is present, I guess. And then 1 would be, like, not present. Because the flag is on when it's 0, and all the different flags, like the dirty flag.
Keeping them in virtual memory. Wait, I'm going to read this.
Present, true. 0 is true. Like, up here, This is the flag, I think.
Wait, where's the number?
Oh, okay. It says, let me go back. With the present flag set to 0, so true, is present, I think.
I'm just wondering, like, I don't see anywhere in the two things that you showed me where it says that 0 is true. I gotta read this. Demand paging also enables.
It's a flag. It's either true or false.
Physical memory by writing memory pages to disk and then removing them from physical memory, but keeping them in virtual memory with the present stack for 0. So it looks like 0 sounds like off here.
You think so?
virtual memory is read, the OS can then restore memory from disk to RAM and set the present flag back to 1. So that means
Oh, you think the
that
one?
means enable it again. Enable it again because we're using it again.
Oh, damn. Okay, so it's the opposite. If that virtual, okay.
Yeah,
Memory
there
is
was
read.
like always on.
Real? Oh, okay. Wait, okay.
Yeah, that's why I was confused. I was like, what?
I hate the numbers they
I was
picked.
gotta be like, who stupid asshole is deciding that 0 is on and 1 is off?
Oh yeah, I keep
Nobody,
forgetting.
nobody
You're
does
right,
that.
because 0 is always false anyway in like all the languages. Because you're right, because 0 is nothing. Because I had to have this explained last time. 0 is
Yeah,
nothing.
you had to.
1
Yeah,
is
yeah, because
something.
like
Shoot. I keep
you're the
getting
kind of person that thinks 0 plus 0 equals 2. Like, what are you talking
in
about?
my head. Yeah, well, my head just naturally. Like, if I didn't know anything about anything, I would just assume 0 is true because of the we say 0 and 1. Not 1 and 0, and it's like we say true and false. So I'm mapping. You see what I'm doing? I'm mapping 0 and 1 to true and false instead of false and true. That's why I keep getting confused. I'm sorry. But Linus, it's fine because Linus Torvalds in his quote basically called me a moron because he's like, anybody who doesn't get this is a moron.
Yeah.
Yes. So end of discussion. That's what it said here. End of discussion. Sad face. Okay, so yeah, you're right. If the virtual memory is read, the OS can then restore the memory from disk to RAM.
Works and cows.
What's wrong? It's the next chapter. Forks and cows. Can then restore.
Let's talk about steak. I like that. They should just name that. Let's talk about
What?
steak.
Heck yeah. Steak is good. The OS can then restore the memory from disk to RAM and set the present flag back to 1. Okay. The OS may have to swap a different section of RAM to make space for the memory being loaded from disk. Okay, disk reads and writes are slow, so operating systems try to make swapping happen as little as possible with efficient page replacement algorithms. I'm not clicking on this because it's going to be really complicated. That's cool to know. An interesting hack is to use page table physical memory pointers to store the locations of files within physical storage. Physical memory. Okay, since the MMU will page fault as soon as it sees a negative present flag, it doesn't matter that they are invalid memory addresses. This isn't practical in all cases, but it's amusing to think about. Files within physical storage. Huh. Continue to chapter 6. Let's talk about forks and cows. And steak. And there will be C code. Yay. Okay, this is the last.
They should have an
chapter.
example in here about talking about butchering a cow
Look at this. This section is just called Moo.
with pictures.
There's no pictures on here. I'm really sad. There's one picture, but it's mostly just C code, which makes me sad, and then a video about cows. The final question: how did we get here? Where do the first processes come from? This article is almost done. We're on the final stretch, about to hit a home run. Moving on to greener pastures, and various other terrible idioms that mean you are a single length of chapter 6 away from touching grass, or whatever you do with your time. And you aren't reading 15,000 word articles about CPU architecture, thank God. If execv starts a new program by replacing the current process, how do you start a new program separately in a new process? This is a pretty important ability if you want to do multiple things on your computer. When you double-click an app to start it, the app opens separately while the program you were previously on continues running.
This is multi-threading. Multi-processing, multi-threading, that's what this is.
Oh, cool. The answer is another system call, fork. The system call fundamental to all multiprocessing. Oh, so you've heard of this call before? A fork call? It's new.
I've probably heard it at some point, but I haven't used it.
Okay.
I mean, I've done multi-threading before, but I don't use the fork instruction because I do it in higher level.
Oh yeah, and it calls it probably for you.
Like C#. I wonder if I might have not have done it in Java. I'm not sure. I don't know. Whatever.
Got you. Fork is quite simple, actually. It clones the current process and its memory, leaving the saved instruction pointer exactly where it is, and then allows both processes to proceed as usual. Save. Okay. Without intervention, the programs continue to run independently from each other, and all computation is doubled. Oh, so this is real true multithreading because it's running in both. Okay. The newly running process is referred to as the child, with the process originally calling fork the parent. Oh, damn. Processes can call fork multiple times, thus having multiple children. Each child is numbered with a process ID, PID, starting with 1.
Like you.
Hey, they start at 1 and not 0. Amazing. Beautiful. Clueless.
Well, on the next diagraph, you can see it starts at 0. On the child, it starts at 0.
Oh, damn, you're
So the
right.
child is 0. Yeah.
But I guess it's like 0 is like the parent then, right? Oh, wait, we're in the child. It says do some computation and feed results to the parent. Oh, it is starting. Okay, so why do they just say starting with 1 if they're starting on 0? It doesn't make any sense. Cluelessly doubling the same code is pretty useless. So fork returns a different value on the parent versus the child. Oh, it's explaining it right here. On the parent, it returns the PID of the new child process, while on the child, it returns 0. Oh, okay. Oh, it's like saying like 0 means like child, but the PID of the new child, if you call the parent, it'll return 1 or... This is weird. This makes it possible to do different work on the new process, so that forking is actually helpful.
Yeah, I was like,
What were you thinking?
they're talking about it like there's no way to differentiate between the parent and the child, and I was like, there has to be a way to differentiate between the parent and the child, otherwise it's useless. Why do it in the first place?
Wait, what part were they implying
So,
at the
so
beginning?
they're talking about how it all proceeds exactly the same and doubles all the computation.
Oh yeah.
And I was like, there has to be a way that you can differentiate so you don't do that. Because otherwise, if you can't tell whether you're a parent or child, then you're going to be doing the exact same things both times, but twice as often. So, but twice as often, it's going to be useless. That's what that is for. That's to basically say, hey, do something different when you're not the original process.
Oh, cool. New child process while the child returns 0. Okay. That's cool. PID equals fork. It says code continues from this point as usual, but now across 2 identical processes. Oh, it's calling fork. Or whatever. Identical, except for the PID return from fork. Okay, this is the only indicator to either program that they are not one of a kind. Oh, so this PID is the only thing that they can tell like which one is running. If PID...
Yeah, if you lose
0.
that number, then you're shit out of luck for figuring out that you're different.
Shoot. This number is like everything. 0. We're in the child. Do some computation, feed results to the parent. Okay. Else, we're in the parent. Probably continue whatever we were doing before. Lol. Process forking can be a bit hard to wrap your head around. From this point on, I will assume you figured it out. If you have not, check out this hideous-looking website. What? For a pretty good explainer. No. Because you're here, you explain this to me, I think I get it. I don't need to look at the hideous-looking website right now. Anyways, Unix programs launch new programs by calling fork, and then immediately running execve in the child process. Okay, this is called the fork execute pattern. When you run a program, your computer executes code similar to the following. Launcher. Fork. Immediately replace the child process with the new program. Oh. That's cool. Since we got here, the process didn't get replaced.
If we ever need to kill it.
What?
Yeah.
Where did... Oh, you went ahead.
Yeah.
Killing a child? That's controversial since
That's
we
like-
got...
That's well, I mean, I guess free food, you know.
We're on a topic about forks and cows, so I guess this is how we got here.
Yeah,
I'll
cows
just
eat their
add
children.
the kid too. So we got the process.
Cows kill and eat their children when they get too hungry.
We're in the parent. Helpfully, we also now have the PID of the new child process in the
You used to be in your parent.
PID.
I said you used to be in your parent.
Damn. Is this how it's happening in the code too? Like oh yeah, you're right, because it starts from the parent and forks. It's true. So we don't hear the person get replaced. In the parent. Hopefully we also now have the PID of the new child process. And the PID variable. Wait, this part I don't really get. Because if it's saying, like, if it's not a child... Oh, but now it says we have the PID of the new child process and the PID variable. How did we get the... Oh, okay. If we ever need to kill it. How did we get the PID of the new child process if we went to the parent section of the code?
Return by fork. If you're the parent process, you get the PID of the child. If you're the child process,
you get the PID of the... each time you get the... Okay.
Yeah, if you're the child process, you get 0.
Now it makes sense. So now you can kill the child. Great. Child. Parent program continues here.
Yeah, so now you can commit murder. I actually did have to do, had to have a thing set up in my,
What'd you do?
In the C# code for runtime compiler for killing the child process or terminating the alternate thread.
Oh no!
Because I needed to do that if it took too long to run, so it didn't just infinitely.
Oh, okay.
So like I'm waiting for the result back from the compiler. If it takes longer than 10 seconds, stop.
Okay. So my question is, how many children have you killed? How many times did you run that thing?
3.2 billion.
Okay.
544,283,174.
Nice. That's definitely genocide. Moo. You might have noticed that duplicating a process's memory, only to immediately discard all of it when loading a different program, sounds a bit inefficient. Luckily, we have an MMU. Duplicating data in physical memory is the slow part, not duplicating page tables, so we simply don't duplicate any RAM. Aha, we create a copy of the old process's page table for the new process, and keep the mapping point pointing to the same underlying physical memory. Okay, this is really, really clever. New process. Okay.
I mean, that's what I would do as well.
It's smart. I mean, honestly, I would probably do the slow, stupid way, and then my program would run like crap, and the computer would probably die. And then I'd be like, why can't I have multiple... like, that's what I would...
You do it. You do it the slow way, and then when it runs like shit, you're like, let me fix this. That's how that works. When it goes bad, then you
realize you have to change stuff so it doesn't. Okay. I see. Copy the old process page table. But the child process is supposed to be independent and isolated from the parent. It's not okay for the child to write to the parent's memory or vice versa. Introducing cow. Copy on write pages. Wow. With cow pages, both processes read from the same physical address as long as they don't attempt to write to the memory. Oh. As long as one of them tries to write to memory, that page is copied in RAM. Okay. Cow pages allow both processes to have memory isolation without an upfront cost of cloning the entire memory space. Okay. This is why the fork execute pattern is efficient, since none of the old process's memory is written to before loading a new binary. No memory copying is necessary.
So then this begs a question.
What's the question that pops up for you here?
Can it copy twice? Like if you have the parent and the child, and like the parent writes to the memory and makes a copy.
Yeah.
If the child writes the memory, does it also make another copy, and then you have 3 copies of the same memory, whereas you only need 2? That's a question.
Wait, why would there be 3 if it's only you only have 2 programs?
So basically, pretty much if either the parent or the child writes to the memory, then it copies the memory. It makes a copy of it in physical memory. But what if both the parent and the child write to the memory? Does it create 2 copies, like a copy for each of them, and then you have that original memory that can't be written to, but is just being wasted there?
Oh, that's a good question. Well, the answer is right here, like where it says knock knock, who's there? Interrupting cow. Moo. There you go. Hope that answers your question.
I don't think that answers my question.
Okay. That is. Well, I wonder if they. I hope they will address that because that's a good point.
Yeah.
That didn't answer my question. That is a classic joke, dude. That's a joke
Divish
like I told
990
when I was in
says
elementary
classic
school.
joke.
That's how classic it is. It's so classic. Classic. I love how they interrupted the whole article to literally write this out. Amazing. Hmm. This is why the fork execute pattern is efficient, since none of the. Oh, I read that. No memory copying is necessary. Okay. None of the old process memory is written to before loading a new binary. Huh. Cow is implemented, like many fun things, with paging hacks and hardware interrupt handling. After fork clones the parent. Oh, maybe this will answer it. After fork clones the parent, it flags all of the pages of both processes as read-only. When a program writes to memory, the write fails because the memory is read-only. This triggers a seg fault, the hardware interrupt kind, which is handled by the kernel. The kernel, which duplicates the memory, updates the page to allow writing and returns.
So that sounds like a.
Both have their separate ones.
Okay, wait.
I think, right?
Does it? So
Sounds
what
like
I'm
it to
guessing,
me.
the way I would handle it is, I would say
Yeah.
if either of them writes it, then it copies and redirects it to a different page, and then the page that they were writing to, now that one is now read write, and whichever one is left having access to it is able to write to it again.
Oh, damn. That's it. Okay.
That's how I would do it.
I see. So you wouldn't create a page for both of them. You're just like, whichever one called it
Yeah,
or tried to
as
write
soon as one
now
of them,
has
as soon as
access.
one of them tries to read from it, then just mark it as read write, and then give the one that tried to read from it new memory.
Okay. Does it sound like that's what they're doing?
I'm not sure. I don't know if that's what it. I'm not 100% sure if that's what they mean here.
Maybe.
But that's what I would do.
That's cool. The kernel which duplicates the memory updates the page to allow writing. It returns from the interrupt to reattempt
the page,
write.
like the reason why I don't know whether or not that's what they mean here is because they say the page.
Oh yeah,
And I
yeah.
don't know-
Which
I don't
page?
know
Like
if
which
they
one we're
mean
talking
the
about?
Original page. Yeah, I don't know if they mean the original page or the new page.
I think they mean the new page. That's my impression when I read it. Like that's what I think they mean. But of course we don't know for sure.
I
But that's what
don't know 100%.
Yeah, we don't know 100%, but I think
See, that's what happens when a high schooler writes an article.
you're right. They don't specify enough in the beginning, not Genesis. Every program on your computer was fork exec'd by a parent program, except for one, the initialization process. Okay. The initialization process is set up manually, directly by the kernel. It is the first userland program to run, and the last to be killed at shutdown. Nice. It feels so bad when they use kill. You should use a picture. Poor programs.
Yeah, and then here's the question: what runs? Like all the stuff is run by the kernel. What runs the kernel?
Yeah, you're right.
So like you got to go up this whole chain and figure out what is the very, very, very first thing to run, which I don't think think I saw in this article.
Oh yeah, that's where that's where we're at right now.
Yeah, but like to my knowledge, I think there's like a bit of
Civitatum says, isn't that what the same idea as what's actually happening?
Wait, I can't believe they just said want to see a cool. I do not want to run anything like that. I know this is for Linux though. I think sudo is only Linux, but like this, why would you do this? Want to see a cool instant black screen? If you're on Mac OS or Linux, save your work, open a terminal.
990 says before the kernel is the bootloader, right?
And kill the initialization process. This is how you just like, wow, amazing. Author's note. Knowledge about initialization processes, unfortunately, only applies to Unix-like systems like Mac OS and Linux. Great. Most of what you'll learn from now on will not apply to understanding Windows, which has a very different...
You want to kill the cows because they give you food.
Kernel architecture. Just like the section on execv. Okay, so Windows does it. This is specifically more for Mac. At least the part about like the booting stuff is more for Mac. It's good to know, I guess. Just like the section on execv, I am explicitly addressing this. I could write another entire article on the NT kernel. Oh, that's the Windows one. But I'm holding myself back from doing so. You should have! F Linux. I want to read about Windows, not Linux. Anyway. The initialization process is...
The thing about the reason why I think is because Windows is very proprietary and closed source. They don't have all this information about Windows because it's not available.
But they did say I could write another entire article on the NT kernel. They just don't want to. So I'm sad. So they must have done some research about the NT kernel too.
Yeah, I mean, I imagine it's also that it's also harder. And like again,
it's true. That's true.
You know, Windows users. How many Windows users are reading these articles?
Fair. You're right. It's really just like the Mac people and the Linux people that are reading this. Makes me sad. The initialization process.
Yeah, like in a year's time, you're not going to be using Windows anymore. You're just going to be using Linux.
Damn, really? That'd be pretty cool. Like, damn, I would have to be. My brain would have to be so swole for that. Windows is bloated proprietary garbage. Damn.
Windows is bloated proprietary garbage wheels, dank man.
You're gonna have a 7 head. Like you're gonna be able to fit 7 fingers on your forehead.
7.
And that's gonna be your forehead is just gonna grow massively from the size of your brain.
Oh my god, I hope so. I want my head to be so heavy I can't support, like my body can't support the weight anymore.
Nibish990 says Windows is malware big.
They become bigger than everything else in your body.
You guys are poor Windows beating down on poor Windows. But then again, I mean, think about it, correct? You don't have a search bar, and my computer shuts down every 2 days randomly, and I have to restart it. So, Windows.
Yeah, if I was on Windows, if I was on Linux, I'd fix it. That fucking Windows, what the hell is that?
Linux is honestly
easier from the command line / admin work.
I can believe that though. And slow. Lol. I kind of don't really understand. I know they're like different, but I mean, I kind of don't. I mean, they're similar, but they're different. Like that's all I know. I don't really understand what the difference between PowerShell and a normal terminal window is.
What'd you say? I didn't hear you.
Oh, I was saying I don't really understand exactly what the difference is between like PowerShell and like a normal terminal window. Like I know they do similar-ish things, ish, and you type commands to them. Yay.
I think everything you can do in command prompt you can do in PowerShell, but there are some things like PowerShell can also use like run certain scripts that you can't run in command prompt and all stuff, and has also some different syntaxes for certain things.
Oh, cool.
But I like the old school command prompt.
You know, I just realized them showing this is really funny because if anyone asks, like, let's say you hate it Mac and you hate it Linux, and then they ask you, do you like Linux? Then all you have to say is sudo kill 1. Like that's how you answer their question. I think that'd be really funny. Yeah. The initialization process is responsible for spawning all the programs and services that make up your operating system. Many of those, in turn, spawn their own services and programs, until you have so many things open that your computer instantly crashes after you boot it. Killing the initialization process... What?
You know what sudo means?
It's like, it's command, right? That's how you give a command? Like you're saying, like, I give the administrator command to do something? Is that what it is?
Super user do.
What'd you say?
Super user do.
That's what it actually stands for. Super
user do. Is so locked down, and Linux has so many tools associated.
The administrator
with it.
in Linux is
PowerShell, but you have to type out.
Oh, super! Of course they call it super user. It's funny. PowerShell so
PowerShell is fully locked down. Yeah.
grep. What is grep? But you have to type it out. Select string pattern, search term path, file to search type. Oh. Oh, you're saying like that's what you have to type if you're gonna use PowerShell? You have to type that long thing? Ew. Oh, you probably mean grab. You can grab in PowerShell or something. I don't know. But you have to type it out. Killing the initialization process kills all of its children. Oh, it's so sad. And all of their children, shutting down your OS environment. Nice. Back to the kernel. We had a lot of fun looking at Linux. I don't know if this was fun. That Linux kernel code back in chapter 3. Jesus. So we're going to do some more of that. No, I didn't like that part. This time we'll start with a look at how the kernel starts the initialization process. Yeah, your computer boots up in a sequence like the following. The motherboard is Whenever I say motherboard, it's so funny because I watched
That's
this
the thing I was
video
talking about.
that maybe you
The
guys
bootloader.
the beans.
That's the thing I was
You know what I'm
talking
talking about? The beans. You know what I'm talking about?
about. No.
Civitatum
I was
Dude,
talking about no.
is a
it's
I'm
command
so
talking
that selects the
funny.
lines that match the pattern.
I'm talking about what's
basically.
on screen. I don't know what you're talking about. I'm talking about what's on screen. They're talking about bootloader. That's what I was talking about.
Oh, okay. Well,
What are you talking about?
I'm
I wasn't
talking
paying
about.
attention.
Okay, there's this. You can look up yourself if you're interested. But there's this like a really funny video of this like programmer or
British
IT guy.
990 says I don't know how to do that in PowerShell,
Oh.
but I know it's long and dumb.
Long and dumb, I see. But the guy, so he does a prank where he takes, well, he opens up his computer, like on his desktop, like he literally opens up and it's really sad, but he pours tons of beans, like, yeah, he pours cans of beans into the computer, which like immediately like destroys it and fries it, and then he calls like an IT person to come over and figure out why his computer won't restart and turn on. And the IT guy comes to his house and he has like hidden cameras set up and opens up the computer and all these all these beans come out of the computer and he's like, "Oh my god, I can't believe this." And then the guy who did the prank, he points to the beans and says with like a serious face, like he doesn't laugh at all. He's like, "Are these the are these the motherboards?"
You went silent.
No, he says, "Are these the motherboards?" It's so funny. And the guy's like,
Hold on, wait, wait. Can you hear me?
"What? Yeah." Again?
My audio's.
Oh, that's sad. You missed the best part. But yeah, he's like, "Are these the motherboards?" Like, I love that.
Lap it if the guy saw the computer.
Damn it. Okay, so the guy sees the computer. He opens up the case, and all
British
these
990
beans.
says beans as a service.
Yes, it's so funny. And all these beans pour out, and then he's like so shocked he can barely talk. And then the guy who does the prank points to the beans that are falling out, and he says, are these the motherboards?" with like a serious face, and it's just so funny. And the guy's like, "No, no, these aren't the motherboards. They're beans. They're beans." It's so stupid, but it's amazing. It's so funny. Like if you just Google computer IT and beams, like it has to show up because it had like over 1 million. I don't know. It had a lot of views. It was really funny.
I just imagine just someone opens up your computer and
Are these the
open it up,
motherboards?
and what they see is just
What?
it's just filled with Campbell's chicken noodle soup. Like just open it up, it's just
Amazing.
straight chicken noodle soup.
If that
And
happens,
it's like, why's my computer not turning on? I tried to do some like water cooling on my computer.
water cooling, amazing.
You open
Wow.
it up and it's all chicken noodle soup.
Nice. Or in your case, what it would just be a bunch of ravioli pouring out from the computer, and then you could be
I don't
like,
eat ravioli.
"Are these
I don't
are
eat
these
ravioli.
the CPUs?"
I don't eat ravioli.
Oh wait, what was it? What do you eat? Isn't it like Chef Boyardee? Isn't that ravioli? What would it else be? What else would it be?
There's more. They have more than ravioli.
Oh, okay. I did not know.
Beefaroni, you probably mean. Two very similar names, but two completely different things.
Interesting. Well, in any case, they're all just motherboards, so it doesn't even matter.
Yeah, they're all
But yeah,
motherboards.
it's a shame. It's kind of a shame
Motherboard.
that I watched that video because I can't like see the word motherboard show up in text without like thinking about beans now. So it's kind of
Are
a
you a
problem.
motherboard?
The beans is bundled with a tiny piece of software that searches your connected disks for a program called a bootloader or a bean loader. Cool. It picks a bean loader, loads its machine code into RAM, and executes it.
Yeah, that's the thing I was talking about. It
What?
runs like this small code to begin running your computer.
Oh, that's what you're talking about? This.
Yeah.
Oh. Load this machine. Oh, wow. That's cool. Tiny software. So if something goes wrong with this bootloader, like it must be like catastrophic.
If the bootloader is faulty, your computer doesn't turn on.
Like that's catastrophic. That's bad.
Yeah.
That's very bad. Huh.
I mean, probably what will end up happening. What will probably end up happening is
What?
you'll end up in like that sort of like command terminal looking thing where it says "failed to boot up" or whatever.
Oh damn.
Like failed to
Oh.
find a bootable bootable drive or something like that,
Mm-hmm.
you'll get an error like when you try to turn on your computer. It'll be on like a computer command terminal looking text.
Yeah. Well, to be honest, though, okay, back to all seriousness. A motherboard is actually it's just the CPU, right? Like the chip. It's called a mother.
No, the motherboard is the entire
Okay.
board. Like, look up what a motherboard is.
Oh, you mean the board, and it could have multiple CPUs on it. Like it's like the actual.
Look up what a motherboard
Okay,
is.
fine.
Yeah.
Civitatum says it's akin to planting a bean, and from that bean a plant would grow.
It's oh my God.
It's the entire giant
Planting.
thing.
Yes, the more bean metaphors you use, the more I understand. So it's very important. It's like, okay, you plant the bean. Oh,
so the motherboard.
Yeah.
The motherboard is the thing that has the CPU.
It's the garden. It's the bean garden. Like the actual motherboard is like the bean garden for the beans.
Civitatum says the
plant
plant
then
then
branches
branches and possibly replicates.
Whoa.
Yeah, it's like the entire farmland where you put all the beans.
The motherboard. Nice.
Yeah.
Yeah, it kind of looks like a plot of farmland, low-key. Like all the different like rows are where all the different types of beans are growing. This is technically accurate. This is amazing. Motherboard. Cool.
Imagine if your computer could replicate itself.
Wow, then I wouldn't need more RAM. I could just keep replicating it and get more RAM. Instant download. Download free RAM. Keep in mind that we are not yet in the world.
Evolving and adapting and going and doing like the whole thing, you know, it might eat you one day.
Cool. Keep in mind that we are not yet in the world of a running OS. Until the OS kernel starts an initialization process, multiprocessing and syscalls don't really exist. Wow. In the pre-initialization context, executing a program means directly jumping to its machine code in RAM without expectation of return. The bootloader is responsible for finding a kernel, loading it into RAM, and executing it. Some bootloaders, like Grub, are configurable and /or let you select between multiple operating systems. BootX and Windows Boot Manager are the built-in bootloaders of macOS and Windows respectively. The kernel is now running and begins a large routine of initialization tasks, including setting up interrupt handlers, loading drivers, and creating the initial memory mapping. Finally, the kernel switches the privilege level to user mode and starts the initialization program. We're finally in user land, in an operating system. The initialization program begins running initialization scripts, starting services, and executing programs like the shell/UI. Cool. Initializing Linux. On Linux, the bulk of step 3, kernel initialization, occurs in the start kernel function. Does it put...
Nibish990 says I don't know how Windows does it, but you have an account for Grub, where if there's an issue with the bootloader you can try to fix it and go into basically a recovery mode.
That's cool. So you've used this thing, this Grub thing. I'm sure it's called Grub because grub is another word for food, and beans are food. Yes. Function in initialization main.c. Wait, bulk of step 3. Step 3 was... Oh, okay, all this. Under memory mapping. This function is over 200 lines of calls to various other initialization functions. So I won't include the whole thing in this article, but I do recommend scanning through it. Hell no. At the end of start kernel, a function named archcall rest init is called. Do the rest initialization, I guess. Non-initialized. We're now alive. Grand Unified Bean Loader!
Civitatum
Yay!
says Grub stands for Grand Unified Bean Loader.
Now you make me want to actually use it. You make me want to give up my Windows and embrace the beans. Did not initialize. We're now alive. Archcall rest. What does non-initialized mean? The start kernel function is defined as ASM linkage. Visible void of Jesus. Initialize no sanitize address start kernel void. Amazing. The weird keywords like visible, initialize, and no sanitize address are all C preprocessor macros used in the Linux kernel. Macros, that's new. To add various code or behaviors to a function. Oh, that's what these things are? These double dash things in C are like called macros? Like giving a macro? Interesting. Macaroni. That's what they can be. The word? Preprocessor macros. Okay. In this case,
Xot_77 says Ryzen 950/RX 7800 XT/32
I do
GB
not know.
RAM DDR4/1
What?
TB NVMe
How does it-
M.2 SSD. Hello,
In
is
this
this
case,
a good PC?
initialization is a macro that instructs the kernel to free the function and its data from memory as soon as the boot process is completed.
Civitatum says better than mine, feels dank man.
As soon as the boot process is completed, simply to save space. Oh, that's cool. How does it work? Without getting too deep into the weeds in the garden, the bean garden, the Linux kernel is itself packaged as an ELF file. Wow. The initialization macro expands to section initialization.txt, which is a compiler directive to place the code
Texot_77 says yummers.
in a section called .initialization.txt. Yummers. Instead of the usual .text section. Wait. Section is compiler directive place the code. Oh. .text section. That's cool. Other macros allow data and constants to be placed in special initialization sections. Oh, as well, such as initialization data that expands to section initialization.data. Okay. Arch call rest.
Texot_77 says J2 as de ban moisale merd borbier 76.
Is nothing but a wrapper function. Void init weak. Arch call rest init void. Rest init. The comment said, do the rest non-init because rest init is not defined with the init macro.
Texot_77
I don't like this whole
says
init stuff.
Why? I don't want to say initialize.
Yeah, well, I mean,
Oh,
init.
because it says init? Is that why?
Yeah, everybody. Yeah, it's like everybody says init.
Okay. It's just like when I was saying, remember when it was XOR, I was like Zor, Zor, and you're like, stop saying Zor, it's XOR. It's XOR.
Yeah, just read the text that's there. Don't worry about
Oh
what
yeah,
it's
and you
supposed to
said,
be.
okay, wait, you were actually right, because when I was watching the CS50 C course, he called the word, I'm not talking about XOR anymore, I'm talking about, what's that data type? It's a data type. Like in high level languages, like, what is it? He calls it char. He says char, not care. I'm the only one who says care.
Yeah.
It's char. Damn it.
Yeah.
Yeah, I was like sad when he said char. I was like, wow, this computer professor guy pronounces it char, so it must be char. Sad face.
Yeah, so you must be wrong and bad and stupid and shut up.
Yeah, exactly. That's what I mean. So sad. I kind of just want to call it init almost to annoy you, but I won't. Okay, I'll call it init just for you, but we know it stands for initialize, so it's like helpful. It's helpful to help me remember when I read.
Yeah, no, it stands for initialize.
What does it stand for?
It stands for initialize.
Exactly, initialize.
Initialize, right?
Initialize, sure. I'll just say.
Initialize.
So I'm gonna from now on pronounce initialize as initialize, not initialize.
Initialize.
No, ignited. Okay, do the rest. Non-ignited.
Like initialize.
Jeez. Right? No. Because rest init is not defined with the init macro. Nice. It wasn't? Where was it? Rest in it. Oh, yeah. Rest in it. Oh, yeah. Wait. Rest in it. That's fine. Okay. This means it is not freed when cleaning up init memory. No inline. Void. Rest in it. Void. Oh, but but there is no init macro thing, though. So. Rest init now creates a thread for the init process. I hate saying init. It's annoying. I don't know why. It's like what's in it? We need to spawn init first so that it obtains PID 1.
Well, maybe you're just pronouncing the T a little bit too hard.
Maybe.
Nibish990 says bio/uefi-bootloader-kernel-init.
Oh, that's the order? Thank you, whoever followed. Thank you. BIOS, then boot. Oh, yeah. Finds the bootloader.
Oh, yeah, BIOS. Yeah,
oh,
BIOS
yeah,
is the
bootloader
first
needs to
thing.
launch the
Yeah,
kernel.
the BIOS is the first thing.
Kernel
it
calls
runs,
init.
yeah.
And
the like searching the active drives for the bootloader, something has to happen to do that, and that's the BIOS.
Ooh, BIOS is so magical. Do you know what UEFI stands for? Just off the top of your head?
No.
Yeah, me neither.
No.
I guess it's like, another name for BIOS. Or it does the same thing at BIOS.
I don't use it because I don't need to use it.
Oh?
Like, I learn the stuff that I need to use, but I don't learn the stuff that I don't need to use or don't need to learn.
Like stuff related to Linux and stuff, I see.
Yeah, like even like assembly, I probably wouldn't have learned assembly if I didn't think that I needed to learn assembly in order to do the thing that I needed
specifically trying to do at the time, yeah.
Yeah, I was learning it for something specific, yeah.
Mm-hmm. Makes sense.
But I didn't end up doing that something specific, but it was good anyway.
Yeah. That's good though.
I think, at least. You'll be the one to find out if it is.
Oh, yeah, because I'm the actual, like, official, you're right, because I don't need it for anything super specific right now. You're right, I'm the experiment in this case. Rest init now creates a thread for the init process. We need to spawn init first so that it obtains bid 1. Oh, yeah. And if it gets bid 1... Wait, that means it's a child. Wait, right? Because you said that. Wait, the parent returns 0. The child returns the parent.
The child gets 0. I think the parent gets the process ID of the child.
Oh, which is 1. You're right. So this is okay. So this is the parent then. Okay, you want it to be the parent. However, the init task. You're right. I always keep reversing stuff, but you always remember the correct order. Like when I thought 0 was true and you had to remind me today, you're like, 0 is false in programming. Like, oh yeah.
Yeah, I mean, I was kind of half paying, half paying attention, 90% not paying attention.
And then you caught that. You weren't even paying attention. You're like, what?
I was like, that doesn't feel right. I was like, who idiot did that? Wait. Did an idiot do that?
It was me. Damn, that's sad. Because it's like you weren't even paying attention to what I was saying and you still caught on that I said something weird. That's funny. That's awkward. Oopsie. Don't worry, I won't ever make that mistake again. This is the last time. I made it once, I made it twice, but I won't make it 3 times. Just watch. However, the init task will end up wanting to create k-threads, which if we schedule it before we create k-thread will, oops. Amazing. I bet this isn't real code comments, this one. I like the oops with oops. Okay. PID equals user mode thread. Kernel init null clone fs. Whatever that is. The kernel init parameter passed to user mode thread. I wonder if
it's an actual acronym for a real error.
Oops. As an error would be amazing. It'd be so cool.
I wonder if there's an error that's an acronym for.
I don't know. If I made my own OS and my own kernel or whatever, I would definitely include oops as like official stuff. Like if something goes wrong, you just get an oops.
Maybe it'll be like out of something.
Oh, you mean like a real acronym? Like he's not joking.
Yeah.
Like that's awkward.
Yeah, when it gets like a real acronym for something.
Says an actual real comment.
Oh, it is? Oh my god, no way.
Yeah.
Well, oops.
I didn't think it was fake. It looks real.
It did? I thought it looked like a joke. You have Linux source
Civitator
downloaded?
says I have Linux
Dang,
source downloaded for
secret-
some reason.
Actually, it's even funnier. The fact that it is real, it makes it even better, and almost makes me want to switch to Linux. Almost. The kernel init parameter passed to user mode thread is a function that finishes some initialization tasks, okay, and then searches for a valid init program to execute. This procedure starts with some basic setup tasks. I will skip through these for the most part, except for where free init.
Nibish990 says Linux dev comments are spicy.
Spicy! Like, no, this is awesome. I love this. It's spicy as hell. Spicy beans. Where init, and this mem definitely must stand for meme and not memory, because what exactly? For where free init.
No, it stands for mems.
Mems, yeah, is called. This is where the kernel frees our init sections. Free init, free the memes. I get it. Free the initialization. Free the initial memes. Now the kernel can find a suitable init program to run. We try each of these until one succeeds. Wow. Nice. The bourne shell can be used instead of init if we are trying to recover a really broken machine. Damn. If execute command, return so much code, run init process, execute command. If not, return 0. Even though I don't know what this does, I don't know, I'm still looking at it, because maybe I'll notice something interesting. Panic. Press it init. And now I know what these are. These like /s/d. These are for, I don't know, I forgot what they're called, but they have a special name. Those are the things that you like replace the variable with. They have they have a special word for them, but I forgot what they're called. Format somethings or something.
Yeah, it's like I mean, by the way, that's percent, not slash.
Oh, sorry, percent. Well, it's slash with two little O's on both sides. So halfway, right? Well, like 25. What's 1/3? Like 0.333% correct, because I had it's kind of a slash.
That's very close to 1/3, but it's not 1/3.
Oh, okay. Sad.
You just need more threes to make it closer to 1/3.
Damn it. Okay, 0.333333333.
That's still not 1/3.
But it's close enough for our purposes. Execute command, return. Reds. This is called red.
It's like maybe within one floating point step of 1/3.
Mm-hmm. I forgot. I think the D's for, I don't know. I was like trying to remember which one's which. Like D's decimal, but no, maybe not. What is S? I forgot which one. All I remember is C.
This is all stuff that I couldn't be bothered to try and remember.
I know C is constant. That's it. No, I think D is decimal. Like I think it's used for floats and double. No, D's double.
Constant. Wait, why would they have? Wait.
What?
Wait, they have one for constant.
They have one for constant. Wait, no, not constant. What am I saying? I meant char. Sorry.
Oh.
That's what I actually meant.
I was about to be like, how do you?
Wait, they don't have that constant. Bro, I don't know what I'm saying. No, I meant char. Bro,
yeah,
I'm
I was like,
losing
you can't tell the difference between what's a constant and what's not a constant.
Don't you
Says
listen.
C is char, D is int.
Once it
Yes.
pops
Oh
up
yeah,
on the
D
side,
int.
you don't
Oh,
know it's
int?
constant.
For D is int. No way. Oh, crazy. S string.
Yeah.
I'm
Yeah,
sorry.
because that makes sense, right? S is for string,
Well, that
C
makes
is for
sense, yeah.
char,
Adam
and
says
D is
you
for int.
unsigned.
That makes
F
sense.
float,
D doesn't
LF
int for
double.
int makes like my head hurt.
Yeah. Can't you find the letter D in the word int?
Yeah, exactly. They're identical. Wait, F? Oh, you unsigned. IF double? This? Oh my god. Okay. Oh, I was gonna say, like, I accidentally said constant instead of char because, remember, I'm an LLM, so sometimes I hallucinate every now and then, but once you correct me, I'm like, oh yeah, you're right. My bad. If config default init.
Yeah, that's why it doesn't stick, because you teach an LLM and it forgets.
Exactly. The next time you make a
that's why you're still
give it a
that's why you're
prompt.
still in like 4th grade or something.
Yeah, limit it. limited memory capacity. 0, return, run initialization process, config default init. If
Yeah, it's limited life memory.
exactly per default init string failed error. Well, I guess now we know this is a int D. No, really? Oh my god. What are these things called again? What's their name?
Squiggly wigglies.
Nah, not squiggly wigglies. This time.
I don't know.
But I'm
Format?
happy. I'm happy
Format.
you said squiggly wiggly. That's with the curly brackets. Oh yeah, format.
Formatted, great.
What'd you say?
Formatted, I think.
Well, I'm sure if I just go C format. Oh, format specifiers. That's what they were.
Format specifiers, yeah.
Yeah.
Which
F float.
really,
Damn
like,
it, D is
on
so weird.
a literal level, they don't mean anything. It's just that the function interprets them in specific ways.
Yeah, I'm trying to. There's actually a lot more than I thought there would be.
The function that they're calling those things, it says do this thing.
Exactly. But yeah, I'll remember this one as like integer. I'll just pronounce it like that because it's a D. Integer.
No, you're gonna forget that.
No, I won't.
Oh, you're gonna forget that.
Integer.
You're gonna have to look at this documentation over and over and over.
It will not happen. I'll remember because integer is such an important type.
No, you're gonna be looking back at this page for at least another 300 times. Nice pin, by the way.
Oh, I didn't mean to do that. Thank you. Wait, Linux dev comments are spicy. Well, that's true though. They are spicy. All right. Oh yeah, I'll have long.
I don't know. Why do you keep accidentally pinning things?
I guess I'll call a double. Lafubble
Hey,
now.
look, your slave is here.
What?
Why do you have so many ads? Where's having your ad block?
My eyes.
Oh yeah. Oh, that's burn your eyes. Damn. Oh, listen, wind. You showed up at a great time because we've just been talking about Linux nonstop, and then I've been talking about the beans. Like remember, like are those the motherboards? Like I shared that with everyone because it's awesome, and I'll never forget it. And I'll turn off the ads now. Don't you want some Tylenol? Don't you need some Tylenol? I'm sure you do.
Your slave doesn't need Tylenol. They're fine.
Damn. They're not my slave. I'm like your guys' slave, if anything. So,
Given that mark next to their name instead, they're obviously the slave.
Okay, hold on.
That's the mark of a slave.
Give me a second. I'm turning on my ad block so that wind eyes don't burn because I care about everyone. Your eyes, I care.
So they say.
I do. Mm-hmm.
But they also burned your eyes out.
I just don't care when I'm not using night mode and your eyes burn. That's the only time I don't care.
Crazy. They hate you. They hate you.
Is there a neural program?
Freedomdeo says ads are a neural program.
Oh. Okay,
Me personally,
extensions.
I wouldn't take that level of disrespect.
Alright, I have my ad block on now, so yay.
That's crazy.
I know. You're welcome.
Hello?
What?
Oh, what the fuck?
What?
Why does this shit suck?
Well, we don't need this page anymore. But you know, I'll just call these the doubles.
I keep getting disconnected from the call.
Well, that's a skill issue. So.
Yeah.
So I'm gonna start calling doubles lafubbles now, so I can remember it's %LF for double. So we have integers and lafubbles. Nice. Default init return else return 0. By the way, if you're here, Win, this is like part of the startup for Linux. This is like part of the, yeah. No, not format strings. The code itself, like, is part of the startup for Linux.
Says format strings.
And look at this code comment here.
Wait, that function's called panic. Nice.
Oh, wait, where?
With the format string.
Where'd you say that? Panic?
I
don't see it. I'm blind.
What?
Oh. I don't see anything.
It's on the 10th line in that big block.
Which 10th line? Oh, it is called Panic. Amazing. Good name. But look at this, Wind. This is an actual code comment in like the actual Linux code. It says will oops, which is I think is amazing. Like will oops, it's like you wrote this code. Anyway, default.
They're calling you unprofessional when they say that, Wind.
I'm not. Oh wait, no, I'm not saying that. I'm saying Wind is awesome and Linux.
Oh wait, yeah,
the coders are awesome. That's no. Pre-RR default init. Oh yeah. String, so integer, config default init, return, ret, whatever.
Indigenous.
Else return 0. If not, try to run init process.
Yeah,
Okay,
indigenous, indoctrination.
Ors, return 0.
Industry.
Which is... Oh yeah, and also... Well, never mind. No, I won't say this right now. I was just going to say that I forgot that... I was going to tell Win that I forgot 0 means... Give me a second. That it means false, and I thought it meant true again, but then I had to be reminded by you that it was like... That's wrong.
Yeah, they were stupid.
Civitatum says integer
it happened
is a
again.
Integer as opposed to integer or an inoeger.
Exactly, integer. Decimal oh, okay. Oh, it's a decimal integer. As opposed to what integer or integer. Oh no, there's more types of integers. I'm sad now. Integer, integer.
Yeah, what about the integer?
Oh no.
The integer.
What are these other ones? My head. I need that Tylenol in the ad. I need the Tylenol. I think return 0 and this one means no error.
137 says I think return 0 in this context means no error.
Yes. It does. And what they're talking about is there was a whole thing before about page files, and they said that 0 means like active or whatever, like allow write, and then 1 means don't allow. And that's like, that doesn't make sense.
Civitatum says an integer does not exist. Feels dank, man, I think.
Integer. Oh my god. Panic. No working init found. Try passing init equals option to kernel. See Linux documentation. Oh god, admin guide. Because I'm sure this will be, whatever this is linking to is going to be really easy to read and fun. RST for guidance. Screw that. On Linux, the init program is it's almost always located at or symbolic linked to sbin init. Oh yeah, isn't that? This is one of the things being passed to this thingy. Try to run init, not try to run init process. Common inits include systemd, which has an abnormally good website. What the? OpenRC and run it.
Blind 137 says, are you learning about Linux now?
No, it's just part of this. It's just part of it, so I'm reading about it.
Learning about CPUs.
It's about, like, I'll show you the website's real name is, it's CPU Land, putting the U in CPU. It's just chapter 6, so I have to read the Linux stuff, okay?
Says, I think I pronounce it systemd.
Systemd, oh, okay, I'll call it that, systemd. But yeah, it's just, yeah, oh, I guess it does say how Linux loads executables, so I'm kind of stuck with it, but.
Well, too late now, you wasted your time.
No, it still learns something about how a computer does. I mean, Linux is still a computer, so...
Linux is not a computer.
Yeah, well, you know, it's part of a computer, so it has computer-related things, so... Yeah, I'm sure not...
My computer does not have Linux.
Well, because you're lame. Like me. So. Common is... Oh, yeah. Good. OpenRC, run it. Kernel init will default to bin sh if it can't find anything else.
You can run Windows.
This is the last one it checks or does whatever this is.
Line 137
if you really want
says,
to, you can run Windows 10
in Unity for a moment. What
I would not want to do that.
Linux is in fact new/Linux.
Oh yeah.
Or as I've recently taken to call it, new plus Linux.
Okay.
Yeah,
that.
Linux is
new
not
plus
an operating system unto
it's
itself,
the kernel, right?
But rather another free component of a fully functioning GNU system made useful by the GNU core libs, shell utilities, and vital system components comprising a full OS as defined by POSIX.
Oh, this is me. Oh, you like copy? I was like, no way, did you just like write all that? That sounds like ChatGPT. When I'm like, what is Linux? And it sends me that. So that's okay. Okay. New plus Linux. To learn computing started at the beginning, go way back in time, 1940s and World War II, and the Enigma, yeah, being cracked. That's a movie called The Imitation. Oh, really? There's a movie all about that? Then I'll have to watch that sometime. I wish I could watch it on stream, but I feel like that would not be good.
Yeah, you get sued instantly.
If I want a clean record, or as clean as I can.
You're going to be $100 million in debt.
It's very funny. The bot reads the whole copy pasta, and she has to just listen or talk over it.
I do. I'm used to it, but yeah, there are times where every now and then, it doesn't happen too often, but every now and then I will mute it when it like annoys me enough. Crop knows that. Like if I get annoyed enough, I will mute it for like a limited period of time so I can actually like collect my thoughts. But yeah, lol. If you can't find anything else, and I can't find BNSH, something is terribly wrong. Damn. Mac OS has an init program too.
Says, hey guys, did you know that?
What was I? It's called Launch D and is located at SBIN launched. Okay, try running that in a terminal to get yelled at. To get yelled at for not being a kernel. Hey, everyone should try this then, so they can get yelled at for not being a kernel. That's cool. Oh, I thought this was funny too, when, wait, where is it? I like this.
Says I started in 2022 with Python, then in 2023 I did IBM Quantum, and in 2024 I made this program that scans for gold using quantum computers, and it discover about 35M so far in the past 24 hours. Just don't take no when they tell you it ain't possible.
What? I'm like not even sure if it's like, is that real? Is this real? Is it corrupt? Is it? What do you think? Quantum.
I think they're just one of those bots that's trying to get you to buy free followers and go to their OnlyFans or something.
No, they're not. They've been commenting earlier. No, they're not.
They just want you to go to their OnlyFans. They say if you give them your credit card information, and they'll give you 1 million gold.
No, that's not gonna happen.
Freedomdeo says I can see Oman voice.
I have all this gold. You're gonna get free Robux.
But anyway,
it's a scam. Don't trust it.
Yeah, maybe sometime Freedom, but for one, well, Corrupt's here because he's helping me with assembly. That's why he's here right now. Say hi, Corrupt. But you're here. Yeah, he's helping me with assembly. That's why he's here. Also, because I only VC with people who are at least 18. Just so you know. Anyway, so sudo, let's see a cool, oh yeah, I just thought this was funny. When I want to see a cool instant black screen, and then it just says sudoku 1. That looks fun. Okay, I'm almost at the bottom, so it's almost over. The pain, the suffering, it's almost over.
Yeah, what are you doing after you finish reading this?
I guess I'll continue tutorial point for assembly, since you're around.
Freedomdeo says it's actually easy to scan for gold. If you go to the beginning.
Sudo RM. What? That looks bad. When no preserved roots.
All computing /Linux /history of Kintug. Information theory. We built everything around this theory.
It's probably like remove, reformat.
Is it probably like don't just delete everything and then you'll never get it back? Is that I don't know. It looks bad. No preserved root. It looks real bad.
The flash on Linux is the root folder, so the very top of your computer, and basically just saying delete the entire computer.
Why are you even allowed to give that command? Like Linux is too powerful. It's good that I'm not on Linux, because I probably would put that command in. Like, someone would send that command to me, and they're like, if you do this, you'll get more RAM. And I'll be like, oh, nice, let me copy and paste it into my terminal. And then it's like...
says at wind 137 you forgot the Motechno 20 pseudo.
Because then I'd be sad. It's like, no free RAM. It's like, oh, I just delete everything and can't get it back. That's sad. Yes, sad. Oh my god! Did they really write this in the actual Linux code? Look at this. This is spicy. No way. I bet they did though, but wow.
Well, yeah, it's not that surprising.
Well, no, it surprises me.
Techno 20 Runas Administrator, Techno 20
Dude,
Runas Administrator, Techno 20
Sudo kill
Runas
1
Administrator,
probably
run
doesn't
as
work if you're running on
administrator.
Yeah, you need the triple shield for that one, but like, or more than three shields. Wait, what were you gonna say, Crash, about this? That's crazy.
But I mean, yeah, just run as administrator. It'll work. It'll be good.
Okay. Oh, wait, I want to show you one other. I know I keep going off on tangents, but this part's really funny. Like this part in the beginning of it. Look at this. It says,
but your friend called me a bot. I can come on voice at salttoserenity.
Nah, bro. No drama.
Freedom, I don't know if you noticed. I don't know if Salt noticed either, but it was like literally like all just a joke.
Yeah, he just joke around a lot. But anyway, this part. Wait, look at this. He says, read chapter 3.
Because, I mean, the whole thing. Well, I mean, the whole thing is they're just trying to get you to pay a ransom to get your
yeah, like WannaCry or something. But
like we have this prince here. He doesn't remember his name. He doesn't remember where he came from. But we know he's yours. Just pay us a ransom and we'll give him to you.
Freedomdeo says, cause I ain't no bot, but I can promise you got the most powerful bots in the world.
Anyways, so this part's funny. It says, read chapter 3, I guarantee you will learn something new, unless you're like Linus Torvalds himself. Also, Linus Torvalds called me a moron. Because look, wait, I read this earlier, but you weren't here, Wayne, if you're around. Wait, where is it? Wait, did he not say moron? Was it idiot? What was that quote? Remember that quote? Where was it?
Called you a fucking retard.
He called me... Where is that quote? Was it on was it the previous page? No, it probably was. I didn't realize we read so much so far. There. Anybody who doesn't... He says anybody who doesn't get this is a moron. End of discussion. So I'm a moron, because I didn't get it. Ever. Well, yeah.
Yeah, you're just dumb.
I'm a moron.
Just don't.
Just if not get it, then don't. Just don't.
Be a little bit better than that.
Yeah. So, where was I? Okay, now for real, I'm gonna actually finish reading this because I'm almost done. Except, I'm gonna skip this word. So.
Freedomdeo says Linus Torvalds is also a moron. He doesn't understand anything about quantum computers or a quantum kernel LUL.
Init program is almost always located. Oh wait. From this point on, we're at step 4 in the boot process. The init process is running... Oh yeah, this is where we are. The init process is running in userland and begins launching various programs using the fork execute pattern. Okay. Fork memory mapping. I was curious how the Linux kernel remaps the bottom half of memory when forking processes. So I poked around a bit. Kernel/fork.c seems to contain most of the code for forking processes.
Says I was looking up all profanity pronounced on the stream in the Linux source code comments and it is all there.
Oh, you searched for they got everything in there? That's spicy. You think? I don't know why, but I would have thought that they would like keep the comments for their personal copies of Linux, the code, but then when they like release it publicly, I thought they would like, you know, delete them or replace them with something else. I don't know why, that kind of surprises me. Cause like you know, the whole PR thing, right? PR. Like, wouldn't the PR department not like this? But then again, I guess they are like a open source project thing. Kernel fork C seems to contain most of the code for forking processes. The start of that file helpfully pointed me to the right place to look. Okay. Kernel.c. Oh, fork C contains the help routines for the fork system call. See also entry.s and others. Fork is rather...
Freedomdeo says we have no PR department, that's why our code is actually good and our systems actually work.
Yeah, that's a good point. Fork is rather simple once you get the hang of it. But the memory management can be a B. Oh, cmm/memory.c.
Salt here has a PR department, so that that they have to
Copy page
worry about.
range.
That's why their code is bad, and that's why they can't say these things.
Wait, what? Copy page range.
You should fire your PR department.
Oh, mine?
Yeah.
Copy page.
Yeah.
Okay. Copy range. It looks like this copy page range function takes some information about a memory mapping and copies the page tables. Interesting. Quickly skimming through.
Freedom says in programming though PR means pull request.
Oh, I didn't think about that.
they can't allocate the PR to public relations or anything like that because
What?
because it means something else, so they can't have a
in
PR
your mind.
Nice.
In your mind. Yeah. Oh, wait. No, but that's bad. If I fire the PR department of my mind, I'm going to be kicked off Twitch in like a day. From all the reports I get. Like, hell no.
So,
I need this PR department in my head. So,
no, just fire the PR department.
no! That's bad. The PR department does good work.
What do they do?
Stop me from getting banned. Instantly.
They 90 days for you? That's great. You don't get banned for saying that.
Well, if you fire your PR department, you get banned for... You know, you can't
Just
say
don't say
anything
negative.
you
Just
want.
don't-
That's why you need the
just
PR
don't-
department.
don't
Trade the PR
say-
department for a
no,
new
don't
department
say
called
negative.
Chill Stream Department.
Freedom
That's all
Deo
good.
says trade the PR department for a new department
I
called
mean,
Chill
it's very
Stream
simple.
Yeah,
Just
but
don't
if
say
you-
anything, don't do
you know-
this, don't flash if it's on stream, don't do any of
It's
that.
simple. It's simple. If you modify, if you go low level and mess with like kernel code, mine kernel code, you might f up, and then brain.x might not reboot ever. You know what I'm saying? Like, don't mess with.
I tried that.
You don't
at
mess
some
with
point.
the
It was
PR
actually
department.
really
Don't
hard
mess
to
with
break it
stuff
that
there.
badly. I tried that before. It was really hard to break it that badly. I couldn't do it.
Yeah.
I did.
Looks
manage
like-
to do some other fucking-
Quickly skimming through the functions it calls. This is also where pages are set to be read-only to
Freedom
make
Deo
them cow
says Twitch
pages.
generally don't ban streamers unless they dangerous acting or something like that's why I don't stream when I have psychotic episodes I stop.
Ah. Let's see. Skimming through.
Yeah, I mean,
It checks whether it should do this by calling a function called
like I said,
is cow
at the end of it,
mapping. This is where pages have to be read-only to make them cow pages. Okay. Read. Oh, yeah, because that's such a read-only. Is cow mapping is defined back in include Linux mm.h or header. I learned that recently, that the h files, because I had to add a library into C. Well, you know, into Visual Studio Code. So I had to deal with this, and this was so annoying. It returns true if the memory mapping has flags that indicate the memory is writable. And the flag returns 0. Wait, it's 0 if it's not writable, right? 1 if it is writable, because 0 is false. Hey, I am learning!
Zero is off. Zero is off. Zero is false.
Well, I'm getting closer, SPQ. No, seriously. Oh, you're the one. I did want to know. I was wondering, like, which of my viewers refers to C++ as the language, and it was you. I just didn't remember who it was.
Tatum says you can basically read C now, which is one step away.
And are you proud of me? I installed. I literally spent like 12 hours in total, because it was like 6 hours to use C in Visual Studio Code, because I had to like link to the compiler or find the compiler on my computer, and that took like an age. And I had to decide like which compiler I wanted to use, so I decided to use MSVC just because. And then I had to install a whole library, but the library wasn't written for MSVC.
Yeah, they made it hard on themselves by using
Yeah.
VS Code instead of Visual Studio.
Yeah, the library was written like for the Linux compilers, like it was for like GCC or something. So then I had to go find a version that was compatible with MSVC, and then I had to copy and paste stuff, and it was a nightmare. It was a lot of
says,
work.
it's a nightmare. See, it's too much work. Just use Python.
I mean,
only
Python
now.
gives me a headache for a completely
just
different
code everything
reason,
in
but
assembly. Just code everything in assembly.
that's a horrible idea. I am not coding everything in assembly. Maybe that would end my dreams of being a programmer. If I was forced to only use assembly, it's like, well, it was fun. It was fun while it lasted. I am screwed. Yeah, because how am I gonna write Doom in assembly? How? I'm not. I mean, some people could, but me do it? No.
Freedomdeo says I can write programs in
That's just
Python in
that's just a
seconds, then takes you months.
now that's just a skill issue. They just I
Skill
mean, if it
issue.
takes
Mhm.
them months, that's because they're just bad.
Yeah, it would take me months to do simple things. So you didn't switch from SBC to GCC.
Civitatum
Oh,
says
I
so
made
you didn't
you.
switch from MSVC to GCC.
No, I
was
found.
just about to
I just
become
played.
proud.
I played with things until I could get it to run in MSVC, but it actually took a significantly long time, and yeah. So I was punished in a way for trying to do it like that instead of just using GCC. I could have just done that the easier way.
Freedomdeo says let's compare repos, homie. My GitHub Graylan 0 GitLab is Graylan 01. Let's go.
What?
Skill
There's
issue
not.
LUL.
Wait, who's this guy? Because if you're talking about, well, me, I don't have anything to show because I suck and I'm just starting to learn.
I don't really save anything to anyone.
I was gonna say, and if you're talking about corrupt, then all I have to say is, ladies, you're both pretty, okay? You are. It's not a comparison thing. We're all here to learn. So, where was I? Is how mapping is defined back in include
Freedomdeo says
Linux
no, I'm talking
mm.h.
to the dude who said it's a skill issue if you
I
take
say
a month
that
to code
because
something in
the
C.
thing
He
that
always
takes the
says
most-
that. It's a
the
joke.
most
And he's
time
talking
in
about
coding
me,
usually
not you.
I mean, you can code some things faster in Python, but Python is also limited in some ways. You could do things that in C that you can't do in Python. But what takes the most time isn't coding the thing; it's figuring out how to do the thing. And you spend more time thinking than you do actually coding.
Yeah, and he was talking about me. He's saying, like,
so
I have a
coding
skill
in
issue because
language
I
that
would
makes
take
it
a long time to
faster
code something.
only makes it faster if that can really balance out the amount of time that it takes you to think about it. It doesn't make it that much faster. It's all just the
But
thinking
yeah.
that takes the most. It's like if it takes you months to solve the problem in the first place, it's not going to make it faster to solve by coding it in Python, and that's the thing.
But anyway, is come mapping to find back and include Linux mm.h and returns true if the memory mapping has flags that indicate the memory is writable and isn't shared between processes. Let's find back in it. Okay. True if the memory mapping has flags. Shared memory doesn't need to be cowed because it is designed to be shared. The memory is writable. Okay, I see. Admire the slightly incomprehensible bit masking.
Freedomdeo says what I'm saying, me personally, I can solve it fast in Python. It will take infinity almost in C. C would be doable, but then again, it takes 500x longer.
Paper rape. What's a pip? The solved? Yeah. Well, Python's really popular, I know, because it is a lot less wordy than other languages, and you can code up solutions to things.
Freedomdeo says
quicker.
pips are like packages for code.
Oh, that's what you called your libraries, right? You call them pips.
So your solution to all of your problems is just use other people's code. That's really all it is. So your whole argument is just saying
we had a pip called Twitch
use someone
and
else's
it can hook
solution.
Twitch chat to your program.
Well, in a
Or
lot
use
of
a bunch of other
cases,
people's solutions to solve
it can
your
be a lot
problem.
faster.
So, yeah,
But you
of
just
course
have
that's
less
going to be-
power to
Yeah, of
customize
course
the
it's going
code,
to
of
be.
course, but it can be faster to just borrow. Like when I was doing a game
Yeah,
jam.
like, that's I mean, it's not a bad thing to do, but of course
Yeah,
it's
of
of
course.
course that's really the same time. If you had but like if you're talking in
Freedomdeo
C, if
says
you
yes,
had
use
those
other
same
people's
kind of
code.
libraries in C,
Stop
it
being
wouldn't
silly.
take that much longer to do it. So that's the thing. Is you're just using the example is just because you have all those libraries.
Well, there's a
It's
place
not about the
for
language, it's about
everything.
the
Freedomdeo
resources
says if
kind
you
of
can't
available
cooperate
in
with
that
other
language,
devs,
like in that ecosystem.
that's a skill ISIS.
Like I said, there's many ways to solve. That's what I like about programming that makes it really exciting for me is like the idea that like there's many ways you can do something. Like you could use a library that's like coded nicely. You could try to make your own, or you could grab someone's code and then you could like tweak it. And you know, the sky is the limit. If the computer runs it, it's a possibility, even if it's not efficient. Like it's exciting. I think that you can just try things and see if they work. Like, that's what excites me about computer programming, is like, maybe it'll work and maybe it won't. Maybe it's a good solution, maybe it's not. But because everyone comes up with their own solutions, it's fun, like, learning what every person's solution is. Because then I get to learn about how other people solve problems, and it's usually much more efficient than the way I solve problems. That's what's fun.
I have a challenge for you, Freedom. Write a
God,
LangChain
no.
Xampp program and make it run as
Please.
fast as you possibly can.
Wait, what? What is it?
Freedom, make a LangChain Xampp program and make it run as fast as you possibly can.
Make it run. Right, what?
With an arbitrary rule set. So,
Wait,
like,
what
the
am
user
I?
can
What is
basically
it?
pick a rule set.
What are you?
I'm talking to Freedom.
Freedom Deo says, in no way
Oh.
am I saying to not code C or C. I'm saying to understand what the potential of each toolkit is. C is great for a hardware thingy that needs moving parts.
Yeah, if
right.
you want to get low level and optimize
But then
graphics
if you try
and
and
stuff.
code a Twitch IRC bot in CY, Twitch.io exists and takes 5,000x less time.
Yeah, that's why, like, I personally am learning multiple languages. Like, I am learning Python because each language does different things better and can save you time depending on what you're doing.
Something that'd be really good.
Python,
Is
C,
if there,
C Sharp.
someone,
I love all of them.
Maybe it exists somewhere. I haven't really looked for it, but it'd be good if there's like one language that they would have used libraries and stuff from pretty much like every other language out there.
That would be cool.
Like,
But remember,
if you could have a language that could load in Java libraries and C libraries and Python libraries and C# libraries all in the same program, that'd be really good.
Well, the closest thing I can think of, remember when I told you about there was this guy who's trying to invent a new programming language, and he's trying to make it from scratch, like from the ground up, but he doesn't know if it's going to be successful, but he's going to do it. He says he's going to do it in the span of a year. Like,
well, if they want it to be really successful,
yeah.
If they want it to be really successful, that's a good way. That's a good place to do it. Is to get it so that they can run. They can load Java, C# and Python libraries all in the same code, and interrupt between them like really easily. If you can do that, that language is probably going to become pretty damn popular.
Freedom Deo says, yeah, exactly.
I'm doing
I think you are
exorcism.
doing L33T code at salttoserenity, not to be harpy on complain. With me it's all a series of questions to engineer anything. Ask the questions in the right way, I think then ITLL do amazing things.
Well,
You
I
will
know
be
I'm
shocked.
filled with questions.
Just keep
very little
asking.
answers, which makes
Then
me a
you
little
keep
sad.
building upon the shoulders of giants.
Oh my god. The way that line showed up in, like, I'm thinking of like a song where that like line, that exact line showed up. Okay, so alright, I'm almost done. I'm so close to finishing this thing, and then I don't have to read about Linux again. Shared memory doesn't need to be cowed because it is designed to be shared. Right. Admire the slightly incorporated bit masking. Have you ever heard of this term before, bit masking? Because this is my first time seeing it. Oh, what is bit masking? Just curious, like, what would you say it is?
Bit masking is related to binary operations, so like bitwise AND, bitwise OR, and all that.
Okay.
Which is what they're doing. They're doing
bit stuff. Cool. Static inline bool is cal mapping VM flags to flags. Interesting. Okay. Return flags and VM shared. Oh wait, one hyphen versus. Oh wait, I get one is XOR and one is OR. So this one's probably OR. Double is probably XOR, I guess. VM.
XOR is caret.
Really?
XOR is caret.
Oh.
Double
and one.
Double is short circuiting OR.
Oh,
Freedom Deo
okay.
says, my point with the pips.
Which is a
Imagine
Boolean
some
thing,
ninja
not a
coders
bitwise
build
thing.
you amazing things. You get to stand on their shoulders. Don't be ashamed, be proud to have your capability elevated so high. And ITLL reward you. I got in a lot of trouble lately not listening to my inner hacker. Listen to the hacker inside ITLL guide you. 3.
Return flags and VM share. Non-bitwise OR, because you said 1 is non, 2 is bitwise. Wait, no, but what am I saying? Oh my god, I'm hallucinating. I'm sorry. I didn't mean to say that. I meant 1 is short circuit and 1 is not short circuit. And
one is short circuit and one is not short circuit.
Oh
okay,
no, I meant
both,
one. One is short circuit. 2 is non-short circuit. My brain's short circuiting.
No, you're still wrong.
Jesus. Well, that's actually what I meant
Potato
originally. Is
says it
one
will
is.
evaluate to a
Oh
true
wait.
or
One
false, and
one
when it
is
gets
not
converted
short
back to it,
circuit.
you get 1 or
2
0.
is short circuit.
Okay. Good. One. Okay. 2 is short circuit. Okay.
Yes.
Yes. 2 short circuit. 1 is not. VM shared. 1 is not. Not short circuit or VMA right
Potato
is
says is
equal to
short circuit.
VMA right. Well, yeah. Return. So I'm guessing like this is a boolean too. Like these are all booleans. Everything's a boolean.
Wait.
Short.
Why?
What are you saying?
Wait. Why? What is going on here?
What is what going on?
Wait. Why
Double?
is VM shared? Wait. Why
Oh,
is
you're looking at
VM
the code?
shared here? I'm looking at this and I'm like,
What's weird
VM
about it?
shared doesn't need to be there. I don't understand. I mean, unless
What?
well maybe VM flags is
Uh-huh.
something else. Maybe that's not just like an integer or something. But if these are all just integers, VM shared doesn't add anything to it. Like whatever you could make VM shared literally anything. It doesn't change the result.
I thought these were all booleans. Like I thought flags. Well, I don't know. I thought everything is a boolean. Like this is a boolean, and I don't really know though.
Oh wait, no, never mind. It would. It does. No, never
okay.
mind. I understand.
It will evaluate
If
to
there's a bit
true.
if there's a
or
bit in VM shared
false, and when it
and
gets
in
converted
flag,
back to int, you get 1 or 0.
right,
Oh wait a second.
never mind. I understand that.
Double is a logical operator. Short circuit. It's a little different. It will evaluate to true or false. Wait, true of false? I get true or false, you mean? It's true or false, right? And when it gets converted back to int. I'm thinking, evaluate to true or false. Back in kernel fork C, doing a simple command F for copy page range. Oh, and I should have said what I was reading. I was actually talking to USBQ earlier. I was like, that's why I said true or false, or it says true or false. Anyway, back in kernel fork C, doing a simple command F for copy page range yields 1 call from the dup map function, which is in turn called by dupmm, which is called by copymm, oh god, which is finally called by the massive copy process function. So these are all calling, why so many things are calling each other? It's too much. Copy process. Wait, yields 1 call from that, which is in turn called by, Jesus, it's called by wait, if it says yields 1 call, doesn't that mean, does that mean it returns? Wait, what is that? Or does that mean the function's just inside of it somewhere? That's what I thought it means. It's just like dup map is just a function inside somewhere here.
The dup map calls copy page range once.
Oh, this calls. Okay, thank you. This calls that. Let's see. Just called. Centered. I see. The English was just really confusing to me, which is called by mm, which is finally called by the massive copy process function. Copy process is the core of the fork function, and in a way, the center point of how Unix systems execute programs. Always copying and editing a template created for the first process at startup. Oh, okay. Cows. This is such an old YouTube video. In summary, so how do programs run? Nice, just a summary. So this part's easy. This is no code. On the lowest level, processors are dumb, like me. They have a pointer into memory and execute instructions in a row, unless they reach an instruction that tells them to jump somewhere else. Yes. Besides jump instructions, hardware and software interrupts can also break the sequence of execution by jumping to a preset location that can then choose where to jump to. Processor cores can't run multiple programs at once, but this can be simulated by using a timer to repeatedly trigger interrupts and allowing kernel code to switch between different code pointers. programs are tricked into believing they're running as a coherent, isolated unit. Direct access to system resources is prevented in user mode. Memory space is isolated using paging, and system calls are designed to allow generic input-output access without too much knowledge about the true execution context. That's really cool. System calls are instructions that ask the CPU to run some kernel code, the location of which is configured by the kernel at startup. Let's see, but how do programs run? After the computer starts up, the kernel launches the init process. This is the first program running at the higher level of abstraction, where it's machine code. It doesn't have to worry about many specific system details. The init program launches the programs that render your computer's graphical environment and are responsible for launching other software. To launch a program, it clones itself with the fork syscall. This cloning is efficient because all the other memory pages are cow, and the memory doesn't need to be copied within physical RAM. On Linux, this is the copy process function in action. Oh, I see. Both processes check if they're the forked process. If they are, they use an execute syscall to ask the kernel to replace the current process with a new program. The new program is probably an ELF file, which the kernel parses to find information on how to load the program and where to place its code and data within the new virtual memory mapping. The kernel may also prepare an ELF interpreter if the program is dynamically linked. Oh, so the interpreter only matters if it's dynamically linked.
Nibish990 says, is that like parent/child?
Yeah, parent/child, exactly. Yeah, ELF is like yeah, that's right, the Linux version of...
Nibish990 says an executable.
How they execute stuff. ELF dynamically linked. I did kind of, because I didn't explain this part well, but I don't really remember why, or I don't really understand why only dynamically linked needs an interpreter and why the static one doesn't, but it doesn't really matter. Because it was, the way they explained this was like really kind of confusing. But everything is like loaded. What was it? It was weird the way they explained it. Let me just think for a second. Because they said for dynamically linked, you load everything, even if you're not using it at the time, but it all gets loaded into like RAM. For statically linked, you only load the parts that are written in the code or something. But then they said something weird like that for dynamically linked. Pieces that are missing have to be grabbed, and that didn't make any sense to me because it's like...
My guess is that if you want to...
What do you think?
To load new things into the program, like in C#, how you can load other libraries in as code.
Oh yeah, it was saying that. It's true. Mm-hmm.
Like at runtime, my guess is that it's something like that. If you want to load more stuff in at runtime,
oh, it'll accept it even at runtime.
Then it needs to be able to interpret it.
Well, that's what they should have said. That's CPU Land should have literally wrote exactly what you said, because that makes sense. It matches what they said, but their explanation wasn't very. I didn't think it was very good. Mm-hmm. But okay, I get.
Cool. It could be like what I said could be wrong, but that's what I would guess.
But it makes more sense than like I can't come up with anything better than that. So, yay. The kernel can then load the program's virtual memory mapping, and return to user land with the program running, which really means setting the CPU's instruction pointer.
Says it will open a dynamic library at runtime and look up the symbols.
Ooh. Symbols. Oh, and which reminds me, the first time I encountered this whole thing with dynamic library and symbols was when I was trying to set up my C library, because I'm trying to use the CS50's library in Visual Studio Code, but I was getting these stupid errors, like with the like it was saying like when I looked up the errors, like, oh, the symbol can't be located and crap, and I was like, oh my god, so freaking annoying. But yeah, it was something like
Civitatum
that.
says the real process is kinda convoluted. I don't fully comprehend it, but there's a nice article
Oh, nice. Maybe
https://lwn.net/.
I'm definitely not gonna read it because I've already been through.
961117.
I've been through enough pain. But I can bookmark it. But yeah, the the kernel can then load the program's virtual memory mapping. Oh yeah, I said that. Blah 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 blah. Oh, which really means the CPU's instruction pointer, setting the CPU's instruction pointer to the start of the new program's code in virtual memory. Epilogue, thank God. Yay. Oh wait, there's still a little more, but it shouldn't be too bad because it's short. Congratulations. We have now firmly placed the U in CPU. I hope you had fun. Did I? Did I? I will send you off by emphasizing once more that all the knowledge you just gained is real and active. Is it? The next time you think about how your computer is running multiple apps, I hope you envision timer chips and hardware interrupts. I will think about that, though, from now on. That was pretty cool. When you write a program in some fancy programming language and get a linker error, that's what I got! This is when I was trying to load the stupid freaking C library I wanted. It was like linking errors, like linker errors all over the place. Like
990 says it's real when something breaks.
Oh, it is real. I got like 1,000 different types of linker error that I had to fix each one. It was absolute pain because I didn't even know what a library was, like what a static and dynamic and all that crap was. So it was hard, but I did it by myself. I did it off stream so that you guys can see how much I was crying, but the tears were shed for sure because it was painful.
Should have done on stream.
Tears of pain, pure pain. Get a linker error. I hope you think about what that linker is trying to do. The linker is trying to destroy my life. Thank you, Everfollowed. Thank you. At least not all things are trying to destroy my life. The linkers are. If you have any questions or corrections about anything contained in this article, you should email me at lexi@hackclub.com or submit an issue or pull request because I learned that's PR because you said that, well, Freemoto, whatever his name was, said that PR is pull request on GitHub. Wait, what is a pull request? What does that even mean? Think you ever followed? Pull request, it means you want someone to do what? What does it mean to pull? Like, look at my issue? The end. What does pull
Means you want them to pull your eyeballs out.
It means what? On Snapchat, on TikTok, oh my god. It's a command. Fetch and download content from a remote repository and immediately update the local repository to match that content. Oh, okay. So it's like pop.
Well, the pull request.
Says that's
pull
a
request
good
sounds like
question.
something different.
I've never used GitHub other than to steal scripts.
Oh, just lol. Okay. Well, let's see what is it? Look, it shows up as the first one somehow. It knew when I said what is that I was gonna say pull request. Proposal to merge. Oh, it is different. You're right. A set of changes from one branch into another. Oh, it's like when you want to add. I feel like it should be called a push request because pull doesn't really make sense to me, but whatever. That's my opinion. Email me or submit an issue.
Yeah, just have push and pop request.
Yeah, I like that. Exactly. Push and pop. And pop's so cute, too. That's the one thing I like about assembly. Pop. Issue or... The end. But wait, there's more, goddammit. Bonus, translating C concepts.
Oh, there's another 6 chapters.
Does not pull
No, there's not.
code to GitHub and open a
Oh, it's a
They
huge...
should be like, oh,
You
yeah,
actually-
there's more. There's
People may
another 6
review the
chapters.
code and
No, you
accept
actually
the
made me panic,
changes.
because if there was another 6 chapters, I probably would just give up here and be like, you know what? No, I'm done with CPU land for now. Because this was a lot. Pull request itself does not pull. You push your code. Exactly, it sounds more like a push request. Like, why do they even call it pull requests? It's so weird. Push your code to GitHub and open a pull request to merge into another branch. Other people may you can accept the changes. Yeah, they should pick different words for that, for pull requests in particular. Because it sounds like just hearing pull requests. If a pull is like taking someone's code and then updating your code base with their code, then a pull request sounds like you're asking for permission to, like, can I please use your code? Is it okay if I download it? Like, that's what it sounds like, but that's not what it means. So I feel like it's misleading. It might be surprising to hear that heap allocation functions like malloc. That's what. Oh, dude! I was watching a video about a guy who made Brick Breaker. He made Brick Breaker in assembly, C, and C++. And he said when he did assembly, like C has malloc, but he said assembly doesn't have malloc. So the first thing he did was he coded malloc from scratch, like a basic version of malloc in assembly. That's what he said in the video. I remember this, and I was like, "What's a malloc?" But yeah, no, we're not heap allocation functions like malloc are not system calls. Instead, heap memory management is provided by the library C implementation, malloc, free, etc. are complex procedures. The library C keeps track of memory mapping details itself. Oh. So malloc does something for the heap.
I like how with init you were saying init is because you didn't want to say initializer, but then for here with libc you're saying library C. You're like the other one you wanted to shorten it, and this one you want to expand it out.
No, I didn't. I didn't want to say init. You made me say it.
No, I was talking about init. You're saying init because you didn't want to say initializer. It's
oh
like
yeah,
too long, but
at least it's closer. It's my version's
libc.
closer to the initialize than yours is init. I mean, I should call this then.
What I'm talking about is how you want to shorten it for the other one. Now you want to expand it for this one.
I didn't really want to shorten it. Well, I just don't like. Yeah. At least my versions are closer. So I could say memory allocation here too, because now I know what malloc is probably memory allocation. But the main reason, to be honest, the main reason I read this out as library C is because sometimes I forget what lib means, but when I see init, I don't know, I just feel like it's like clear to me that it's initialization. But every now and then I'm like, what's a lib? So it's kind of more of a reminder to myself, like, hey, don't forget library. Lib means library. That type of thing.
Obviously lib means liberal.
Sure. Under the hood, the userland heap allocator uses syscalls including mmap, which can map more than just files, and sburk. Nice. Oh, this is a syscall. mmap and okay. Heap. That's so complicated. Bonus tidbits. I couldn't find anywhere coherent to put these, but found them amusing, so here you go. I did not ask for this. I'm not going to understand these jokes. Most Linux users probably have a sufficiently interesting life. Wow, that they spend little time imagining how page tables are represented in the kernel. Jonathan Corbett. LWN, I don't know this. An alternate visualization of hardware interrupts. Hey, look! Look at this. This is assembly. Move racks RBX. I guess RBX into racks. Add racks. Hello, it's me, the keyboard. I have an important message. E? What? I don't understand this. Do you get this joke?
Keyboard interrupts.
Oh, because you're pushing E? That's all. Oh, because I thought, okay, I was confused who's talking.
When you press something like keyboard,
yeah,
it stops all the other code and says, hey, do this.
E. That's cute. And note that some system calls use a technique called VDSOs instead of jumping into kernel space. I didn't have time to talk about this, but it's quite interesting, and I recommend reading into it. I'm not going to do that. Oh my god, it's another 3 links.
Boomer memes feels dank mad.
Boomer memes? I thought this was pretty hip. I thought it was the bee's knees. What are you talking about? I thought it was cool. Oops. I know this is a technique called VDSOs instead of jumping into kernel space. VDSO. Okay, I didn't have time to talk about this. And finally, addressing the Unix allegations. Allegations? I do feel bad that a lot of the execution-specific stuff is very Unix-specific. Actually, yeah, everything was like Unix, Unix this, Unix that. Like, give me more Windows. If you're a Mac OS or Linux user, this is fine, but it won't bring you too much closer to how Windows executes programs. Well, that sucks. Or handle system calls, although the CPU architecture stuff is all the same. In the future, I would love to write an article that covers the Windows world. Please do, because I feel very left out and disregarded.
When was this written?
Not. I don't think it was that long ago, because I saw. Oh, yeah, 2023.
Oh, I was hoping it was going to be a lot longer.
Why?
I told it was going to be a lot longer ago because if it was a long time ago.
Why not? I mean, why?
I mean, maybe they've done it. I don't know. But it was like, if it's a long time ago, then maybe they've written the Windows one already.
Oh, yeah. No, but then it'd be more sad, because I checked, and there wasn't anything more than this, and if it was a long time ago, then that means I gave up. So that
Tatum says you can map syscalls to the user space because this way it is more performant or STH.
Oh, wait a second. Is that what you're saying? Is the, what is it called? A VDSO is mapping syscalls to the user space? Okay. That's cool. Understanding this. Well, that provided. Yeah.
Tatum says some
Thank
common
you.
ones are mapped by default. At least that's how my limited understanding
Okay,
goes.
thank you. I appreciate you saying that because now I understand what it kind of is without having to open up all three of those really long articles because they're probably going to be really long and dense and difficult to read, and I can get a nice like little, you know.
Well, you don't know that. They might just be Reddit posts.
No, sometimes Reddit posts go on forever. Like, oh my god. Acknowledgements. I talked to GPT 3.5 and GPT 4 a decent amount while writing this article. Nice. So hopefully they didn't make any mistakes or, you know, there's no hallucinations that I just committed to memory because that would be pretty sad. Oh wait, while they lied to me a lot and most of the information was useless, oh god, they were sometimes very helpful for working through problems. LLM assistants can be net positive if you're aware of their limitations and are extremely skeptical of everything they say. That's true. That said, they're terrible at writing. Don't let them write for you. More importantly, thank you to all the humans. This is what they was. They're in a hack club. I told you, I said that to you. Hack Club Slack. I don't think it's related to their school though. It's just called Hack Club. See, it's a national organization called Hack Club. You have to be under 18 to join, so I'm not allowed.
CIA.
It's for kids only. You have to be like
Wait,
under
it's the
18.
CIA?
What?
It's the feds?
It's not
Feds
the
are recruiting
feds.
children
No,
now?
but this organization has like an age limit.
Wait, the feds are recruiting children now? That's crazy.
Oh, well, lol. I don't think. Anyway, they said there. Oh, wait. More importantly, thank you to all the humans who proofread me, encouraged me, and helped me brainstorm. I'm not going to read these names. Who drew the wonderful elf in chapter 4. I don't think that drawing was that good, but it's okay. They tried. And my lovely parents. If you are a teenager and you like computers and you are not already in the Hack Club Slack, you should join right now. Well, I'm not a teenager, so I'm not invited. I would not have written this article if I didn't have a community of awesome people to share my thoughts and progress with. If you are not a teenager, you should give us money. Are you serious? No. 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 All of this mediocre art in this article was drawn in Figma. I used Obsidian for editing and sometimes Veil for linting. What's linting? What does Veil do? Oh, it's like something with style? Linting. But I kind of want to get the definition because I've heard this word before come up in like tech stuff. What is linting? A linter program? Oh. Static code analysis tool. Used to flag programming errors. So it's just like a, yeah. Oh.
Corrupt Converter says def linting.
Oh wait, isn't just debugger a better word for this? Like, I prefer that to lint. Lint's weird. The markdown source for this article is available on GitHub and open to feature nitpicks. Okay. Yeah, why does he end his whole article with a sad face?
Corrupt Converter says if you type something like that into Google, it gives you a definition.
Nice.
Because they hate their own code. Everybody hates their own code.
Aw, that's depressing. I read this whole thing, and that's what the ending is. It's just this, like, sad face. Like,
Yeah,
have
they just
fun.
look back and they're like, this sucks.
They're
But I
like-
don't want to do it again because it took a long time.
Jesus, that's too dark. Oh wait, debugger. Oh, that's okay. I see.
Tatum says debugger
Thank
is
you.
for inspecting
One's-
the program at runtime.
I see. One's for when you run it, and the other one's for like when it's just you haven't ran anything yet. but it tells you like your syntax errors and stuff. That's cool. That's a linter. So I could literally show my code to like another programmer and be like, hey, bro, will you lint my code for me? That's a valid sentence.
What are the chances that they would actually say yes?
I don't know. I feel like maybe you're nice, and if
Like-
it was like
like,
short, you
They'd be
might
like,
say yes.
they'd be like, how much are you paying me to do that?
Shoot.
They take one look at the code and be like, okay, so like we're talking $50, right?
Wow. Okay. No, actually, what I think would happen is they would take one look at the code and be like, actually, everything is a syntax error, so start again. Like, there's nothing here that can
They'd be like,
that the compiler can run.
As a compiler,
Yes.
I can't look at. I don't know what this first character is.
Should give them money. Oh
I
yeah,
don't know
just
what
like
this
this
second
kid.
character
This
is.
kid's like, if you're an adult, give us money.
Civitatum
Like-
says they would say you should give them money.
No. There's more to adulthood than just giving money. Like, I don't know. I'm sad now. Anyway,
Hey, it's time to learn about complex numbers.
no, it's not. You lie. Imagine this actually there was like a coding error and the next lesson said like complex numbers. I'd be like, screw this.
No, it'd be fun.
Not at all. Oh, speaking
As
of
long- I mean,
which,
well, then again, it's Khan
Bro, bro, bro,
Academy.
bro.
It might not be as fun.
wait, I just want to say to you that when you said like these problems are like kind of annoying, like there was this one. I think it was this one here. This one, every single answer to every question is mapped to the wrong. Like the questions are mapped to the wrong answers. So I literally had to write them down in a text file, the questions and answer key, because they were all wrong. And it was so freaking annoying. I'm just saying, like, Khan Academy does have some mistakes like that. Like, some programmer probably made, like, an off by one error for the key. And it's screwed up. What? That's
So
not funny.
Everything.
Every
So all the answers were all wrong.
every
Nice.
answer was wrong. And so they were in
how did
total.
how'd you get through? Was it like shifted down one or something?
I copied and pasted every question in the wrong answer so that I would have all the wrong answers.
You went through
So-
all
and I
of them.
and I brute forced it so I could get my goddamn crown. Give me my crown. That's not funny. That's
Well, what if you
sad.
were just really bad? And what if you were just really bad the whole time?
I'm not. I'm serious. It was just subtraction. Everything was wrong, and I also double checked with a calculator for the first three
What if you
ones.
weren't off by one error?
What?
What if you weren't off by one error?
No, I didn't code it.
What
But
if
if I
you had a
did,
bug?
then every single lesson would have the same exact problem. So thank God.
What if your computer had a bug in it? Or
No, I can't because I'm loading the website
Maybe
through a
you-
web browser.
you
Like it's
know,
not
you-
being run
what
on my
would happen
machine.
if you were- Or what is the version of dyslexic for numbers? I forget. What if you were just that?
It's called. It does. Yeah, I forgot the name of that. You're right. It's called dyscalcula. I remember now. Dyscalcula because I looked it up and I was like,
What if you were just
I
dyscalculic?
literally am so bad at numbers. I literally Googled one day. I was like, do I have dyscalcula? Because that's how much I suck. I don't
Well, you
think I
have
actually have
dyslexia.
dyscalcula.
You can't spell this word right.
Damn. Anyway, tutorial point. Oh wait, oh no, yeah, tutorial point. Where is it? I think I bookmarked that. Damn it. Oh wait, no, that's not tutorial point.
I
what
can
do
tell
want?
when you're in a different window because when you hover over text, your cursor doesn't change.
Wait, what is that? When I hover over it?
I can
Yeah.
tell when you're in a different window because it doesn't show like when you're in other windows, but I can tell because the cursor doesn't turn into like the selecting text cursor when you hover over text. So I know
You
you're in
can
a different window.
still see my cursor when I'm moving it, even though I'm
Yeah.
in a different window. Oh, that's cool.
Yeah.
Wow. Okay, so where is it? I have too many things bookmarked. I think I'm literally okay. I'm just gonna Google it. It's taking too long.
See, if you keep closing your tabs, then you're gonna keep having this
I
problem.
didn't close the tab. It my computer shut down again, and I lost all my tabs. Leave me alone.
Well, did you try like Control Shift T or something as soon as you open up Chrome? Because that sometimes works.
Oh, I should try that. But it's just an incognito window, so I lose everything anyway.
Yeah, that's also going to be a problem.
I know. So
So if you
anyway.
get a different browser, just use that one.
Oh yeah, you did mention that, but I'm loyal, I guess, to Chrome. I don't know why. Doesn't make any sense.
Well, about being loyal to Chrome, I think they maybe not have just made it so that way. Like, are you on the latest version of Chrome right now?
No, I didn't update it for a long time. I'm loyal
Okay,
to this
good.
version,
Because
whatever I'm using.
I was gonna say because like if you had, then your ad block would not be working right now.
Well, that's sad.
They
Then
made it so that they made a change to it
I
that
did
is
hear about
probably
that.
very
Yeah,
much targeted towards breaking ad blockers.
sad.
So is that
Oh
what you
wait,
want to be loyal to? I mean, the company that you're being loyal to just got sued for being a
I'm
monopoly.
joking. That's why I said for some reason. But I'm just lazy and don't like switching. That's all. As long as something works until it breaks. If it breaks, I switch, and that's about it. That's how lazy I am.
Well, it already did break. You lost all your tabs. You should
Yeah,
really
that was
figure out
sad.
what's going on with your computer and why it's turning off. That's probably a good idea.
It's just a problem with the hardware because Asus there's actually a lot of issues with this, and I'm actually glad it just like runs most stuff because people I've seen worse. Like I've seen worse comments about this particular model that I bought with people like some people's stuff, like computers wouldn't even boot up at all, and they had to like return it, and the company actually had to send them another one, which is even worse. But for me, it's just the Wi-Fi card doesn't work. The Wi-Fi card came busted, and then the operating like the heart it just I don't know. Every few days, like
It's actually like
overloads
just
and
get another
then
computer.
yeah. Well, no, money.
Just steal some money from someone. Like you probably have
No,
neighbors or something. Just steal their money or
no,
steal their computer.
no, because prison.
Well, prison if you get caught. Just don't get caught.
Wow, you think I wouldn't get caught? That's funny. If I
I
okay.
mean, you're not a criminal if you don't get caught.
What? But you have to not get caught.
Yeah.
Impossible. Oh wait, there was memory segments. I did want to review. Oh, where is it? Oh, register. Sorry, registered. I wanted to look at the picture one more time. Register myself. Right. So if I see 3 letters with something E, anything that starts with E is 4 bytes. You said anything that's like
AX,
just
VX,
X.
EX, DX. Those are all the 16. And SI, DI as well.
X is 2 bytes, and
Yep.
And then what did you say is 1 byte? Something's 1 byte. What's 1 byte? Where is it?
All those 8 things in the gray.
Oh yeah, AHAL. So anything H or L, 1 byte. Okay.
One thing that you're gonna need to remember or reference this thing repeatedly for, and because you're gonna keep forgetting it, is which one comes first, AH or AL.
Wait, why will I have to reference that? Shouldn't it be obvious? Because it's like
you might repeatedly forget which one comes first. In fact, you should take that image and like save it somewhere on your computer.
lol. Wait, what do you
Make
mean?
it like your desktop.
I wouldn't forget. It's literally ABC, ABCD, ABCD. Like there's no way I'll forget.
No, like the
what are you talking about?
The AH and like the AH and AL. Sometimes I keep having to look it up to be like, what's the order? Like, which one is on the left and which one is on the right? Because if you set AH to 4, EAX is not going to be 4. But if you set AL to 4, EAX should be 4.
Oh, damn it. Oh, yeah, you're right. Because yeah.
One of them is on the left,
annoying.
one of them is on the right, and you got to remember which one is which.
That's actually going to be really annoying. You're right. But I guess I can remember just, like, one's the, HL. I just need, your mnemonic. HL is, like...
Half-Life 3.
That's not a bad one, actually. Oh, yeah, because it's half... Dude, yeah, it's half the... Well, AH plus AL is half the size of the 32-bit register.
Half-Life?
So half-life, yeah, because it's half of it. I like it. I'll use that. That's good. That's a good one. Where did I actually stop? I stopped...
The other way that I just thought of, which I kind of wish I thought of before, is also, like, ordering the alphabet. H comes before L.
Oh, that's an even, like, simpler one. Because that one's, like, built in. Half-Life's cute, though. I think I'll remember that.
Yeah.
Yeah. I think I was somewhere on this page, because I know I stopped, like, as soon as you got tired and passed out, like, I was, like, then I switched to watching, because then I was kind of tired, too, at the time, and I started watching this video. Which, by the way, I
Tatum
finished
says L
this.
equals left since that's lower on little endian.
Well, what is H? That doesn't work if you don't know what H is. And also, it's not going to be left on JDoodle.
Oh, yeah, I remember little endian. Wait, what did you just say? Sorry. It's not going to be left on what?
I'm talking SPQ. It's not going to be left on the it's only left on little endian. But it's not going to be on the website we're going to use. But also, but if you're going to use that, what is H?
Wait, our website that we're using, it doesn't do little endian?
Tatum says doesn't
mean I told you about this already.
I forgot.
There's the thing before about how it swaps the bytes. And I explained to you why a lot of things do that, but also said keep that in mind because JDoodle doesn't.
Okay, but you didn't use the word little endian, so I was like trying to link those ideas right now.
Yeah.
Yeah. So if not do weird swappy byte thing, then that's little endian. If it does the weird swappy byte thing, then that's it's the big endian. I think that's the other one.
Little endian is is. I think little endian. Well, given what they said there, little endian is doing the swappy thing.
Oh, so we are using little endian because ours does. Oh wait, I remember you said that our JDoodle doesn't do the swappy thing. You're saying okay? Yeah. I see you now. I had it reversed, like I always do. I always mix up true and false. My bad. Doesn't AX mean extended accumulator register? Yeah,
where's that to 0 and not 1?
To A and EAX mean extended as well, so EAX is extended accumulator. Well, I guess that makes sense because EAX is the biggest one, and then the AX is like half of it. So it kind of makes sense that it would be like double extended.
So wait, if A stands for accumulator, what do B, C, and D stand for? I forget.
It's obviously...
No, it said this, didn't it?
Wait, what?
In this registers thing, did it say that? I think it said that. I forget. I mean, I don't know. I just think of them as A, B, C, and D. I don't even care about...
Yeah, it is A, B, C, D. Because I was like, if A is accumulator, then B is accumulator, and C is accumulator, and D is...
Accumulator.
Tatum says, I forgot
right? To. But yeah. Okay.
Yeah, because why do you even think about that? I don't think about that. I don't want to think about that.
When instructing where to upruns for summer tremendous. 3 basic modes of addressing. I think we stopped here. We stopped at I don't know. You probably don't remember either, but I'm pretty sure I think I read this.
Yeah, I don't remember because it's been like a year since we last talked and did assembly.
You're right. I can't argue with you there.
In that time, I almost became a Marine.
Holy hell. Damn, you gotta do me like that. For some other instructions may require 1, 2, or 3 operands. Actually, I don't know if I... Let me go back here. Oh, yeah, we did this, remember? You fixed their code that didn't work, and you fixed it so that it actually would take a number. So we did do this part.
Oh, yeah, we did that.
You fixed their code. That was so cool.
I fixed it on JDoodle.
Yes. Oh, to run on JDoodle, that's right.
They use 2 for the console in, but JDoodle uses 0. So like, that code is right. It just didn't work on the other thing, which is also part of like the whole, portability of assembly. It's so very portable that you move it to one other place and you need to change an entire number.
That's beautiful.
Just to get it to run.
Amazing. I'm kind of jealous of the guy who coded Brick Breaker in assembly. Like, that was cool. Can you code Brick Breaker? Do you have enough knowledge to code Brick Breaker in assembly? Because that was pretty insane. I'm like, oh my god.
If I could probably figure it out, but first things first, I need to figure out how to draw it to the screen.
Good point.
That's the first thing. I could probably do it, yeah.
I see. So if you just knew like the calls that you need to make to the system, like you'd have the knowledge to put it together.
Yeah, if I know all that stuff, which I could figure out, then I could probably do it. Was that my next project? Making an operating system for Brick Breaker? Making sure you open a VirtualBox and then you pop in an ISO file with Brick Breaker?
Actually, well, he did Brick Breaker. If you were to do a game, I want to see Pac-Man because I think that'd be even cooler than Brick Breaker. Brick Breaker's cool. It's okay, but Pac-Man's like the classic. Yes. Because then you have even more to worry about, like the ghost AI and stuff, in addition to, Pac-Man. Anyway. Most assembly language instructions require operands to be processed. Operands are like the command, like move and stuff, right? Like move and pop and push. I think. An operand address provides the location where the data to be processed is stored.
Keep disconnecting. What'd you say?
Oh, hi. I said, it said most assembly language instructions require operands to be processed, and I said, is an operand like an instruction, like move and stuff and push?
An operand is a parameter. It's the like when you do
yeah.
move, EAX, EBX, EAX, and EBX are the operands.
Thank you.
They're just the things that come after the instruction.
Got you. Thank you. Now I remember.
There are some.
Now that you said that, I actually remember we'd read this small section, so I'm gonna skip it because I asked you the exact same question, and I remember asking this exact same question, so that's good.
You remember answering that question before?
I do. Because then I asked you, I got really confused about the whole order thing, and I asked you about this for like 10 minutes and made you explain this for like 10 minutes. It was really unnecessary that I like kept asking that.
That's why I forgot about it.
But if you forgot about it, that's good because I've kind of put you through hell there, but yeah. Just don't think about it.
Does that mean I need to spend another 10 minutes explaining it to you again?
No, I understand the answer now, but at the time I need it. I was like confused by the answer you were giving at the time. I think. Wait. Register memory, second operand source. Source contains where the data to be delivered. Actually, maybe I'm thinking of a different part. I'm just gonna keep reading this. But don't worry, I'm not gonna ask any crazy questions on this section, I think. An operand address provides a location where the data to be processed is stored. Okay. Some instructions do not require an operand, whereas some other instructions may require 1, 2, or 3 operands. Okay, when an instruction requires 2 operands, the first operand is generally the destination, which contains data in a register or memory location. Yeah, and the second operand is the source. Source contains either the data to be delivered, immediate addressing, or the address and register or memory of the data. Ah. Generally, the source data remains unaltered after the operation. Okay. The 3 basic modes of addressing are register addressing, immediate addressing, memory addressing. Register addressing. In this addressing mode, a register contains the operand. Depending upon the instruction, the register may be the first operand, the second operand, or both. Blinky, Pinky, Inky, Clyde. Name all the ghosts.
Me says.
Wait, why did you laugh?
Inky and Clyde.
Dude, you're funny. What? Anyway, sorry. Move, DX, tax rate. Tax rate. Register in first operand. Register in second operand. Okay, move DX tax rate. Wait, so even though it says count...
Wait, what the fuck?
What? This is one of the registers?
How are they moving CX into count here?
Yeah, that's what I was about to ask. Like, this is
how are they doing... How is that second line happening?
I don't know. I was
like,
about to ask you.
It's not in square... Like, it's not in square brackets or anything.
So it's not like a label. It should be like a label, right? Like, it shouldn't be...
Yeah, it should be in square... I feel like that should be in square brackets. Because I know for damn sure count is not one of the registers.
It's not. There is no register called count. Like, I was like, what the hell?
I feel like that's
just a typo.
That looks like a mistake. That looks like a mistake.
Yeah. Thank you. Good to know. Because I was like, what the hell? Move EBX, EAX.
I mean, the first line makes sense. The second line does not.
That's true.
But maybe someone with more assembly experience can explain that if there is a reason. But I feel like that's just wrong.
Yeah, it seems weird. Second operand, both operands are in registers. Why for the third line does it say both the operands are in registers? Like, this line, this doesn't seem like it has anything to do with the registers, like the operands in the registers. Like, These two.
They are both EAX and EBX are both registers.
Civitatum says technically this is still an operand field.
Yeah, but
give me a
the...
second. I'll be right
It's
back.
just
The
a
audio's fucked
syntax
up again.
error.
Oh, okay. There's still an operand. Just syntax error. Ah.
I'm back.
Hello.
So in the first one, the register is the first thing. On the second one, the register is in the second thing. Like DX is in the first one. On the second line, CX is in the second, and on the third line, both of them are registers. So that's what it's talking about.
Well, I mean, I was thinking. Oh, okay. Okay, I guess it makes sense because DX is inside EAX, so it's in the
DX, like all the smaller things, those are all registers too. Yeah, SPQ. That second line seems wrong, right? Seems like they made an error there.
Mhm.
I mean, it could just be to, like for explanation purposes, but I definitely do think that line is wrong.
I'm also gonna.
So don't do that. Don't do what they did there.
It seems weird, like that. If DX is inside EAX. Oh wait. I'm already thinking. Okay.
DX is inside EBX.
Oh, wait. DX is inside EBX. Oh no.
EDX.
DX. Yeah.
Same letter. That's part of the D register.
Oh, you're right. So it would be EDX. Okay, I see.
Yeah, and then CX is part of ECX.
Mhm.
And it contains CH and CL.
But the only thing we care about is the operands, and the operands are being moved to registers that are unrelated to EAX and EBX. That's what I was saying. Why does this line, this part, move EAX, EBX? Why does this even matter? I don't think it does. Because these aren't the operands. It's talking
about how you can have them both be registers. You can have one you can have the one on the left be a register, the one on the right be a register, or you can have them both be registers.
Okay, I see. So in this case, it's like another set of operands. Like these are two operands, and then showing you like, oh, you can have two operands.
Yeah, and technically that has to be like coded on the CPU, like to use them both as registers, rather than just one in either. Like the way it's all set up has to be coded like specific ways on the CPU.
Okay.
They like get their own like sub instruction sort of thing.
Weird. As processing data between registers.
What I understand, the way it works is you have the move instruction.
Yeah.
As like a byte, and then the following byte contains probably like a bunch of flags for a bunch of different parameters. Like depending on what it is, it determines what you have as your parameters, and it can be a constant, or like an immediate, or a register, or reading from memory. In which case, it's some other things as well. If it's want to read from memory, but it doesn't have a thing set up for doing both of them as memory.
Wait, what are both things? Where are they? What things?
Both the thing on the left and thing on the right.
Oh.
First and second operands. It's like pretty much like how it's like interpreted. I mean, machine code is what I'm talking about. How it turns into machine code.
Mm-hmm.
It's got a whole bunch of like settings based on the bits of the bytes.
That's cool.
It's like some value, like it might have something that indicates this is a register and this is the register that it is.
Oh, and then if all these values are here, then do this.
It might be like, this is an immediate, this is how big the immediate is, and this is the value of the immediate.
Civitatum says, I think the second line might be
valid because macros. Well, yeah, but like I understand, of course, it's gonna be a macro, but can you do it? If you define count as a
register or STH.
Oh,
what? How do you define count as a Is that a thing that you can actually do? Like define something specifically as register?
It did compile. Wow.
It did see, here's the thing. It'll compile. Yeah. I believe that, but actually, wait. I mean,
Civitatum says %define.
Is register a keyword that you can use? Define count. Oh, okay, that makes sense.
Oh wait, you figured what?
Tell me. That makes sense. That makes sense. That does make sense if you do that. Yeah, I was gonna say if it was like some like allocated bytes for some value or some constant, I was gonna be like, that doesn't make sense.
Oh,
But yeah, if you
it's
do
like
that, yeah, that
redefining
does
it,
make
saying like I want to call it count instead of I don't want to call it
Yeah.
EDX anymore. Yeah.
Yeah.
Just like remember when we were reading the U and CPU thing where they like renamed a register into their own thing, whatever. And you're like, I think that's just like their naming, their
I
name.
feel like I could make the most cursed assembly code using that idea.
Oh, yeah, you probably could. But maybe.
Just name everything 1, 2, 3, 4, 5,
No.
6.
Have you ever thought? I'm just curious, but have you ever thought like maybe you shouldn't? You know, maybe I shouldn't do this. Maybe it's a bad idea.
What do you think?
These are the questions. As processing data between registers does not involve memory, it provides fastest processing of data. Immediate addressing. An immediate operand has a constant value or an expression. When an instruction with two operands uses immediate addressing, the first operand may be a register or a memory location. The second operand is an immediate constant. Okay. The first operand defines the length of the data. Oh.
Alessio Rep says BS viewers on 777hotels.com/mg.
Annoying. Anyway. For example, byte value DB150. Byte value. A byte value is defined.
I wonder if you can set up your TTS to not read from viewers that got banned after they sent the message.
I think probably not this one. There's literally like not many features I can do, like not many options for me to change this. But obviously, if I used a different service or had my own, I could do whatever I wanted to do, like customize what things I wanted to read. Yeah. Byte DB 150. DW3. Wait a second. First operand defines the length of the data. Where's the length being? Is this DW, DW? Wait, is this DB and DW? Is this the length of the data? Or is this 150, 365?
Yeah.
Okay. Wait a second. It just said the first. Wait, it just said two.
Look,
it says two different things.
okay.
What? It says
SPQ?
what?
Wait, what is going on here?
What is what going on?
Wait. Add byte value 65. What? SPQ, explain this.
Yes.
This can't be valid assembly, right?
Civitatum says this does not work now.
Oh.
Yeah, I was like, there's no way this works. Like, I was like, wait,
what in the
what's
world?
going on here?
Yeah, what is this? Why are they...
Like, how are you doing that? Like, how are you doing that third line? How are you doing that? It's like trying to set 3. It's like trying to write 3 equals 4 in C sharp. Like, how are you doing
4.
that?
Like, this is weird.
Yeah, I was like, you got away with it last time, but this one is blatantly stupid.
I see. What if I was to find? Constant 45H. Okay. I won't think too hard about this because they made some oopsies. Could say. I hope they stop making oopsies because it'd be really nice since I am trying to learn like what the hell's happening. Direct memory addressing. When operands are specified in memory addressing mode, direct access.
says you could do add byte underscore value.
Yeah, that's
65.
And I think that's what they meant with the other one too. But I feel like they're not doing it just because they don't want to make it look more complicated than
it's so funny.
Want it to look.
I guess, but it's.
But if you're experienced and you look at that, then you're like, that just seems wrong.
I feel like too, literally just adding brackets to something does not make it that much more complicated. Like honestly, just add the freaking brackets. That's what I think. Because assembly is already
Unless you're
complicated.
someone who codes in Python, and if you're someone who codes in Python, then yeah, you can't read the code anymore as soon as you see in the brackets.
What? No, you could just get over it. Just don't learn Python, and then you're fine.
Well, you're doing assembly right now. You're not doing Python. That's why you can read
Exactly,
that.
but you should be used to, if you're gonna learn assembly, you need to be used to seeing things that you don't understand what the hell's going on. So put the brackets anyway.
Mhm.
Confuse all the people because, yeah, because then it's yeah. But but what the hell is it? Okay, this is confusing. With the word byte value DB, like the first operand may be a register memory location. So what? This is oh wait. So the oh my god, the register memory location's name is byte value, and then the first operand defines the length.
Yeah,
But it
but
says
something called byte value.
okay. The confusing thing is it keeps saying it says the first operand different things. Like the first time it says the first operand may be a register or memory location. And the second time it says the first operand defines the length of the data. So what is it? Is the first operand the register or memory location, or is it goddamn length of the data? Like it can't be both. Or maybe it is both, because a memory location defines its own length. Like it is like I guess.
Okay.
I don't know. Maybe I'm thinking it.
Okay, so I'm reading this. You might need to read the whole paragraph. I'm thinking.
I did read the whole paragraph.
An immediate operand has a constant value or an expression. Don't scroll. I'm trying to read this.
Sorry.
When an instruction with two operands uses immediate addressing, the first operand may be a register or memory location, and the second operand is an immediate constant. The first operand defines the length of the data. No, that makes sense.
Okay.
It's just saying basically like if the first operand is a 4-byte or a 32-bit, or if it's a 16-bit, that defines the length of the data that's being moved.
Okay. So the first operand, so in each one of these, so like this is the first operand, this is the second operand, right? This is the first operand.
I
DW.
don't think that's.
Oh, I thought it was.
I don't.
Second.
I'm not sure if that's referencing this. It looks like it's referencing like instructions like mov and add and sub. I think it's referencing like those kind of things, not what's wait. No,
Oh.
for example. Oh, maybe. Oh.
It's weird.
Oh, no, I think that is what they're trying to. No, that is what they're trying to do here. They're talking about the line 3 and 4 on there, but also line 3 and 4.
Oh, it's only really line 3 and 4 that we need to pay attention to.
I think they're talking about line 3 and 4, but also line 3 and 4 are a little bit scuffed. But
yeah,
I think that's what they're talking about here.
Okay. Byte values.
I can tell you for damn sure there is no CPU instruction called byte value.
Okay, that's good. There's no byte. Oh my god. So like, what even is then? What it says? It's like some kind of definition. Like, what even is this? What is the 150 and 300 at all?
Random numbers, arbitrary numbers.
Oh,
they don't
wow.
mean anything. What's important about them is that 150 can be stored in a byte and 300 cannot, so they use the word for that instead. That's really why they picked those numbers.
Oh, that's it. Oh.
You can store 300 in a word, but you can't store it in a byte because a byte only goes up to 255.
Oh. Okay. Byte. I see. Okay, that's why that's okay. So the numbers themselves, at least, that's the only part that's like not random. Good to know. Yeah. Direct memory addressing. When operands are specified in memory addressing mode, direct access to main memory, usually to the data segment, is required. Okay. The way of addressing results in slower processing. Wait, this way of addressing results in slower processing of data. To locate the exact location of data in memory, we need the segment start address, which is typically found in the DS register, and an offset value. Okay, this offset value is also called effective address. In direct addressing mode, the offset value is specified directly as part of the instruction, usually indicated by the variable name. Oh. The assembler calculates the offset value and maintains a symbol table, which stores the offset values of all the variables used in the program. Wow. In direct memory addressing, one of the operands refers to a memory location, and the other operand references a register. For example, add. Oh, it adds the register in the memory location. Oh. Wait, memory location. Is this the same thing as a stack?
Oh
wait, no, it's just a
the stack
piece.
is memory.
Never
The
mind.
stack is memory.
That's true. I guess it's like the
but
RAM.
not always. This isn't.
Oh,
They're
RAM stack?
wrong here. They're not using square brackets.
Oh, yeah. Well, we already know, I guess, that they don't ever use square brackets in their examples. But look, except down here. Look at this. They just decide, like,
They're using square
let's
brackets down
use
there.
them
Yes,
all of a
they're
sudden.
actually doing it right there. And also that what I just saw there, what they were
What?
talking about was one of the things I mentioned before about how you can have problems.
Where?
This wait. Oh wait.
Okay. Wait, let me check.
Scroll down.
My phone's about to die.
That is this actually valid syntax? Where is it? When is it valid syntax? I'm looking at this. The thing with the byte table. If you scroll down, the 4 byte tables.
Where? Oh, these.
SB2, can you verify that this is like valid syntax or byte table word table? Can you verify this is valid syntax? Like this actually does these things? Because I didn't know that was a thing. It does indeed compile and works. Huh. Nice. Interesting.
Civitatum says it does
I didn't know
indeed
that was a thing you
compile.
could do.
Oh, okay. I'm guessing memory location is not the same thing as stack. It's separate.
Civitatum says, but
Basically
that would
the same
make
way you
sense. It's
define
basically
string
the same way you
literals.
define
Or
string
maybe?
literals.
I don't
What do
know.
you mean?
Is a memory location part?
Because I was under the impression that if you wanted to reference anything in memory, you always had to put it in square brackets. But I guess that's not true.
But so that's not the stack, right? It's something else.
What?
The memory
Well-
location is not the same thing as a stack, right? They're two different things, pieces of places, information.
BSF. I think they're talking about BSS here, which is different from the stack.
Oh, okay. BSS. That's what's true. Add the register.
As far as I know, I could be wrong about that, but I'm pretty sure it's different from the stack.
Okay, adds it to the BSS section. Yeah. Wait, why could you just like not? Couldn't you just like only use the BSS? Like, why do you even have to use a stack? Can't you just like exclusively use?
You could.
Oh.
Yeah, you could.
Oh, cool. That's kind of cool.
But
Mm-hmm.
you
But-
will run into a problem, like if you want to call the same function twice at different points.
Uh-huh.
Like you call function or like if you call a function, that function calls itself.
Oh. Okay.
Because guess what?
What?
Guess what memory both of those functions are using? The same memory. If you use the stack, then they all use different memory. I'm gonna add the stipulation. I wanna add that stipulation just so you don't take the easy path. I'm gonna add the stipulation. You must only
What?
use the
So I
stack,
can
do not
cheat?
use
Wait,
BSS.
that sounds fun. I want to cheat and just use BSS for everything that doesn't call
I
itself.
like that stipulation. Do not use only the stack.
Wait. How about let's pretend we go back in time and I never asked that question. So that it doesn't. I didn't ask that. So, aha. Therefore, there can be no stipulation if you didn't think about it.
Yeah.
VX word operand from the memories added to register. Why? Is it because in your code you didn't use the memory? Like you used only the stack yourself? Or did you use BSS?
Yeah, I also want you to think about that because it's like you need to think about things a lot more when you're using the stack as well.
That's true.
Because you can't just give everything variables. You need to keep track of like the positions of all of your stuff. and make sure that that you're not overlapping things. You need to arrange things in a very structured way.
Yeah.
Whereas
But
if you're using BSS, then all you need to do is give everything a name, and then it arranges
yeah,
it for
it's
you.
more like it's closer to a high level language. But what did you do? Did you use BSS?
No.
Oh, damn.
No.
Okay, fine.
If I use BSS at all, I don't think I did. But if I used it at all, it was just to define. It was just to make a floating point number.
Okay,
Because
so I'm allowed.
I couldn't use floating point constants in .text.
Okay.
But I don't think I even did that. I'm pretty sure what I did to get floating point numbers is I used I would like convert 10 into float, and then like and then like do like 1 divided by 10, or they may probably have that as a constant as well, and like do like 1 over that, like take reciprocal of that thing to get like 0.1, and then work from there and all that stuff. Convert from ints to floats and just work with those.
Mm-hmm. Okay. Well, anywhere you used, if you did at all, then I can use BSS wherever you might have. Yes. At least, because it has to be even. It has to. Add to register. Direct offset addressing. This addressing mode uses the arithmetic operators to modify an address. For example, look at the following definitions that define tables of data. Table. Oh, byte word. 134. I don't see any arithmetic. Oh, wait. Oh, these are just tables of data. Never mind. The following operations access data from the tables in the memory into registers. Gets the third element of the byte table. Third element of the byte table. It's the fourth element of the word table. Fourth element of the word table.
Best viewers on 777hotels.com/MJPO.
Why are you reading?
See, why is that like
Why are you reading that?
777hotels.com that they're trying to get you to click on? They're trying to have you go to hotels.com for viewers on Twitch.
Exactly, but yeah.
That's crazy.
Mm-hmm. Indirect memory addressing. Scroll down. How many sections?
How do you know that they're the best viewers? Like, surely there are better viewers than that.
True.
You're gonna get sued for false advertising.
The addressing mode utilizes the computer's ability of segment offset addressing. Generally, the base registers EBX, EBP.
I just said EDP for a second. I was like, what?
What? EBP. That's one of the pointers, right? Like ESP and EBP. Like those are related, right? If I remember right.
Everything can
Those
be
are
used as a pointer pretty much. But usually you use ESP and ESP and EBP. Yeah, usually.
Okay, yeah, they're related to that part. Good. Or BX.
Yeah,
BP.
EBP you keep in one spot. ESP moves all over the place.
Mm-hmm. And the index register, DISI. Didn't you bring DI and SI up like earlier too? You like mentioned DISI. They're just like extra ones for you.
ESI, EDI.
Yeah.
And the DI and the SI and DI. Those are the 16-bit versions of the other ones.
Yeah, but didn't you say they're just basically extra registers that I can use if I want to?
Yeah.
Okay, good.
Yeah. But they don't have 8-bit versions. They don't have the 1-byte versions. They only have 4-byte and 2-byte.
Oh, that's right. They just don't have the little tiny ones in them. Yeah, good. Index registers coded within square brackets for memory references are used for this purpose. Coded within square.
Did you like what I sent you on Discord?
What would you send me? No. No. What? No. I mean, indirect memory addressing. Oh yeah, I read that. Indirect addressing is generally used for variables containing several elements, like arrays. Starting address of the array is stored in, say, the EBX register. The following code snippet shows how to access different elements of the variable. My table times allocates 10 words. 2 bytes. Each initialized to 0.
Oh yeah, and there's also like also having that like the +2 on the other things or +3 on the stuff declared at BSS. I'm looking at that and I'm thinking that reminds me of the stuff that I didn't like with C, where if you
What?
take a like a byte pointer and you add 1 to it, it changes the value by 1. If you take a short pointer, which is 2 bytes, and you add 1 to it, it changes the value by 2, the value of the memory address by 2. If you add an int, if you have an int pointer and you add 1 to it, it changes the value by 4, points 4 bytes forward to the next int.
Why?
And I didn't like that. I didn't like that because I'm like, if I want to move 4 bytes forward, I want to add 4 to it. But I still want to keep it an int pointer. So what I do is I just turn it into a byte pointer, then add forward and turn it back into an int pointer.
Okay. I see.
I think I probably did in my code a couple times. Let me look at my C code. I'm pretty sure I did this.
Okay, what's here?
Oh,
Allocates 10 words, 2 bytes each.
whatever. I can't be bothered.
Initialized to 0. Reactive address in my table in EBX. The table 0 equals 110.
Yeah, I did. Like, I understand why it does that, but I just don't like it.
Add EBX to EBX equals EBX plus 2.
You know what I don't like about the way they wrote this?
What? Move table
On the
1.
EBX equals EBX plus 2, they put a space before the plus sign, but not after the plus sign. Like, you know, if you're doing it, you gotta either put a space before and after, or no space before, no space after. It's just so uneven. I don't like it. It's like, but like the freaking what's the thing? It's like messing with me. Seeing that unevenness on it.
What?
Line 4. The comment on line 4.
Oh, you're talking about... Okay.
I don't like the unevenness of that.
Oh, like the how one doesn't... Oh, there's no space there and plus 2.
Yeah, I don't like that.
Wait, that matters, right? In assembly.
No.
Does it?
Well,
okay.
no.
Well, oh, so you could put a space there and it's fine.
That's also... I mean, it's also a comment, so it doesn't matter anyway.
That's true. It's a comment. But in actual, like here, in these examples, where it's like not a comment, if I just delete the spaces, it's like fine, right? If I want it to.
Civitatum says it looks like a unary plus on 2 and lack of
an
operator between 2 operands.
That too. I mean, nothing, like, literally nothing nowhere ever is going to interpret it as a unary plus 2, but, like, a unary plus on 2, but, yeah. It's just like, I prefer if it's like, no space left or right, or 1 space left or right, or some number of spaces left or right, but I don't like when it's uneven. It just feels wrong. It feels weird. I forget what that's called.
Wait, why is it not unary plus 2 or whatever. Doesn't that just mean add 2? Like literally like 1, 2? Add 2?
Unary plus is an operator on and up. Like, you know how, like, if you add,
Oh.
like int x equals plus 5? So that wouldn't add 5 to x, that sets it to positive 5.
Oh, that's
Basically,
what that... Oh.
it's like EBX equals EBX positive 2. But, like, where's the operator in between? Instead of it being plus, it's positive. Imagine it means positive.
Okay. So then, okay. But in this case, it does just mean actual plus. Like, it's what's supposed to be.
Yeah.
Not unary. Unary would just be positive, like positive, negative. Okay, that's
We spent
weird.
so much time on this, it wasn't even worth looking at.
That's true. But that's actually what I was... I was only up here because I was looking at understanding of the whole effective address thing, but I think I get it after staring at it enough. Because it's like you move the address of my table to move it to EBX.
No, that's not what that does.
What?
Is that what that does?
That's what
SPQ,
it's just...
is that what that does? I thought you have to use LEA for that. Wait. Is that what that... I thought you had to use LEA for that. I mean, I could be stupid, but I thought you had to use Leah for that. The Leah instruction.
And then...
Because, like, I'm reading this and I'm thinking that that's going to read the first 4 bytes at my table and store those into EBX, rather than store the address of my table into EBX. SPQ will figure it out, probably.
Oh, you think it's going to take the actual value and put it into EBX instead of taking the address?
I'm imagining that's going to take the first 4 bytes inside of my table and store that in EBX, rather than put the address of my table in EBX. I thought it would move 0 to EBX too, does it not?
Oh, but it says it's special.
Says I though it would move 0 into X.
It was
Doesn't it?
Well, the paragraph says EBX is special. It's different than the other registers. EBX is used for this memory thing.
No,
well, that's
it's
what
not
it says.
special.
Generally, the base registers.
No, it's not, and it doesn't. SPQ, does it move 0 or does it not move 0? Maybe if SPQ has a convenient way of testing that. It actually, I mean, that might be very inconvenient to test, by the way. That might be, but I'm not 100% sure. Okay, you know what? I have an assembly program that does that. Let me test it. I'll test it.
Actually test.
What the fuck?
Civitatum says maybe with inline assembly. Let's see.
Inline assembly. Okay, I'm gonna test it.
Okay.
I need to log in now. Come on, dude, press the freaking button. Oh, this is just massively lagging is all. Why is this not working? Okay, that one, do that. And bing, bang, boom. There you go.
Wait, it has to be an array though. It says something like the starting address. Whatever that is, it has to be the starting address of an array. It can't just be something with one value or something, I guess. Wait, that makes sense to me because if this is an array, then it's not just going to copy one value. Like, why would it do that? It should copy the memory address because it's an array.
It'd be reading from that though.
It is.
I'll test it to see what it does.
Okay. That'd be weird.
Section.text. section dot bss.
Okay, I'm gonna keep reading. This is
My
like stay
table.
ahead. We've already used the move instruction that is used for moving data from one storage space to another.
Can you scroll up to the lines so I can
yeah.
copy it?
Here, I'll just copy and paste it for you, and you can have
My
it.
table times 10, my table times 10 DW0. Okay.
Okay.
So if I go to
Here, have this.
if I collapse all these different things, Pnum EAX, that's gonna
The
be
move
good.
instruction takes 2 operands.
Main.
Syntax of the move instruction is move destination source.
Okay.
Move instruction may have one of the following 5 forms: register, move immediate register, move immediate to
Jump back.
memory, move memory to register, move register to memory. Please note that both the operands and move operations should be of the same size. Wait, this makes sense to me because it says both need to be. It said both have to be the same size, but in this example, it's not the same size, so that's why it would store the address because the array is too big.
Yeah, it does
right?
store 0. Wait, what the hell is this?
Wait, make your array super big. I don't know.
Wait. Wait, why is it complaining here? Do I need to put it at the bottom? Maybe. Okay, well, let me just move that. What this is telling me right now is that it does just move 0 there, but I could just be doing this wrong. So I'm gonna move this to the bottom of my code and see if it gets rid of this error that it's trying to give me.
Oh, okay. I was gonna say, can a memory address also be 0? So it's like coincidental. Is it possible?
Yeah, but your program might crash. It doesn't really like to let you do that. Why is it not letting me do that?
Oh,
What's wrong
okay.
with this? Why is it not like that? Oh, segment. Do I need to put segment? Segment.
Well, look, it's doing
Do I
it.
need to put segment?
It does it again. Look at it's. Wait, it's explaining this thing again with the address. It's saying the move instruction causes ambiguity at times. For example, look at these 2 statements. Move EBX my table, effective address of my table, and then move EBX 110. My ambiguity. 110. It is not clear whether you want to move a byte equivalent or word equivalent of the number 110.
I mean, whatever the case, what I'm getting is that it doesn't move the address of the thing into the thing. It moves 0. So they are supposed to be using the Leah instruction, but they're not.
Oh, so they're just not using like.
They're
simplifying it too much.
Guess what they're not doing wrong. Guess what they're not doing right.
Not using the Leah instruction, so that it shouldn't do that.
Yeah. So what the Leah instruction does, it's load effective address. So, which is the instruction that they're looking for. Instead of mauve, if it was LEA instead of mauve, then it would work because it'd be loading the address. But instead, what they're doing is they're just reading the number that's stored there rather than getting the address.
Okay, so if it's an array, they're just gonna read whatever the first byte or whatever in the array is, and then they're just
they're using this wrong. They're literally just using this wrong. This is wrong.
Okay. It's like the brackets thing, but worse.
I mean, I'll do a couple more tests to see if I'm wrong, but I think that's just what that is.
I don't know. Well, you said they didn't want to use brackets because it's too complicated, so maybe they don't want to use Leah because it'll make it look too complicated.
Yeah.
So they just pretend like it.
Yeah, they're using it wrong, but the code that they're giving you is wrong. So I don't know which would you prefer it be T-byte? Wait, is T-byte a thing? Wait, what? I've never heard of T-byte before.
Wait,
T-byte.
What?
I've never heard of T-byte. What the hell is T-byte? I've never heard of that before. It doesn't, like, I typed that into JDoodle. It doesn't even change colors.
Damn. What was Google T-byte? It must be real. Like, no way they just made that up. That would be so silly.
Wait.
Okay, it does exist. It's real. The art of
The hell?
assembly. Found
What the frick is this shit?
what? What'd you find?
I'm trying to figure out like I can understand how you could do it, but I'm wondering if that's an actual like keyword in assembly. Keyboard director will allocates 10 bytes of storage. 10-byte variables use the table data type because there's now the use of 80-bit non-floating point constants. You may not associate and initialize it with this data type. However, if you wish to reserve storage for an 80-bit variable, you may use this data type to do so.
This website looks so freaking old.
I guess. So, but yeah, with the examples that they're giving, there's absolutely no way that they're doing it right.
Okay. Damn. This guy, I'm gonna bookmark this. This is a whole book. This is a whole book called The Art of Assembly. Hell yeah. Yeah, I found.
That's probably literally the thing that I had just found as well.
You just found this? Oh, could you look up T-Byte like me?
I saw The Art of Assembly a couple of times when I was looking up the videos.
Oh, you've had this show up as a resource before? That's cool. Yeah, thank you whoever followed, by the way. Sorry for the delay. I'm just very, like.
Yeah, you don't get T-byte sized registers or anything.
Let's save this.
So I don't even know. Like, is there really anything that you can use T-byte for? F word. What the hell is F? What the hell is an F word size thing?
F word is a word thou shalt never say.
Well, fuck.
Damn it.
In just 90 says that email address was from UCR, my alumnus.
No way! Wait, what email address? Where? Where? Is it the one by this guy who wrote this? No way. So what are the odds? Wait, where was there an address? Now I need to find where the email address is. Where is it? Oh, I found it. Wait, it's right. It's the ucr.edu.
In just 90 says top of this page.
No way. What are the odds?
What's LES?
I'm guessing it's this one, right? cs.ucr. That's crazy. I just found this website too. What does it say? Represent absolute proof that God never intended anyone to work in assembly language. Amazing.
Think that hexadecimal 1% absolute. Nice.
Yeah, that's what it says. Many think that hexadecimal proof. God.
In just 90 says I graduated with business though. Sad face.
Oh, don't be sad. That's an awesome thing to graduate with, and it's another.
It's not engineering, like.
What?
It's not engineering.
But just like computer science, like you can take business and take it everywhere. Like it just fits into like every single, like it's very versatile. It's a good degree, I think.
Yeah, I can take computer science into the Marine Corps.
Because no matter where you go, you need the money. Aw.
In just 90
I need to take the lower byte of RDI.
To be
store it in one of the A, B, C, or D registers and get the lower byte of that. Because that's the 64-bit, so maybe the 64-bit has it, but to my knowledge, at least in the 32-bit, like EDI, you can get the lower 16 bits, the lower 2 bytes, but to get the lower 1 byte, you're going to need to copy it into the A, B, C, or D registers and get the low byte that way.
UCR University. I don't even know where that is. I'm kind of curious now. UCR. Oh, California.
Says that's probably true for 64 as well.
Riverside. Wow.
I think they're in California. There's
Cali.
They have one of the stations for Marine Corps boot camp there. But I won't
Oh,
be going there. I'll
cool.
be going to Paris Island probably. Paris Island is closer.
Wait, you're. Oh wait, no, never mind. Because you're East Coast. You're not West Coast anyway.
Yeah.
Because of your weird time difference. Why would anyone learn this stuff? Amazing. You're actually reading this. That puts you into one of three categories. A student who's being forced to read this stuff for a class, or I am being forced to read this stuff for corrupts class. Someone who picked up this book by accident, probably because you have yet to be indoctrinated by the world at large. Damn. It's brutal. Or one of the few who actually have an interest in learning assembly language. Egads. What kind of book begins this way? I wonder how good this book truly is if I read the whole thing.
Yeah, those last three reasons are pretty good reasons.
Oh. You're interested in how to write. Yeah. You're right. You want to understand how... Yeah, these ones would be my main three reasons. That's a good point.
Like, if you wanna do computer science, it probably helps to know how computers work.
Mm-hmm. That's true.
Yeah, and then whenever you do things in like higher level languages, you're gonna start thinking about how many assembly instructions it takes.
Oh, like what each thing might look like in assembly.
And then, like, you do things that you're gonna be like, well, if I do it this way, then that'll take less assembly instructions, therefore it's faster.
I think one of the most exciting things about learning code is being able to like read other people's code. Like I'm really excited to start reading other people's stuff.
On the language,
of course, you're not gonna get one to one. You're never really gonna get. You're not gonna get one to one. I sometimes think about the assembly when I'm doing things in C#, and that's never really gonna be one to one with assembly.
You get to be, but if you want to go one to one, you could literally just like make a computer from scratch and do all the circuits yourself, and then like, yay, one to one.
That goes beyond assembly. I have no idea what you're talking about right
now. It does. But there was someone who made a functioning computer in Minecraft using just redstone. And it was like a whole... Yeah. Like, the redstone imitating the circuits in the board. Like, it was kind of crazy.
Yeah, I remember the first time I got introduced to that sort of thing being a thing you could do was when I saw that someone made an emulator for Pokemon, like, Yellow or something.
Holy hell.
Inside Minecraft. They made the entire game. Like, all the glitches worked as well.
Did it run like crap?
I don't know how fast it ran.
Damn.
I don't think it ran at real time, but it was all it wasn't with like on redstone though. It was with command blocks. But even then, it was like I forget. It was like some hundreds of thousands of command blocks or something.
That's crazy. I remember, I think it was so long ago when I saw the video, but when the guy made the whole like functioning computer with redstone, because it was in Minecraft, it was like the screen would update one line at a time, so it was like really slow. It worked, but it was like the screen updated so slow. It was crazy. Like yeah.
Command blocks and a resource pack? Yeah, that makes sense. How many command blocks did it take to do that? Let me see. I want to see how many command blocks this was.
It's not clear whether you want to move a byte
equivalent. I know it was a lot of command blocks. It was a lot.
Or word equivalent. Number was head. In such cases, why is it
357,000 command blocks.
Nice. Following table shows some of the. I thought it'd be more. Some of the common type specifiers. Oh, yeah, byte, word, D word.
Common type. Who uses T-byte? A T-byte, the number of bytes is not a power of 2. Why would you use that?
Oh. Following program illustrates...
That's not a power of 2 is inconvenient to use.
Some of the concepts above. It stores a name, Zara Ali, in the data section of the memory, then changes its value to another name, Nuha Ali, programmatically, and displays both the names. Yeah, so they're using the... Wait, you said I can use BSS, but that data is like different than BSS. So I can use data.
Yeah, BSS, no. I'm pretty sure I specified. Didn't I specify? Do not use BSS or data.
Oh, okay. I'm sad now. Or data. Nah.
No, you didn't get me. Yeah, you didn't get me on that one. I already covered that.
Okay, well, I'm
And
still.
I also said
It's
for
not.
even better measure,
It's not
for even
against the
better measure, I
rules,
also said
though.
everything must be. No wait, what if I do this?
What? No, I was gonna say it's not against the rules for me to be sad, so I'm just gonna be sad then. Does that make you change your mind?
You may not use the section or segment keywords. That's fun fact.
Why?
You don't, especially when you're doing it in assembly, you don't even need to specify section.text or section.bss or whatever. If you just don't specify it, it assumes it's all just in .text.
Section.text.
And you can see that in my assembly code. I don't even have the word section in there. Like, unless I put it in a comment or something, but like, I don't have the keyword.
Okay. Sad. It must be declared for linker. Start. Tell linker entry point. I should open up my a JDoodle. Let me make sure I save this link. I did. Good. Because I might end up coming back to this book, especially if I get confused and like literally have no idea what's happening. Then it's like, oh, maybe I should just read a whole freaking book about it. It's 25. And you know what? When you go off to boot camp, all I'm gonna have is this book, honestly, because you'll be gone. So it's like I have this long book, this book.
Yeah, that should take you 3 months to read.
Mhm.
So when I get back, I expect that you're still gonna be reading that.
That's mean.
Just no, I'm going to the Marine Corps.
No, you said
In just 90 says you're going to coding boot camp.
coding boot camp. Lol.
No, I'm going to Marine Corps boot camp. That's where I'm
In
going. I'm
just
not going
90
to coding
says aren't
boot camp.
most web dev.
I'm becoming a United States Marine. If I can get the right waivers. So that means I'm gonna spend a good 3 months not touching a computer or phone or anything, and I'm just gonna be like, just gonna be doing a whole bunch of physical stuff.
When he's gone, like I'm gonna become a programmatic god, and that's what he said. Like I'll be.
They're gonna make a faster LinkedIn dent than I ever could.
I'm gonna make my own kernel. By the time you're back, I'll be on my like own kernel, my own operating system.
Yeah, by the time I get back,
Beans OS.
By the time I get back from my service in the Marine Corps, they're gonna have made an entire operating system.
And it will have supplanted Mac OS and Windows OS. Like everyone will be using it.
Yeah, everybody will use it.
Oh, I'm so sad. Not doubtful.
And it'll be made in Unity.
Wait, is this? I don't know if this is weird or not, but in Just, you're literally the first person on Twitch. Wait, is this bad? You're literally the first person on Twitch I've ever seen use a yellow username. That's about it. Like, I've just never seen anyone with a yellow username ever.
Yeah,
ever.
I mean, it won't be a Twitch Prime thing that lets you do that. I think my guess is you don't normally have access to yellow. My guess is that you don't like people who don't have Twitch Prime can't.
Just 90 says yellow is the easiest to spot.
But this person does have Twitch Prime, so they're able to do that.
Oh, well, my guess is just no one uses yellow, and he's just the only one who, like, wanted to use yellow. That was my guess. Wait.
Hold on, let me see.
Change your...
color.
Yeah, do you use yellow?
Me says yellow is my favorite color.
Is it really locked? I wonder, is it really locked or no? But it looks really good on black.
What does yellow-green look like?
What does it look like? Oh wow, it just looks like a sadder version of
Corrupt converter says
why is it not showing up on my end?
I see your message, but where's... Wait, let's see your yellow.
Why, it's not showing up on my end.
Okay.
It's not showing up on my end.
Well,
yeah, anyone can change their username color, but for people who don't have Twitch Prime, they can only pick certain colors.
Oh, I didn't know that.
You have Twitch Prime, so you can pick any color you want.
I see. Twitch, I didn't know about that though. That Twitch Prime like makes it so like only lets you get more colors. It's cool. Slime lime.
But I don't like from the color that I'm seeing in there. I don't like it. I want spring green, black, spring.
No, I like your other green. It was cool. It was nicer. It popped better.
In just 90 says yeah, yellow is obnoxiously stand out, and I want my messages to be read.
Aw, no. Oh, that's why. I like it. It's cute. It's a nice color.
Corrupt converter says yes.
Yeah, and it does. It looks very nice against the black because I use like a black background.
I said shut up because I thought you were telling me to stick with the color that I had just changed it to. The
No,
other
no, I
green.
like your old. I meant your like your old green was like popular.
Corrupt
Yeah,
Converter
your
says
green-
yeah,
this
colors
green is
Your
that
original
stand
green,
out
yeah,
are
it's
good.
good.
But yeah, and just you can set it to yellow because you're in Twitch Prime. I don't have that yellow as an option because I don't have Twitch
Oh,
Prime.
look, we all
I literally couldn't
learned
pick that color.
something.
It doesn't let me.
Assembly.
Make sure you pick NASM.
I know. I need to get NASM. Wait, why did it go? Why did it disappear? Why? Why did my menu? Wait, you see that? The menu just like when I tried to click on it, went away. I'm like, what the hell? Give me my menu.
Oh yeah, this is a great website, by the way.
I know. Jank Doodle. Oh, this again. What is it? Bikaikalis. Biklekis. Wait, why did it? What? Oh my god, I have to keep clicking on them? It's a whole mini game. Wait, there's no Bikaikles anymore. I'm sad. Like, what am I supposed to click on? There's none. Verify.
Oh wait.
That's it. That was annoying.
Yeah, you have to keep clicking until there aren't any more.
Until time ends. Until the heat death of the universe.
Civitatum says color test.
Pretty much choose the same color. Color
Wait.
test. Okay.
Wait.
Copy paste all this. Goodness. Gimme.
Corrupt Converter says squid.
Give me your code.
Give me your Coke.
Okay, let's see. Will it run? Will it blend? It will run. Okay. Let me see if I can understand what's happening here. Telling your entry point, blah blah blah. Writing the name Zara Ali. Move EDX. Okay, they're starting with DX, not just from the A register. 9. Message length. Move.
I have a great naming system for all of my images.
Do you
I
know?
I want to look.
ECX.
I want to look at my hard drive because I had a great naming system for the like my Photoshop files in school.
Wait, so one letter. Okay, so EAX, like, you know, that whole register, all these EAX, EBX, all those registers hold 4 bytes. Wait, yeah. They hold 4 bytes, and every single letter that in a string, each letter is 1 bit.
One.
So I can
byte.
count. Oh, each letter's 1 byte?
You can't store
Well-
like 100 things in a single bit.
Wait, that's stupid. Wait, yeah, you're right. That's stupid. Because a bit is like 0, 1. Okay, wait, never mind. You're right. Yeah. Well, okay, fine. Fair. Touche. I concede. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this should be 8 bytes. But this register only holds 4 bytes, and this is 8 bytes. So how can it hold this in the register if it's only... How is that possible? See me?
What?
It's moving the string Zara Ali into ECX, but ECX can only hold 4 bytes, and Zara Ali is 8 bytes, I think. Or
No,
In just
it's
90
moving
says
the
message
address
length line 15.
of that string because the value of name is just the memory address.
Oh,
And it's
okay,
copied
it's just
to
the
memory
address.
Like,
Thank
I mean,
you.
that's the other thing with the other thing.
That's right.
I
Just working with addresses.
But yeah. So it's moving the memory address.
Oh, thank you.
Or
Message length line.
In just 90 says message length line
I'm
6.
reading it right, that's what it's doing. And if I'm interpreting it right, that's what it's doing. But also, like, you know, with the other thing, it was like kind of maybe, kind of, sort of, don't know, who knows what's going on, but that should be what it's doing.
Okay. So memory address to ECX of name, which is Zara Ali. File descriptor stand out.
Right?
Oh yeah, these are the arguments for the syscall.
In just 90 says read
1
the
for
comments.
this is for printing. Print out the name. This makes sense now. I'm nice. It's nice that I can finally sort of
Just
follow
90
what's
says
happening.
it is literally telling you.
Yeah. But I'm also trying to like remember what these things are before I read what it says. Because this isn't my first time seeing these instructions. Like I'm trying to like, because I have to later on. I'm gonna write my own assembly code, and obviously I'm not gonna have these nice code comments to guide me. Move name D word, and remember D word is how many bytes was that?
4 bytes.
Oh, you're good. 4, yeah, 4. Because it goes D word and then keyword. 4, 8. D word, keyword.
Byte word, D word, keyword.
Keyword. Nuha.
And XMM, YMM, ZMM words.
Change the name to Nuha Ugly.
Damn.
Move name. D word. Okay, yeah. 4 bytes.
Okay, am I gonna...
1, 2, 3. Oh yeah, and Nuha is a 4 byte. Well, this time they're storing the actual value, right? They're not actually storing the memory address. This is like the value,
Yeah.
and it can hold it.
At name. So remember what I said before, when I say at versus in, when I say at, it's talking about storing at the memory that it's being pointed to, and in is just storing in the variable. So that's storing at the value, the memory at name. So like in that Zara Ali, what it's doing there is just replacing Zara with Nuha.
Damn. Okay. But how does it know? How does it know to keep Ali?
It's because that doesn't replace that. It's not. Ali is too far for it to replace that.
Oh, it's just gonna replace the first 4 ones, no matter what. Okay.
Yeah, replace the first 4 bytes.
That's cool. Okay.
Why is this freaking breaking my file explorer?
Oh no. Also, I thought you said that the difference between data and BSS was like data has to stay the same and then BSS can change. Did you say something like that during runtime? Am I crazy? Did you say that?
Data doesn't change, BSS does.
But they're changing it here. They're deleting Zara and replacing it with Nuha.
Well, my guess is my guess is
yeah.
Okay, my guess is that it's not like strictly enforced. That's my guess.
Oh, it's just like what you're supposed to do in theory, like
you're
not
supposed to, but
you don't have to. Okay.
Have to. I shouldn't be doing that.
All right. Move AEDX. Wait, is this 1, 2, 3, 4, 5, 6, 7, 8? Yeah, it is. Move ECX name. Oh yeah, all of these things are actually, I think, operands to the system call, or whatever. ECX. The memory address into ECX. 1 for, yeah, these are called system call, file descriptor. Kernel, blah, blah, blah. And then end the program. Call thing. Nice. What are you doing? Are you still doing testing, or did you move on?
What am I doing?
Mm-hmm.
In just 90 says, what's your goal in learning ASM?
I don't know where I put it. There's I'm trying to figure out like how I name my Photoshop files in school. But in order for me to do that, I need to find out where the frick on my hard drive those files are.
Oh, okay. Here's the answer. Here's the answer to your question, so I don't even have to use my voice because I highlighted it earlier.
Me says to code games.
It's proving to be a bit difficult.
Also, I want to complete Corrupt's challenge.
Me says in Unity.
There. Here, I hold. Oh wait, now I'm gonna have to mute my TTS because I don't want it to read out that long message that I just wrote. But yeah.
I want to see if they learn assembly. Does that help them? Like how much does that help them to learn higher level coding?
Because the interesting thing is that's what actually Corrupt did, which is very like rare, I guess. But Corrupt did something very similar. So he just wants to see if he's an outlier or not. And I was like, yeah, I'm willing to be your science project.
Yeah, they were the first person out of like 17 people that was actually willing to try this.
Wait, you actually have asked other people and they denied you? No freaking way. Did they say no?
Yeah, my classmates.
They said, no way, but that you literally handed them a golden opportunity on a golden plate and they denied you? Because like, it's not easy to find someone who will teach you assembly. Like, damn, I can't believe they refused. Like, that's the type of thing you pay money for. I'm just saying. Like, it's funny to me.
Yeah.
There's no way I could possibly say no, because it's like...
Of me says I don't want to learn assembler.
Like that's
assembler?
Yeah, right there. See, there you go.
Tisk.
Why the frick does this, like, not open? Can I open this in, like, something else that maybe has, like, less lag opening this? Open archive?
Your computer's lagging?
So much faster.
Oh, damn it.
Right. I had to have these files somewhere else that's, like, less laggy than this, surely.
Oh, that's what these DD thing are. Like, now they explain it, but they waited all the way to this chapter before they introduced that. And I was like, what the hell are these things? Alright, assembly variables. I thought there weren't variables in assembly, but I guess not. NASM provides various define directives
I really thought I had.
for reserving storage space for variables. The define assembler directive is used for allocation of storage space. Ooh, it does say assembler. It can be used to reserve as well as initialize one or more bytes. Okay. Allocating storage space for initialized data. The syntax for storage allocation statement for initialized data. And it's what you said. You do need the brackets before you do the thingy. But before they weren't using brackets. But yeah, it's saying it here now. Brackets. Variable name. Define directive. Initial value. Initial value. Hey, corrupt. Why do you think, why is this initial value in brackets, but then the one next to it's not in brackets? Like, is it saying, like, you can use either one, it doesn't matter? Like, I'm guessing it's like an or, you can do this or this? For the...
It's an array. I think that what they're saying is it's an array.
Oh,
like,
okay, thank you.
Like you just do like initial value or something, and then you do a bunch of other values.
Oh, yeah.
You see this.
Like
You're
3, 4, 5, 6, whatever.
You're probably giving examples like immediately after.
Oh, that's
Let me see, what are they give like an example of like that thing there? I don't know.
No, but they didn't give an example of an array, which is sad. But yeah, now I see. Array.
Well, what I imagine it is that when someone puts like a string and then they do comma something else.
Comma, yeah.
Civitatum says assembler directive must be a correct term. Assembly refers to the language. Assembler refers to the program that compiles assembly into machine instructions.
That actually makes sense because an assembler is something that does the assembly. Like a factory assembler would be the ones who make the products. That makes sense. I didn't think about that. For which the directive is a special key. Oh.
Civitatum says for which the directive is a special keyword.
Okay, a special keyword for that compiler thing that turns it into machine code. That makes sense. Not necessarily the language, but for the actual compiler. Please
Me
no.
says like a compiler.
Define directive. Where variable name is the identifier for each storage space. The assembler associates an offset value for each variable name defined in the data segment.
Civitatum says it's like.
There are 5 basic forms of the define directive. DB, define byte, allocates 1 byte. DW, define word, allocates 2 bytes. DD, define double word, allocates 4 bytes. Oh, DQ, define quad word. Oh, Q stands for quad. It's 4 bytes, but it's not 4, it's 8 bytes. Cause it's 4 times the word. 4 times 2 is 8, so it's quad word.
Says LOL, I can sense.
This actually makes sense now. And then DT, define 10 bytes, allocates 10 bytes. Following are some examples of using defined directives.
Civitatum
Oh my
says
god,
sign.
accidentally. See.
Hey, I gotta find. I need like the full list of all these freaking things. I can't find them.
List for what? What are you looking for?
Broken up because Google Takeout breaks them up in stupid ways.
Oh, yeah, I was gonna say, Corrupt already discovered all the, like, symbols that F the TTS up, yeah. On the first 2 days of watching my stream. That wasn't annoying at all.
Linear death room, core module, wiggle time,
Wiggle.
organisms, internals diagram,
What the
broken
hell?
slime.
Devil's using defined directives. Choice DB. Y. Number DW. 1, 2, 3, 4, 5. Because this is 2 bytes. 1, 2, 3, 4, 5. Neg number DW. 1, 2, 3, 4, 5, 6.
I came up with like stupid ass names for all my like Adobe Photoshop and Illustrator stuff that I do in class.
Big number DQ. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Gesticulation.
Real number DD. 1.234.
Yes.
Real number 2 DQ. Oh wait, define quad word. 1, 2, 3, 4, 5, 6, 7. 8
Regular
bytes.
fish, pending deferments.
8 bytes.
Repercussion, 9 Nagahara.
64. Wait, wait a second. I was gonna say, for a second I thought all these things were storing like the string of the number for all of them, but actually I don't think so anymore. Only the Y is a string. So, I'm kind of curious. Well, do you know this off the top of your head, Corrupt? This number, for example, 123.456. How many bytes does this actually take up? Like, to store it?
Well, it's saying to store that as a quad word, so it's storing that as 8 bytes.
Well, I mean, how many... If you use the minimum amount of bytes possible, what I meant is not how big is the quad word that's stored in. Because, you know, you can have a bigger storage case than you need. Like, how much size does it actually take up? Like, if you had
minimum to store it exactly, like
yeah,
minimum to store it exactly within like those 6
would be
digits
used frequently by those who need long doubles.
Probably 3 bytes minimum, if you wanted to be able to store that.
Oh, you think 3 bytes for this length? 1, 2, 3. 4,
but they would probably just go with 4 bytes instead. But even then, you still have other problems.
Okay.
For a 4 byte float.
Oh, and okay.
It depends on how you want to store it and the way you want to store it. Because technically, you could store that in you could probably store that in 1 byte, but you just like you can have that value be represented in 1 byte. It just depends on how you handle that byte. You just wouldn't be able to do a whole lot with it.
Okay.
But,
well, what is it?
Like the less bytes you use, the less you can do with it.
Yeah.
And the less things you can represent. That's all it means.
Okay. What does it look like? If you did store in 1 byte, then what is it? What does each bit look
value
like?
Of 1 byte. Basically, what I mean is you pick any arbitrary value of 1. You could pick like 50 and say that's 123.456. Means absolutely nothing.
You could pick 50? 50 what? Bytes?
You could pick 50, you could pick 100, you could pick 30, you could pick whatever, and just say that means that number.
Oh, you saying like pick any number? Like
it's not like you wouldn't be able to do anything with it. Like you wouldn't be able to like add 1, subtract 1, and multiply or whatever. You wouldn't be able to do a whole lot with it. It would just be pretty meaningless. But you could define it that way if you wanted to. That's basically what I'm saying. Is your question is like kind of doesn't make a whole lot of sense.
No, I'm asking you because I want to understand how the float is stored. That's why I asked it specifically. Because floats are weird. That's literally why I asked.
It'd be stored usually as either 4 or 8 bytes. So that one would be stored. Like minimum, you'd store it in 4 bytes. But this is saying specifically to store it in 8 bytes. So it's storing it as a double precision.
Okay, got you. So minimum, no matter what the size of my float is, I'll always use 4 bytes for a float. Like if it's
also need long doubles. SPQ, are long doubles like? Hold on, are long doubles actually handled like by the CPU, or do you need to make like a software implementation to do long doubles?
Oh damn.
Do you need like a software implementation of floating point arithmetic on long?
Wait, this SPQ, you code in assembly? Oh, but then again, you do know the language, and the language fits nicely in with assembly.
Like, can you use like the floating point arithmetic
10
instructions
bytes.
on a 10-byte float? You're not sure? Okay.
Long double to be 10 bytes.
Civitatum says I'm not sure.
10
TBF.
bytes. That is a what was it called again? Oh yeah, they said tera. Didn't they say terabyte or something?
Civitatum says let me check what does the language produce.
T-byte.
What does the language produce?
The language. It is the language. The language.
Your colors. I was like, your color is different. I'm pretty sure. Yeah, your color was red before.
SPQ's name? No, it wasn't. It was always purple, I think. Actually, maybe in the past it was, but like how far in the past? You mean today it was blue, purple the whole time?
I'm rolling up. Their name was red when I scrolled up.
It's not for me. Oh, it must be a bug on your screen. Their name's not red at all, ever.
They
Seriously.
Their color changed when they said color test. So
well, when they did color tests,
Civitatum
they're purple
says I
on my
changed it
screen.
to blue some minutes ago.
Oh, okay. Well, it never changed for me.
I'm saying they're red when I scrolled up to further. Yeah, what they're saying. They're red when I scroll further up in chat.
Yeah,
So
but when they
color.
said color test, their name is still purple, so their color never changed on my screen. That's all. I didn't know.
No, I'm talking before that.
Yeah, before that, they have no red. Like there is.
Look at it.
It's like a bug on my screen. The colors didn't change at all. The only color that changed was your name. That's it. I don't know why.
Well, look at that. I sent you it.
Send what?
You're wrong. You're bad. You're dumb. You're stupid. Shut up.
I'm not, because my screen effed up. Maybe with inline assembly. Here, now I have the freaking screenshot too. But I can practice my alt print, whatever the hell you taught me. Alt print crap. Alt print. Just grab the screen.
Well, for things that are not entire windows, you use Windows Shift S.
Really? Oh, that's new for me. Windows Shift S, and then it grabs just the one window or something.
And then you can drag across the screen to select an area to copy to.
Oh, but it will go to my clipboard, right? Windows Shift S.
Yeah.
Oh, cool.
Well, and then if you click on the thing that shows up on the bottom right corner of your screen, the notification, then you can save it as a file.
Oh, wait. What am I saying? I know Windows Shift S. I know I've used that before, but I never. Okay.
Wait, you're telling me you've used a computer before? That's crazy.
I know, but I've used Windows Shift S, but I don't know why. The way you said it made it sound like something completely new. I'm like, oh wait, Windows Shift S, duh. I use it all the time. I use it like once a day. Okay, maybe not as that much, but I use it a lot. Okay, hold on. I have to go all the way back. Fine, there it is. There's the set of messages. Okay, well, I will try the Windows Shift S because you said I could. There's a button for copy to clipboard, and that's actually what I want.
Screen copies the entire window. Windows Shift S lets you select a specific area of your screen.
Yeah, I know. I use it all the time, but I can't find the copy to clipboard. That's what I want. Oh, there we go. I think I did it.
I think it just copies the clipboard, maybe.
Well, there was a button. There was a button that shows like.
Well, there's a button, but I think it also does just automatically copy the clipboard.
Okay, maybe. But see, my screen never changed. So. That's why.
Red.
No, it's not.
Are you colorblind?
You gotta be kidding. Because if you're trolling me, then you're actually colorblind.
No, I think you're like actually colorblind. That's red.
No, it's not. What I just sent you? No, you're actually colorblind then. You're trolling me. You're trolling. You're so mean. Like, stop messing with me. Stop it. Just stop. Anyway, okay. The time assembler, where is it? Oh my god. Look what you've done.
I was like, before you sent it, I was like thinking like, how can I make this funny? And I came up with that.
How? So this is how this is how you define funny. Hey, look at this. I could have made a dark mode the whole time, but I didn't. How do you feel about that? You see? Lights?
I don't like the bright orange that they use on that thing there. Like, for dark mode, that orange is not great. They have
good.
Okay, their dark mode on here sucks.
Okay, good to
Dark
know.
mode would probably be a better dark mode. I wonder. Actually, let me check this. Let me see what this looks like on Dark Reader.
Okay.
What page is that?
Here, I'll copy a link for you.
This is tutorial. Wait, page is this?
I sent it.
On the
Only example. Wait, where was I?
assembly constants. Okay.
Yeah.
Okay. Let me see. What does
Actually,
this
I
look
was
like on
too
Dark Reader?
far. I was actually supposed to be reading this page anyway, but
The frick? Why is it set to that?
please note that each byte of character is stored as its ASCII value in hexadecimal.
Dark Reader has a better dark theme.
Each decimal. So look, this is, even though it's not written as like a string or whatever, it's still storing the ASCII. Wait, it says, because it says each byte of character is stored as the ASCII value, but in hexadecimal. Oh wait, never mind. So each decimal value is automatically converted, never mind, to its
Look at this
16-bit
dark theme.
binary equivalent and stored as a hexadecimal number. Oh.
Yeah, look at how much better that dark theme looks.
16-bit binary equivalent and stored.
Oh, my phone turned off. That's what you can still hear me, right?
Mm-hmm.
Okay, good.
Yeah,
Making sure.
it's better. Processor.
Yeah, because like ideally with dark theme, the idea with dark theme is you don't have bright colors. And look at the color of those text boxes.
Yeah, it doesn't
Bright
really bother me too
freaking
much.
white.
Well, I don't really like the white one, but this one, the orange is kind of cute. It's like very pumpkin spice,
I mean,
you
the
know?
orange isn't too bad, but the white kind of defeats the
Okay.
purpose of using dark theme.
The white is just dumb.
Yeah, the white just defeats the purpose of using dark theme.
Mm-hmm. Processor uses the little endian byte ordering.
You're gonna have like 40-50% of your screen white when you're using dark theme. You're not using dark theme.
Negative numbers are converted to its 2's complement representation.
And your number 2's complement is when you flip all the bits and add 1.
Oh yeah, you just we and then remember we talked about this for a very long time that one time, and it was really interesting.
Yeah, we spent an entire like 8
we
hours
did.
on
It actually was like 8 or 9 hours, but then I finally understood it, and I was like mind blown. Like it was the coolest thing ever.
Of me, says Big Endian.
Little endian. Short and long floating point numbers are represented using 32 or 64 bits. Oh yeah, you did say this. Floating point is either. Wait, you said. I don't think you used bits though. You said like 4 bytes or 8 bytes or something. I guess what you said.
Same thing.
Is that what you
Well,
said?
I'm like stopping myself from saying like 32 or 64 bit because you were saying that's confusing you.
Oh yeah. I'm saying like this lines up with what you said. I think so. That's cool. Respectively, yeah. I like the bytes more than the bits. To be honest. The following program shows the use of defined directive. Global start must with linger.
But I mean, at some point, as you get some ways in, I'm just gonna start intermixing 32-bit, 64-bit with 4-byte, 8-byte, just whichever one is more correct to say at
the point in time. Okay.
And I'm gonna be like, I don't care.
Okay. Okay. So, tell linker entry point. Message lane 1. Makes sense.
Question.
Message to write choice.
What do you think of my project naming scheme?
40x80. I don't know.
So I've got underscore name segment underscore junior dot psd. I've got organism internals diagram. I've got broken slime. Gesticulation. Okay, what are the good things here?
Allocating storage space for uninitialized data.
Wiggle time.
Reserve directives are used for reserving space for uninitialized data. Space directives take a single operand that specifies the number of units of space to be reserved. Each defined directive has a related reserve directive.
Pythagoras and shape moves.
5 basic forms of the reserve directive.
The thing is, I have absolutely no idea what these projects are.
Then it's probably not a great naming scheme. Reserve a word. Reserve a double word.
I'm pretty
Reserve
sure
a
I
quad
named
word.
it. I named it that way specifically so that way nobody would understand what it is unless they opened it. Just because, like, I just came up with random stuff.
Wow, that's terrible. Reserve 10 bytes. Explore latest online. Oh wait, no, that's an advertisement. Multiple definitions. You can have multiple data definition statements in a program. For example, choice DBY, SKY, 79H, number 1 DW, 1, 2, 3, 4, 5. Oh wait, I shouldn't read off the letters. I need to like say what they are so I remember what they are. Choice defined byte Y. There. Oh yeah, stored as ASCII. Number 1 define word 1, 2, 3, 4, 5. Wait, what? Did you say something? At some point? Did I interrupt you? What'd you say?
Did you like reading?
What?
Take your pills.
Okay. Number 2. Define D word. 1, 2, 3, 4, 5, 6, 7, 9. 7, 8, 9. There's a typo here, but that's fine. Huh.
Oh, yeah, there is a typo.
Yeah, I see it. Like the D here equals. Wait, I feel like you were about to make fun of me, and then you're like, wait, there is one.
No, I was like,
Okay.
is there a typo? There is a typo.
Typo. BCB.
They also have that weird extra space on that line for some reason.
Where?
On
yeah.
The DD.
Oh wait. D.
I very much don't like the.
You mean after ASCII?
The DB, DW, BD, and also that weird space as well is also weird.
Oh yeah, that does kind of look a little. Oh yeah, they're all like weird. That's weird. I don't know why it's like that.
Why do they like space like?
Why are they doing this? I know it must be like intentional to like mess with people who are reading this so that they're bothered. Of course, it's because they wanted to bother you in particular. That's why they did this like this.
Well, I think this would not just bother me. This would bother a lot of people who care about formatting and code.
Damn. Well, they want to bother many
most people
when they look
like
at
a
this.
lot of people who write code for a long time are gonna look at that are gonna be like that's like the worst formatting I've ever seen in my life.
Wow.
But me personally, I'm not gonna say it's the worst formatting I've seen in my life. You wanna know why? Because well, I've looked at my classmates' code. And yeah, things get bad.
I see.
Things get quite bad.
Quite bad. The assembler allocates contiguous memory for multiple variable definitions. Okay. Multiple initializations. I don't know, I'm actually. Oh wait, no, damn it! I thought I was like all the way down here when I saw this green thing, but then I realized like no, I'm actually here. That's okay. I'm at least halfway through, but it's gonna get really confusing once I get into like freaking recursion and stuff. It's gonna be like when I first learned about recursion, and I'm talking about high level languages. I mean, I was on recursion for like a week and barely understood it. So that was fun.
Oh yeah, recursion recursion in assembly. Like, I don't think I really read as much as you're reading right now. I just kind of learned like the basics from there. Recursion in assembly, I didn't even look up anything on how to do that. I just figured it out myself.
Oh damn!
I needed to figure it out for doing writing a simple calculator in assembly. I needed to do recursion in order to do parentheses. Like, you can do addition, subtraction, multiplication, division just by going left to right.
Wait,
but
what?
You need to use recursion for parentheses because you need to kind of go back and forth a little bit.
I see. Wait, what operations could your calculator do? So it could handle parentheses, I guess.
Addition, subtraction, multiplication, division, and parentheses on integer numbers.
Okay. But it would, if you did it on integers, would you get? Would it give you a decimal back, or what would it do if you try to divide integers?
It's integer arithmetic. So it's just doing integer operations, round down for division.
Oh, so it will always return an integer too as well, right?
Yeah,
Okay.
we're always returning it. And one thing I should do is
What?
I should do that thing, but do it for floats, and also add things like exponent and natural log
Oh
or logarithm.
damn! You should. That'd be
'Cause
crazy.
I
Natural
could do
log.
all that. I could do all that.
Don't forget the E and the I. Okay, no, I'm just kidding. But natural log's
I could
crazy.
also make it do complex numbers as well and add like cosine and sine and all that.
I'll cry. I'll cry because your calculator knows how to do it and I can't. So it'll make me sad.
I'll make a cut. And so here's the deal, right? Once I figure out how to do it in assembly, I'm gonna add that to the list of things you need to do in assembly.
Okay, but it gets added to part 2. Like you have to divide it at least. So it's like calculator part 1, calculator part 2. That's all.
Calculator part 1 is
So I can do the easier one.
Wait,
Wait, no, but I'm not even going to be able. I'm not even going to be able to do it for a while. That's just the truth because I don't even understand how to do it in like plain English. Like I don't. Like I still don't completely understand complex numbers. I haven't reached that point, so I'll have to reach the prerequisite level of math before I try coding it. Obviously.
Well, you'll figure it out.
What the hell? Oh.
It'll make sense. It'll
Won't
make sense.
make sense. It'll make no
So
sense.
I mean, it's actually really simple because it'll make sense because by that point when you get to that, you'll have learned how to break down problems into very tiny parts. And what you'll realize when you look at that is you're breaking it down into reading a number and then reading up until you find an operator, and then depending on what that character is, whether it's like a plus, minus, asterisk, or slash, then you go and do different things for like addition, subtraction, multiplication, and division.
Okay.
And then you can also group like multiplication. Can you hear me?
Yeah.
Okay, I was making sure because sometimes it disconnects me.
Oh.
And then you group like multiplication, division into like these blocks, and then once you get something that isn't that, then you return it. You kind of like return it. You like save that, or you like if you go from like addition to like multiplication, then you save where it was before you did the multiplication, and then you got to do something because of orders of operations. It'll all make sense when you get there.
I don't see how this is gonna help me understand complex numbers, but okay.
It's not gonna help you understand.
That's what I meant. Not the. I wasn't talking about the process of coding it. I was talking about what the hell what its like actual meaning is. Like that's different. Lol.
It's not gonna help you understand complex numbers. There's nothing to do with complex numbers.
I know. The assembler.
Civitatum says GCC is using weird ST registers
there are
that
instructions
are
to work with
80-bit
them.
floating point registers, and there
The
are
hell?
instructions to work with them.
Oh god.
Interesting.
Weird SC registers.
I find it kind of weird that they actually have like dedicated CPU instructions for that when like nobody uses it.
No.
Like I didn't even know that existed, like at all. I didn't even know that existed.
That's
Nobody
why you
knows
should
that
only
existed.
use MSVC forever.
What?
I said that's why MSVC should always be used because yeah. That's the other compiler. That's the Microsoft's version for C and C++ compilation.
I used MSVC for my license amp program when I was doing it in Unity.
Oh hell yeah! You used it? MSVC? Yay.
Yeah.
Okay, well,
I used it for Unity.
respect.
And can you imagine that? For when you're writing code for Unity, making a Unity game, you use C. You need C# when you can use C.
Nice.
You still need C#. I did a lot of C# on it as well for setting up all the memory.
And C#'s just like also, I mean, it's the one you have the most experience in, but it's your favorite one to use, right? Like the most fun to code in, syntactically.
I like C#. C#'s good.
Yeah.
It's also it's the first one.
C#'s pretty fun.
But yeah, it's also pretty convenient.
I like C# too. I don't know. Every time when I learn other languages, like they're cool in their own ways, but C# just it never. Even when I remember when I was learning Java, I never really liked it that much. Like the syntax part, like coding's cool,
Yeah.
but C# is nice. Something about it is nice to use.
People who say that like Java and C# are basically the same thing. I say they have pretty much the same syntax, but C# has much better features than Java. Like there are a lot of conveniences that C# has that Java just doesn't. And pretty much everything that Java has in terms of language features, already C sharp already has. So
Yeah,
there's
but
stuff
the
C sharp
most
has that Java has. This Java doesn't, but there isn't really stuff Java has that C sharp doesn't.
the most convenient
I mean,
feature they
unless you're
have.
gonna make an argument for the libraries and the platform independence and all that, I mean that's a whole other thing. But I'm just talking about the language itself.
Yeah, only the
Language
language.
itself.
My favorite feature of
There's
C Sharp is the documentation is actually pretty nice to read. Compared to other types of programming documentation, it's fairly user friendly. In comparison, like I do appreciate, and then they have these little code snippets throughout the
unless you're
documentation.
trying to find out what the hell make ref value
Oh
and
yeah,
and
well we ignore. Yeah, if it's like normal, yeah,
you can only find whispers
you can't
about
find
things.
anything. Yeah, well we don't talk about that part.
The only way, like, as a regular like C sharp programmer, the only way that you'd ever even really find out that those things exist is if you like decompiled the Microsoft stuff and looked at like their keywords and like you managed to find their keywords list and you found that in the keyword list. You'd be like, what the hell is this? Like what the hell are these things? I've never seen these keywords before and these don't look normal.
These don't look
You look them up
normal.
and you find out what they are, but like figuring out how to use them is like really difficult.
Yeah.
Even as like this whole type reference that is super hard to use and pass into things or something. Like it doesn't even act like a normal C sharp type. It's weird.
Damn.
Like it's like you can't set things to and make things that type or something or whatever. It's really inconvenient. I didn't like the things that I couldn't do to it.
Multiple initialization. The times directive allows multiple initializations to the same value. Oh my god. For example, an array named marks of size 9 can be defined and initialized to 0 using the following statement. Marks times 9? A times directive is useful in defining arrays and tables. Wait. So you're basically saying there's like an array that you can add 9 values to before something gets overwritten or something weird? Arrays and
You're
tables.
allocating 9 bytes per array.
Oh yeah. Good point. You're right. 9-byte array. The following program displays 9 asterisks on the screen. Okay, global start. Type a linker, tell linker entry point, blah blah. 9 stars, ECX. Oh, message. Okay, message array. Okay, so stars is times 9 dB star. Wait.
Also, another funny thing about this is it's like assembly isn't really case sensitive. A lot. So like you see in some parts of this code they do DB uppercase and other parts.
Oh
yeah,
that's why I was confused. You're right, because up here, you're right. There's DB, and there down here it's like
it's
DB.
I think it's not case sensitive. I don't know if like variable names like stars or whatever are case sensitive, but I know like mauve and DB and all that stuff are not. I wonder if it's just fully case insensitive or if it's just like, let me test this.
Wait, I was gonna say that's easy to test. You just change the caps and see if it breaks. No.
Change the capitalization of one letter here.
3, 4.
Change the capitalization of one letter here. X
times 9 divided
by.
by.
It doesn't. I changed the capitalization of one letter here instead of the whole thing, and it does the same thing. So, but I don't know. But like I said, I don't know if that applies for. You know what? I can test that too. Why don't I test that?
Okay.
Because.
Well, do you want to know something that surprises me about this code? Even though I understand what's happening, but want to know what was surprising? Because something did surprise me. Because I know this prints 9. This puts 9. There's 9 stars. And stars. Well, yeah. Yeah. But I'm surprised, it didn't just put 1 star and then the other 8 bytes are empty. That surprised me. Why it didn't do that. Because that's what I thought would have happened. I thought it would put 1 star at the beginning and then 8 bytes empty.
What this thing is,
yeah.
It's not, well, the times 9 is not saying allocate 9 bytes.
Oh, that's what I thought it meant. Allocate 9 bytes and then put.
It's not allocating 9 bytes. It's saying whatever you're doing, whatever you're allocating, allocate it 9 times.
Oh, okay. Okay.
So, like, let's say if that was 3 stars, it would
Oh.
allocate 3 stars 9 times, and you get 27 stars.
Okay, so that's what multiple initializations mean. It means put it in, or do whatever your operation you're doing this many times, 9 times.
So the variable, so those
Star.
that names like stars there, that is case sensitive. If you put uppercase stars somewhere else,
Okay.
it wouldn't.
Like move and stuff, it doesn't matter. But and
Like if you put uppercase stars somewhere else, it wouldn't. But like registers and instructions and pretty much everything else is case insensitive.
That's good to know. That's cool. HR interview questions. Oh my god. Sorry. Oh, thank you. I bet one of the HR interview questions is like, is 0 true or false in most programming language? And I'd fail that question. And...
Is 0 true or false? About 70% of our applicants get fired, get rejected on this question.
Oh damn, that's pretty bad. Hopefully that's not true. That doesn't happen, because that would be pretty bad. Like, why are you even applying if you can't answer that question? Sniff.
No, they say that only to you.
Oh. I guess it would make me feel a little better that I'm not. If they said something like, if they said this instead.
They don't want you to feel too bad about
yeah,
getting it wrong.
You know what? The sad thing would be this: if I got it wrong, and then they said to me, "Wow, we're really shocked because not a single applicant has ever gotten this question wrong. Like, that's how bad you are." Like, what?
They say like, this is really easy. Everybody gets this right, and then you get it
wrong.
Oh
yeah, and then they say, "Here, let's start off with an easy one, like an obvious one. Like, no one, it's impossible to get it wrong," and then you get it wrong.
Yeah, you get it wrong. You're like,
But you know what I would do in that situation? Honestly, that's when you use.
I'm sorry, the position has already been.
No. What you do? Listen. What you do if you get it wrong is you use your social skills to say, "Bruh, I was just kidding. I obviously wouldn't have gotten that question wrong. I'm pulling your leg." Like, then you use your social skills to pull.
So what they do is they have like their computer screen there, and you just see their face turn a solid red from the screen of the computer, and then a trap door opens beneath you, and there's a grinder underneath there. You just get turned into soup, and then lunch menu the next day for the company, it's soup.
No.
By the way, that's a story. That whole sequence of events is kind of like what we were coming up with before we graduated. We're like, if you don't graduate, that's what happens. You get turned into soup. The students that don't graduate, they get turned into soup.
Wow.
And that's why all the soup happens. That's why the soup comes from.
Wow. There's several directives provided by NASM that define constants. We've already used.
That's what my friend group does.
What?
So that's what my friend group does.
I see. We've already used the EQU directive in previous chapters. No, we didn't. Oh, wait, I skipped? Wait, no! No, that's a lie. We didn't use EQU once. They're totally lying. They didn't use this, ever. This never shows up in any of their previous code, so it's a lie. It did not show up. We will particularly discuss these.
I think it did. I think it did.
No, it didn't.
It's probably in like one of the very first chapters of this thing.
I swear to God, if I saw it, I would have remembered it. I don't remember a lot of things, but I don't know. I would have remembered this.
You've been gone for like 50 days, so of course you're not gonna remember it.
Yeah, it was not. No, they did not. Like, if you go back and Command F every single one, which I'm not, but it won't show up because it did no way did it show up in anything. Not one time. Not once. They did not do that.
Stupid. Okay.
Yes. EQU, percent assign, percent define. Okay, the EQU directive. The EQU directive is used for defining constants. The syntax of the EQU directive is as follows. Constant name, EQU, expression. Total students EQU 50.
Hey, look how long it took me to find it, like 20 seconds.
Find what?
It's in the basic syntax, they have it there.
No.
Basic syntax.
Dude, this is the page I'm on. You can't. This is the page I just started reading.
You're not on. You're on the constant section. I'm talking basic syntax. It's the fourth
Oh,
thing.
why did you send me a picture of constants?
I didn't. I haven't sent you a picture of the thing.
Yeah, you did. You sent me a picture of constants, not this.
That was like freaking 5 hours ago.
Really? No way.
That was like 20 minutes ago.
You're right. I thought you just sent it to me right now. You're like, wasn't that 5? It wasn't 5 hours ago, bro. It was just like a little while ago. It wasn't 5 hours.
Okay. And look right there. It's equal. Echo. Right there on the message.
Okay. Well, this is. Reconnected back. That was weird as hell. Anyway, where were we? Make sure you have set the path.
What the frick is going on?
You said it was in basic syntax, and I'm like, yeah.
What the frick is?
EQU was used.
What's going on? What's going on?
Aw, damn, that shouldn't. Okay, fine. I guess you're right. EQU was used down here.
What is this? What is this fucking shit?
What's wrong? Why are you freaking out now?
What the fuck is this? What the hell just happened to my computer?
What happened to your computer?
I had this bright white screen that said, "Please wait."
Please wait. Are you? Wait, you asked me if I'm getting hacked. Are you getting hacked?
Yeah, am I getting hacked?
Are you getting hacked? Like, damn. Please wait. That's scary.
What the fuck?
Hey, guess what?
Now everything's freaking broken.
Oh no. Well, it's welcome to the game, but like for realsies.
Oh, my computer is lagging incredibly hard.
Why don't you restart it?
No, I lose my uptime if I do that.
Oh my god. Only you would say that. You lose your uptime.
Did I misclick something? I must have misclicked it. I must have did a keybind that did something.
Or you just, installed a bunch of viruses. Good job.
Wait. What the freak is going on?
Assign define. You just said I'll lose my uptime. That's hilarious.
Wait, what the? Am I in? What is this theme? Is this high contrast theme? This looks like I'm in high contrast theme. Did I just turn on high contrast theme? What is going on? What the frick is going on?
Yes.
Okay.
EQ expression. You can then use the constant values in your code, like move ECX total students, move EAX.
Ease of access.
Oh, CMP,
okay.
EAX,
oh, I turned on high contrast. Oh, that's what I did.
Okay, good job. What is?
You know what? That explains why. Okay.
What is CMP?
I found the key combo for turning on high contrast. Wait, I wish I knew that key combo existed in school. I would have fucked around with people with it so much. It would have been so funny.
Well, there. I could see you doing that. What is CMP? What does that command do? Or whatever?
Compare.
What?
Compare.
Oh, compare. Oh, compare. Bitwise operation. Yes. That's right. See? Wait, right? Yeah.
Not necessarily. I don't think compare is a bitwise compare.
Oh! I see. Okay.
It's like mostly like an integer compare, pretty much.
Okay.
It's like compare this thing less than or greater than or equal to.
Oh, yeah, and then it sets all those different flags, and you have to return a specific flag or whatever, you have to check the flag you're interested in. That's what you said, I think.
That fucked the shit up of my computer. That was crazy how that did that.
Well, you fixed it pretty fast, that's good.
But I fixed it. I figured it out.
Nice.
I figured out when I saw my taskbar was all black, I was like, looks like high contrast. Luckily, I knew that was high contrast because I've seen that before.
I see. Tell link or entry point. Move EAX.
I did not know that was a key combo.
Syswrite EAX. Oh wait, Syswrite's on here. Wait a second.
I was trying to take a screenshot of the stream, and it was doing the whole not like this blue background thing.
Beautiful.
And then I turned on high contrast because apparently that's a key combo that exists.
Lol. Wait, what were you screenshotting? Were you screenshotting the EQU
I
thing?
was trying to screenshot your stream. What the frick key combo was that?
No, I said what were you trying to screenshot? Like which part?
Your stream that was down.
Oh, so you could. Oh yeah, the one so you could show me that it was down. Nice.
Yeah.
Wait, what is so Sysrite must be special? What is Sysrite? Because Sysrite's getting moved to EAX, but like, what is that?
Oh, it was alt print. I did alt shift print screen instead of alt print screen. That's what I did wrong.
Oh, that could happen to me easily too.
'Cause I got mixed up between Windows Shift S and alt print screen.
Oh yeah, it's because you told me about Windows Shift S and then you confused yourself and mixed them
I've
up.
never told you about that.
Yeah, it's your fault. Skill issue.
Yeah,
But yeah, what is Sysrite?
You almost blew up my computer.
It's not my fault. It's your fault. Skill issue. Sysrite.
No, that was you. If you weren't there, I would have never blown up my computer.
It's not. Writing into the screen, exiting from the... Writing into the screen.
Syswrite is writing to... Basically, like, what it means there is writing... It's talking about, like, writing to console, pretty much. Like, Syswrite is 4. Like, EAX 4. They have this stuff probably defined somewhere else.
Oh, yeah, because I'm like, that's what I was looking. I was like, where's the definitions? And I couldn't find the definition for Sysrite.
This defined somewhere.
Okay.
I mean, is it in this code? Is it not in this code?
No. Oh, it's at the top! I'm blind. I skipped it. I just went right down here. Sysrite. Constant 4. Are you okay?
Yeah, it's there.
You need your pills, need your meds.
So, Sysrite is 4. Yeah.
Okay.
What did you say?
I was asking if you need to take your meds.
Wait, what the fuck? Here they have standard in as 0, but in the other code they had it as 2.
Does that bother you? They did that?
Because they're inconsistent.
They are.
Why are they inconsistent?
Yes. Yes.
Because that was one of the problems that that was the problem that we had before, where we had to change the number in order to get to work.
Oh,
That's the number
yeah. Now they're using...
Why do they have a 0 here, but 2 in the other code on the same tutorial?
Wait, did you and the one you fixed, you had to change the 2 into a 0, right? Isn't that what you did?
Yeah.
To it. Oh yeah, now they're like, yeah, that's weird. It's probably a typo. I bet it's a typo. Like they were supposed to put 0 the whole time, but they effed up and put 2 and just broke their own code.
Yeah, I don't know.
Yeah. ST out. Oh, standard output equal 1.
Yeah, the STDs go out and the STDs go in.
Wow. Okay. Well, very accurate. Damn it. AVX. Okay. Now I can't stop seeing that. Stop it. Why'd you do that? Standard output. Move ECM. That's mean. This is stupid. That's not what that means. Message 1. Wait, move ECM.
Oh, it could be.
You're wrong. You're just wrong. Lane 1, move EDX. Okay, wait. Message 1, Divine Byte. Hello, programmers.
What's this? Here are the recommended channels: pools, hot tubs, and beaches.
What the heck?
Why is that a category on Twitch, by the way?
I know, right? No, the worst one, the most egregious one, is just sleeping. Like, that's just weird as hell. One.
Pools, hot tubs, and beaches was really interesting on like a couple months ago.
Okay. Wait, can you remind me what the $ thing is again? Oh wait. You said this is the length. Getting the length of the...
Current location. I'm pretty sure that means current location. I don't know if that means current location like always, or if it's just in data.
Mm-hmm.
But to my knowledge, right there, it means current location. Like, I'm wondering if I can use that in the .text section. I'm not 100% sure if I can or can't. But right there, it means current location. Wait, what if I... Wait, you know what? I could test this.
Oh, okay. What about the what about the dash thing after it? What is that again? Oh, because there's a $, then dash.
It's really just minus.
Ow.
It just means minus. Which you can't normally do like that, but for that thing you can.
Oh yeah, because you told me it's like the way you like subtract something from another thing to find the length.
My entire taskbar. What the hell? Wait, my whole taskbar is reorganized. I was trying to find my browser.
Skill issue.
Okay, if I set this to $, does this compile?
Did it compile?
It does. Okay, so yeah, that just means current location.
Current location. Wow. Why would you? Why is this useful at all in any way? What is this for?
So like if you understand what this line there is doing, message 1 is the location at the left of that string, and then at the end of that string, you have current location.
Because it's the start.
0xA, 0xD, it looks like it's adding more bytes. What are those? What is that?
Oh? Is something on your screen?
I'm looking at 0xA, 0xD on
Oh
that
yeah,
code.
this part, 0x, 0xD, what the hell?
What is that? Let me look at that.
Okay. Yeah.
ASCII chart.
That would have been my next question.
ASCII chart. What are these things? 0xA, 0xD, line feed, carriage feed. So like.
Oh, look at the spacing of this. Like
0xA is a new line. What's carriage feed?
New line. 0xD.
I remember 0xA. I've used it a lot.
Oh, okay. It's a new line.
What is that? Return to the beginning of the current line without advancing downwards.
Without advancing downwards, what the hell?
Why does it need both of those?
I was gonna say, if you delete it, I bet it won't do anything. Or does it? It must not matter?
It goes down to the next line, and then goes to the beginning of the next line, which it already is at. Why does it do that?
I know.
The name comes from a printer's carriage, as monitors were rare when the name was coined. This is commonly escaped as /r. Okay, so
What'd you learn?
that they didn't need to put that there.
Oh, it's just unnecessary.
So the 0xA is a new line.
Yeah.
So welcome to the world of, and then it's gonna follow that with a new line, and then a carriage feed for some reason. And then the dollar sign is. So imagine that there are 2 extra characters at the end of that string, right?
Which string? Which
The dollar
string?
sign is pointing to current location, and at that point in the code, the current location points to the end of that string, because you allocated those bytes to the string, and now it's pointing to like at the end of that. Current location is at the end of that string.
Okay.
And then message 1 is the start of that string, so the length is right minus left. We talked about this before.
I see. Okay. I'm dumb because I actually thought in my head. Oh wait, no. Oh wait, okay, never mind. What I was gonna say doesn't make sense because I was gonna say left minus right, but it actually should be right minus left. My bad.
Yeah, right minus left.
Yeah. Entirely. What's the start string? Wait, but it doesn't make. But if you do. Well, maybe it's different than I think. Oh wait, it just means like in memory, like where it is. Because I was thinking like if you start on 0, if H is 0 and then exclamation point is some number, then some number minus 0 will be some. Oh yeah, but that's the length. Wait, okay, never mind. Never mind.
Yeah, it works.
Yeah, it works. Okay, cool. Good.
And apparently, I could just do that anywhere. So that's interesting information. I didn't know that.
That's interesting. But wait. So 0xD, explain what that does. I know it's not necessary, but what is its purpose when it is necessary?
It's a carriage feed, which I've never used before, so I don't really know a whole lot about what it does. But from looking it up, apparently it's like,
says hi, big
what do you call it? A carriage? What are you calling it? Carriage retreat?
Carriage feed.
Carriage feed? That sounds weird.
Yeah. Well, apparently it's called that way because at the time that was invented, like monitors weren't really things that carriage feed.
Fees. Okay, feed. Oh damn. But wait, is it the same thing as carriage return? Whatever this is, or no? No, it can't be because.
I don't know. Look at it. Maybe there's two different things. Let me look at the ask.
Wait, these should not be the same thing. Yeah, line feed, carriage
Let me
feed.
look at the ask.
Oh wait, line feed.
Well, looking at the ask, yeah, I see carriage feed, but I don't see carriage return, so I'm assuming they're the same thing.
Okay. Carriage return is just enter, like when you go to a new line. I think that's what carriage return is. It's like go to new line.
Why do they have two new lines?
Exactly. Like,
They have two completely different new lines for what reason?
let's see, carriage return.
Maybe maybe they have it that way because like on some machines it uses 0xA for new
Wait,
line.
I was wrong. Sorry, it's not a new line. Carriage return means move the cursor to the beginning of the line.
Wait, say again?
It just means move the cursor to the beginning of the line. Like if
that's what I found. That's what I found as well. But
yeah,
like,
okay.
if you're going to the next line. So
I know they're at the beginning of the next line, so you don't need to move it to the beginning if you're already there. It's funny.
Yeah, you're already there.
That's true. It was very unnecessary. When the above code is compiled and executed, it produces the following result. Hello, programmers. Welcome to the world of, oh god, Linux assembly programming. No. Okay, let me look at this. So, this is probably all three lines. So first line, syswrite 4, 1.
So I guess you use
Message.
equal to define a constant of a constant of a constant.
Constant of a constant of a constant.
Constant. Yeah, it's a very constant.
Sure. Constant. G lane 2, blah blah, and then it repeats for all three. Right, this is cool. The sad thing is that I'm not allowed to use the data section. But wait a second. Oh yeah, that's sad. Well, that's sad.
What? Everything on the stack.
Stack makes me sad. The assign directive.
The stack is going to be your best friend.
Oh, I reject my best friend. The assign directive can be used to define numeric constants like the EQU directive. Numeric constants. So what were we using with the equal? Oh, those are strings. But in this case, they're using it as a number. Like they use EQU50 for this example. So it's like that's numeric.
So it's treating that thing as a number, yes.
Yeah. Oh yeah, and then
so what's the other thing doing?
The other thing says yeah.
Let's see, assign.
But you can redefinition.
Oh, you can redefine it. Okay.
But doesn't that literally defeat the purpose of a constant? Because you're not supposed to. It's called a constant because it's constant. So that's like a point. That seems dumb. Like just use a normal name. Like I don't know.
Well, I mean, you can't change it without the assign. So.
Oh, so you have to say assign to assign it again, basically. Yeah. That's really it.
Yeah.
Wow.
Yeah.
Okay.
Yeah.
Okay.
Yeah.
For example, you may define the constant total as assign total 10. Oh, then you have to do it. That's really it. Yeah, you're right. Assign total 20. Wow. This directive is case sensitive. Okay, I guess this total is the case sensitive part.
Yeah.
Okay, the define directive. The define directive allows defining both numeric and string constants. Okay, this directive is similar to the hashtag define in C. Oh, okay. For example, I haven't learned about hashtag define yet. For example, you may define the constant PTR as define PTR EBP plus 4. Wait, I remember about like ESP because that's like where the stack ends, where you start. But like EBP starting from the opposite side, right? Where ESP is, like it starts all the way on the other end.
They point to the other ends of the stack space that you've allocated for the function you're currently running. Wait, but only for the function you're currently running, not for the whole entire everything? Like Yeah, the idea is
Look
with
at the function.
EBP, because EBP is not really supposed to move that a whole lot. You
Yeah.
use that as a base for being like that -4, that -8 are specific
Oh,
values,
for
and
the
you don't
function,
need to
because it will
account for
never
what
like move
you don't
like
need to account
ever.
for what you
Base.
push and pop up the stack that's kind of like that's more fixed than ESP.
I see, and that's why you have the B for base, because it doesn't move. Stay still, and have it. You always have that reference. Okay, that's cool. I'm glad I remembered something kind of ish. Numeric and string constants. The above code replaces PTR by EBP plus 4. Yeah. Oh, this directive also allows redefinition, and it is case sensitive. Okay. Okay. That's good to know. Oh no, arithmetic. I can't handle it. Arithmetic instructions. The instruction. The inc instruction is used for incrementing an operand by 1. It works on a single operand that can be either in a register or in memory. Okay. The inc instruction has the following syntax. Inc destination. The operand destination could be an 8-bit, 16-bit, or 32-bit operand. Wait a bit, so I'm just going to translate this to bytes so I'm not as confused. 1 byte, 2 bytes, 4 bytes. Inc EBX increments 32-bit register. Inc DL increments 8-bit register. So if EBX, let's say EBX was holding a memory address, then if you increment it, then you're just changing the memory address, incrementing it by 1, right? If it did?
Yeah.
Okay. Inc count increments the count variable. DEC instruction. Wait a second. Oh, so for these variables, these have to be defined in segment data to be using them, I guess.
Yeah, pretty much everything that isn't a register or an instruction or something like that has to be defined as like that thing in like data.
Okay,
like
makes
that.
sense. And then you have what's this down here?
So basically, when you get to do assembly, you won't see words like count and value.
I won't, because I'm not allowed to use this section.
Yeah, it's all gonna be numbers, and there's gonna be no English.
Okay. Move EBX count.
Just think about the numbers, visualize it,
Visualize,
keep it all
he
in
says.
your head as you're trying to solve these problems. Otherwise, it's too easy.
I don't think this is easy, even with the added data section. I don't think this is easy at all. But okay.
No, I'm not saying it'll be easy. I'm saying it'll be too easy.
I don't think it's too easy with that, but okay. Inkward EP. Okay, so when here with this one, I know I scrolled down ahead, but like
it's also like good like balance. Make sure that there isn't like other factors like you did it too significantly different from the way that I did it, so that way I can see if
you're right, because it's an experiment.
If you do the same way that I did it, is it still good?
That's true. Okay, so count is 0 up here. So if it's incremented, then this turns to 1. Is that what's happening? And then 1, like, take count, and now EBX is the name of the... It points to the memory address of count. It's going to be 1. Like, if you printed this, EBX, it'd be 1.
Can you say that again? I misclicked the wrong button.
Okay. So here in this, like, sample code, count is 0. It's a D word. It's 0.
Storing the value 0 at count. Yep.
Yeah, you increment it, so then it becomes 1. at this location, like, well, 1. And then you move this.
Increment, yeah.
Oh, okay.
Decrement value. Decrement the decrement the value at count. Increment the value at count. Decrement the value at value.
But I was just gonna say at this point in the code, wait, at here, when it says move,
Yep.
EBX is gonna be 1, right? At this point in the code.
No,
No, damn it.
because count isn't in square brackets.
Okay, so instead it has what? The memory location of count instead? It's not. It doesn't hold 1. It just holds the memory of count. Is that
Yeah.
it then? Oh.
Yeah.
Okay. Oh my god. So if it was in square brackets, then it would have taken the actual value. But because it's not,
Yeah.
it's just that. Oh my god. Wow. Okay. Good. Good to know. Thank you. I just wanted to clarify.
Mhm.
So not. Yeah. Okay. Cool. So then.
Can't wait for you to figure out what you can and can't put in the square brackets.
Oh yeah. So here, because they're actually using the value, not the memory address. Now it's incremented, so now it's 2. And isn't ESI? This is the special extra one you can use, isn't it? Or no? Or is this actually the one with the pointer?
It's one of the extras, yeah.
Just the extra one. Okay. So move 15. But this. Wait, why is this value blue but count is not blue? Shouldn't they all be blue because they're all variables? Like, it seems kind of inconsistent.
I can't even think that there's a. Let me get closer.
Here, see? This one's blue and this one's not. Like, that seems unnecessary.
Because I couldn't see because of like stream quality.
I'm sorry. Sorry. Yeah, one's blue and that's weird.
It's blue because I guess whatever they're using is interpreting the word value as some sort of keyword, but it's not supposed to be blue.
Okay.
It's not supposed to be blue.
Got you. So the syntax highlight is just wrong here. It's fine.
Yeah, syntax highlight is just wrong for the word value.
Okay. So this was decremented, so then it's 14 right now. 14 gets moved to ESI. And then decrements.
14 is not being set to ESI. ESI is not being set to 14.
Really?
It's being set to the address at the.
Well, no, I mean, no, not ESI. I meant value is going down to 14 because here it's sticking. Value goes to 14. Yeah. You're right, and then the memory location of value goes to ESI, and then ESI. Oh, okay.
So then that. You know what that does?
Decrements ESI. Well, it decrements value because ESI is pointing to the memory location of value, so it's going to decrement the value.
Yeah, so then value becomes 13.
Yeah, but why does it have to specify that it's a byte when we already said it's a byte up here? Like that's. Oh, you have to do it here, like inc word. You just have to, like, I guess. Like, can't you just delete byte and say dec ESI?
Oh, this is actually a fun thing.
What?
Oh no, wait, no, never mind, because that is a byte. I was about to say if it wasn't a byte,
yeah,
then this would actually give different behavior depending on whether you're doing little endian or big endian. But it's a byte, so don't worry about it.
Oh wow. Okay, that's
forget
crazy.
that it exists.
Okay, I didn't hear anything. I didn't hear you say anything. You didn't say anything.
Yeah. It said you have to specify byte because otherwise the assembly interpreter doesn't know whether you're trying to decrement a byte, word, or D word.
Okay, I'm thinking about it. Okay. Byte. So it doesn't know like where to and which part of the number to decrement.
Yeah, it doesn't know how big of a value you're trying to read and decrement.
Oh my god.
Because if you say word, then it's gonna do a different thing than if you said D word or if you said byte.
Wow.
Basically, it matters. It's ambiguous if you don't put it.
Okay. See, all these little luxuries like that are available in like higher level languages are gone. You have to tell it everything.
It doesn't assume which one you want because if it assumes, it has like a 1 in 3 chance of massively screwing you over and making it ridiculously difficult for you to figure out why it's wrong.
Okay, that's just fair.
So, like that's the sort of thing where it's like you appreciate that it stops you from doing that because otherwise, big problems can happen.
That's okay. Good point. You're right. It's not worth the big problems.
Not worth the debugging pain.
Mm-mm. Not in assembly. Like, damn. The ADD and sub instructions. The add and sub instructions are used for performing simple addition/subtraction of binary data in byte, word, and double word size, i.e., for adding or subtracting 8-bit, 16-bit, or 32-bit operands, or aka 1 byte, 2 bytes, 4 bytes operand, respectively. The add and subtract instructions have the following syntax: add, subtract, destination, source, destination. The add subtract instruction can take place between. Oh my god! If I ever
add destination source or sub destination source.
Oh yeah, source destination. If I ever took an assembly class in the future, if I ever did, I would be like, oh my god, I already am familiar with assembly. Like everyone else in the class is screwed, but not me. That's what it would be like. I'd feel good. Register to register. Memory.
So they have you doing AT&T syntax, and then it's like, what are these freaking symbols?
Oh,
yeah, you should look that up now. Now that you've seen a good bit of assembly, you should look up AT&T syntax assembly.
Okay, but I don't want to. I'm not gonna look up what anything does. I'm just gonna look at it and cry. Is that okay? Yes, it is. Stadium, AT&T Stadium. Oh my god.
Syntax.
Ew, it's just a lot of percent signs. Looks.
Yeah. Like, why? I don't understand why they have all these percent signs
everywhere. Like, damn.
Yeah, like the bottom code is just so much cleaner. Why why there's so many unnecessary symbols in the top code?
Lol. And just in general, like more letters and stuff. Like they just add. It's just more. It's more text.
Yeah. I don't like it.
Yeah.
I mean, I would say it would be fine if it served a purpose. But the thing is, I really don't believe it serves a purpose.
Well, you know, they gotta have more symbols because look. Explanation for you. Because look, they're A-T and T, so they gotta put those symbols in there for brand, you know, they gotta like...
I mean, maybe it's like some sort of thing where you can just write it without any, you can have all of your code without spaces or something like that. I don't know.
Brand recognition. Brand recognition. Or everything can be on one line.
Yeah,
but
yeah, but the syntax sucks. JDoodle has that on one of the things. I forget which one it is, but
fun. Register to memory.
On one of the other assembly options on JDoodle, you can use AT&T syntax.
Mm-hmm. Register to constant data. Memory to constant data. Okay. However, like other instructions, memory to memory operations are not possible using add subtract instructions. Oh yeah, and you told me about that before. No memory to memory.
Yeah, no memory to memory.
Mm-hmm. An add or subtract operation sets or clears the overflow and carry flags. Sets or clears, like... Oh wait, no, it makes sense, because depending on how much you add, it'll flip. It just depends on like the amount. It makes sense. The following example will ask 2 digits from the user.
If it doesn't overflow, then it clears it. If it does overflow, then it sets it.
Okay. So it's like, did I overflow or did I not overflow? It's like, that's what the flag says. Clears overflow.
Wait, is there text there that says example that is not there if you don't highlight it? In the black area?
Oh yeah, this is bad. You're right. You didn't notice that.
I saw that for a split second and I was like, what the hell?
I didn't even notice that. You noticed that, like something, like a hidden...
Yeah, I saw the text completely disappear and I was like, what?
What? No, seriously, it's like, it's welcome to the game. It's like, where's the hidden code? Oh, there it is.
Yeah, there's the hidden text.
There it is. Damn. Hold on a second.
That's like, this is a higher level secret.
Mm-hmm. We found the Easter egg. It's called example. Nice. Yeah, you're very observant. More observant than me. Like, I would miss one of these things if you didn't point them out. I'm just sad that it just says example. It's not like some secret code or like bank account number for me. Nope, just example.
Well, it's probably a side effect of using dark theme. They probably missed like whatever that tag is in changing the colors.
Yeah, they definitely did. Okay, there's probably this is a syntax. I've been missing them. I didn't know these exist syntax.
Yeah, like the H1s or whatever,
Example,
or
syntax.
the H2s, I guess. I think those are H2s, not H1s, but those are missing.
So it's these HTML, tags.
Hey, look at all this text that you didn't read.
Wow. Cool. Well, I just read it, so it's good. It's all good.
So incredibly important.
Incredibly important. Oh, this code's a lot longer than the other ones. Yay. I guess.
Is it that long? I don't think it's that long. I mean, compared to my code, my 1,000 lines of assembly.
I guess compared to that whatever that is, the hell that you coded. Alright, the following example asks 2 digits from the user. Store the digits in the EAX and EBX register, respectively. Add the values. Do the digits... Oh, wait, no, okay, never mind. I didn't say anything. Respectively, add the values. Store the result in a memory location, res, and finally display the result. Okay. Let me look at the data. Oh, wait. It starts with the data. Cool. 1 says read, 3 says write, 4. Now they're using from now on. What?
I should try and see if I can write a string to int and int to string functions without typing a single number.
Without typing a single number?
I feel like I could do it.
How? I can't even figure out how, because you need int, so it needs to be a...
Yeah, I
you
feel like
need to type a number.
It might be possible. Like, I mean, there are a lot of things you can do without typing numbers in like higher level languages. I'm wondering if I can accomplish everything the same way in assembly.
Yeah, but in like higher level languages, I can see it because it's higher level and you have. But lower level sounds like your options are so limited.
Yeah.
Yeah.
It would definitely be tricky.
It'd be really cool if you managed to do that though. Like that'd be pretty.
I can already imagine how I can get like the number 1. Like if I just say sub EAX, bitwise not EAX,
oh god,
and then or something like that, and then I do like IDiv EAX.
Oh
to
my
store
god.
1 to turn EAX into 1, and then I get 1. Like this is the sort of thing I actually did this in my applied science class. One of the projects or a couple of the projects, I wrote them without typing a single number in the code.
Nice. I would hate to freaking grade that though.
So like,
teacher.
like doing a thing like playing Neon Cat on the speakers without using a single number in the code, like stuff like that.
Wow. Wait, did you actually do that? It was play the song?
Yeah, I did that. That one I did. I did that one. Neon Cat on the piezo speaker, without typing any numbers in the Arduino source code.
Oh, wait, did you have to... Oh, wait, was this handled by, like, library stuff? Or did you actually have to, like, create, like, how the audio is being, like, stored and everything? Like, all the, you know...
I had... So, in order to interface with the piezo speaker, I had to... Well, I used some library things.
Okay, yeah.
Just the prepackaged stuff. The stuff that just comes with working on an Arduino.
Okay.
So like the stuff I don't really import any new libraries or anything like that. I just use the stuff
But you use like default libraries at whatever they give you. Okay, so they probably had some like audio thing there, like something.
But yeah, so I did that and I didn't type like if you did Control F and check the numbers 0 through 9, you wouldn't find them.
Nice. Where's... I need to put my phone in because it's like F1%.
Yeah, if you take a bitwise not of 0 and bitwise not of 0 and you divide them, you get 1.
I was thinking that's okay. Bitwise not of 0. Because then when it's not, then if they're...
That is -21474836648 for an integer, a 32-bit integer. and then
Oh, wait,
that
bitwise
divided by
not.
itself is 1.
Wait, say again. Bitwise not 0. What do you get at the beginning when you do it? Well, first step. What is the result of the first step?
Bitwise not of 0 is negative 214748368.
Oh God.
The important part, it doesn't matter what the number is. The
Yeah.
important part is that it's not 0. Because 0 divided by 0 would give you an error, but anything that's not 0, anything not divided by 0 gives you is fine.
Mm-hmm. Wait, the original byte, the one you're doing, whatever you're doing in bitwise not, wait, you're doing it on, like, what? Like a byte, or you're doing it on, like, a bit, or what? Maybe it doesn't matter, but still, just curious. Because 0 should be a byte, right? Because a byte, one number is 1 byte. Or maybe not.
Say again, I got disconnected.
Oh, okay. I said when you originally do the, I know this doesn't matter for the actual math part, but I'm still just curious. When you're doing the bitwise not on the 0, so 0 is just 1 byte, right? It's stored as 1 byte. It's like an integer, it's 1 byte long. And
Depending on what you're storing it into.
Oh, okay. So it could be -2, but whatever, not 2.
Zero is 1 byte if you're storing it into a 1 byte number, but it can also be a 2 byte number or a 4 byte number or whatever.
Oh, okay. But it will always be -2, or it's only if it's 1 byte, like the -2.1, whatever you said. You know.
What are you talking about?
Oh, because when I asked what does it end up being equal to, you were like -2 point something, and I said, is it only if it's 1 byte, it's -2 point something, or it's like if it's
that's if it's 4 bytes. If it's 2.14214748648, negative that's the 32-bit negative integer limit.
Oh, so it's okay. Oh, okay. I get it now. So the not thing is like giving you the negative limit.
That's like the smallest number that you can store in a 32-bit number.
Okay.
Actually, no way. It would be -1. Never mind. It wouldn't be that. It would be -1.
Oh, for 1 byte.
Oh,
sorry.
Well, actually, for 1 byte, 2 byte, 4 byte, it would be -1. Yeah.
Okay. Cool. -1. So then, that's interesting. 4 bytes. 1. That's weird. I mean, it kind of, well, how does it become -1 for everything? Because it's 0. Oh.
So the bitwise not of 0 gives you -1.
Yeah. Well, if it was like 1 bit, that makes sense, because either 0 or, wait, no, never mind. Wait, how does -1? Bitwise not on 0. How did that happen? Oh, wait, because actually, I don't know. What is the bitwise not doing? Like, what is it? How does it work again?
It's flipping all of the bits inside the number.
Oh, so everything. So it would have been
if you
0,
turn the
0,
number
0.
into binary, you turn all the zeros into ones and all the ones into zeros.
Okay, so if you're storing 0, regardless of how many bytes, it's all 0, and then they all flip to 1. And it's like 1, 1, 1, 1, 1, 1, 1.
Yeah.
And that ends up equaling -1. How does that happen? Because shouldn't it be higher? Like so. Maybe I should just like.
I mean, imagine that you have. So think about this. Imagine that you have like an imaginary 1 all the way at the end. You should always do this when you're doing subtraction. Imagine there's an imaginary 1 bit all the way at the end. Okay. Now you're subtracting 1.
Which end?
Throughout the entire way across, you need to carry from the next one.
Yeah.
Right.
Yeah.
I mean, you can also think of it like this. What's 1, 1, 1, 1, 1, 1 plus 1 in binary?
0.
Or in base 10, what's 9 and 9, 9, 9, 9, 9, 9 plus 1?
That's true.
All those 9s turn to zeros, right?
They do, yeah.
Same thing happens in binary with all the 1s.
Okay. That's a good explanation. Everything becomes 1. I just thought in decimal it would end up equaling like a different number instead of -1.
Well, in decimal, the equivalent would be all 9s.
Mm-hmm.
It's like signed, unsigned, whatever.
Yeah.
If it's unsigned, it's just the integer limit.
Oh, okay. If it's unsigned, then it's integer. Oh, integer limit.
I mean, negative numbers
that
don't
makes
exist for
sense.
unsigned numbers.
Because I thought the negative, whatever the negative limit is, I thought it was not -1. I thought it was like negative. It'll be like some, depending on the byte size, it'll be like negative, I don't know, whatever, some power of
Well,
2, something weird. Halved something.
for unsigned numbers, it's the positive integer limit because they don't have a negative integer
That
limit.
one makes sense. But what about, yeah, for the negative, for the signed integers, it becomes, because isn't it supposed to be half of the unsigned version? So it should be negative of something like related to whatever half of the unsigned one is. Which one would it be? Yeah, if they all flip. Hope that makes sense.
Yeah.
Like, okay, maybe I need to go find what one of the, like, negative limits is. Negative unsigned. Wait, I guess this is called signed limit of something. What's the smallest one I can use? Byte? Can I do that? Oh, okay. -128 to 127. Yeah, I thought if all the ones flip, so it's like 1 byte. If you start at 1, if you start at 0.
3-byte one.
Right. Yeah, if
3-byte literally does not exist and has never existed
Low.
for any numbers you can work with. How did they give that number?
I do not know. But yeah, I thought if it was all 0 and then you do the bitwise not, I thought it would become -128.
Yeah, I was thinking that too, but then I realized that you get that by going. But then when I thought about like positive integer limit and then adding 1 and that's how you get there, I was like, wait, no, that's wrong.
Really?
And then I remember, oh yeah, it's -1, not that.
That seems so weird. So I feel a little better knowing that you thought it was this initially before you thought about it more, but this is what I think. Like, it's weird.
Yeah, I wasn't thinking right enough.
Yeah.
But yeah, it's -1, which you get even if you do like the binary arithmetic of how to do like bitwise subtraction.
Oh, like you add the numbers and it will end up being -1.
Yeah. Which you do is you subtract 1 from 0, which gives you 1 and carry from the next digit.
Okay.
And the next digit is 0, so carrying from that gives you 1 and carry.
Oh
from
wait,
the next
I want to try
digit.
doing that. So I'll just use three digits because it's easier. So you subtract.
Yeah.
Where do you start subtracting from? Like, does it even matter?
From the right.
From the right. Okay, subtract 1, and then it flips to 1, right? It's just like we're just become 1 1 1.
Carry from the next digit.
Okay, so you subtract 1, and it becomes 1. But then don't you just do this over and over again? And then it's 1 1 1.
Yep.
Yeah, but that's not -1. Or if it was 8 bits.
That is -1.
It is.
That is -1. Yeah. That's -1 in binary.
What if you add?
We went over this. That's how you represent like negative numbers. When the number all the way on the left is 1, that's how you represent negative numbers. That there is -1. That's how you represent -1 as with signed binary.
What? Sign. Wait. Binary to decimal. Insanity. I don't remember which one I was using last time, but
Not that website.
not
it's a different website.
whatever this is. Not what I wanted though.
Making you click on things
Oh,
and
this
everything.
one.
Making
Okay.
you read an article.
Yeah, I don't want to do that.
1111 probably might need more. You might need to put eight.
Okay,
ones.
1, 2, 3, 4, 5, 6, 7, 8. Damn it! Oh, you're right. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So that's 2 bytes. Oh my god!
Yeah.
Wow. Okay.
See, it's -1.
Yeah, it is 1 1. But. That's crazy. 2, 3, 4, 5, 6, 7. I'm gonna look at the unsigned. I want to look at the unsigned one. Don't. 255. Wait, I'm trying. I'm like thinking about how this would make sense on the clock. Remember the clock?
Yeah.
Because you're going back, so 255. So it should be on this, like, you're going back just a little bit, subtracting one.
Well, I mean, if you add 0 and you go back, you end up at 255 because you have to
Oh, yeah, because the negative high number is on the opposite side of the clock, so it would be like at 6 o'clock down here, like the one that's like.
Yeah. I mean, the way I kind of imagine it in my
position
head is I kind of imagine like
Yeah.
portals. You have like a portal at 0
Of
and at
course.
the integer limit, which here is 256. So when you hit 256, you're back at 0. When you go below 0, you go to 255.
Below 0, go to.
It's like you kind of like cross a portal out to the other side.
Oh, yeah, and you start counting negative. Okay.
I mean, yeah, and in that sense, I kind of interpret it as like a movement rather than a number. I interpret it as like a movement in that direction. And when you go through the portal in that direction, you come out the other side.
Yeah, now I see what you mean. So all you have to do is bitwise not, and then you get a -1, right? Because that's all you need to do to grab a -1. Okay, maybe it is possible then to do what you said. Use assembly and make a calculator without typing in numbers. Pretty crazy. It's funny.
Is going to be, how am I going to store and access all these numbers? Do I have enough registers to do that? That's going to be the challenge.
Yeah, but then you have to do the weird thing where, like, you remember how sometimes you have to give the pointer, like, like you have to tell the pointer where to go, like -4, like move it around to grab what you're looking for. You can't do that because you have to type a number.
I feel like, I can't like shift the memory addresses with constant with numbers like that.
Yeah.
Like I can't do like ESP +4, ESP
Exactly.
-4.
But don't you need that?
I can do I could do like ESP plus EBX or I can't do ESP minus EBX. Though.
No.
But I could achieve that if I can make EBX minus.
Wait, why can't you do minus? If you can do plus, shouldn't you be able to do minus?
It's not enough. Yeah, this is going to be the fun thing you're going to find out is that you can do plus, you can't do minus.
That's stupid.
I think. I could be wrong about that, but I think you can't do minus.
Well, I want to revolt.
Well, I mean, they only have so many options for things that you can do in the binary, in the bytecode.
I guess, but they should have been more consistent when they created this language, I think. With what you can and can't do.
Yeah.
Yes.
Well, I mean, it is very consistent. I don't know. It works. It does the same thing.
Yeah, but that part's not very consistent. Sad. But you did kind of tell me you can do subtraction with addition, but it's still annoying to me. It's still annoying.
You can do addition with subtraction.
Oh, wait. So you can't. But you can. Shouldn't you be able to do addition with Shouldn't you be able to do subtraction with addition as well? If you can do addition with subtraction.
Let me tell you this.
Yeah.
You have the number +1. How do you get -1 for using only addition? If you don't have negative numbers, how do you get to the negative numbers?
Wait, I'm supposed to be allowed to, but then you have negative numbers, then it's fine.
Yeah, that's where the problem comes. I mean, with binary, technically, yeah, you can get to the negative numbers because you can.
Oh, the signed unsigned crap.
Yeah, because you can just loop back around the integer limit, and that's how you get to the negative numbers. You can do that actually.
But
that'd work. But if you wanted to do that, you might have to put like 255.
Well, yeah, you should be able to do that with subtraction too. It's the opposite. You just loop back around the clock by subtracting enough until you go positive. Like go to the positive.
Well, with subtraction, you just subtract a negative number from 0, and then you get a positive number. Just 0.
Oh, sorry, I meant addition. I was talking about addition. With addition, you can just add until you overflow into the negative.
Yeah, addition you have to overflow in order to get the negative numbers. But with the negative numbers, you don't. You can just do 0 minus the negative number, and you get the positive number.
0 minus. But
I want to see if I can do that.
But you're still doing a negative number anyway. Like you said, you can't use negative numbers, and you're doing minus negative. So I should be allowed to do plus negative too.
You have 0 minus 0 subtract 1. Subtract +1 gives you -1, and then 0 subtract that -1 gives you +1. So you can just alternate between them. You have access to the subtract out. I'm talking about if you're trying to do addition using subtraction, that's how you would do it. But like subtraction using addition, you need to go over the integer limit and do all that crap.
Oh yeah, but it's possible. It's just like it's maybe more annoying. But you like to do things
Yeah,
in the most annoying
but
way,
then the
so.
other question is of course, can you do that? Like, can you, if you have an unknown number, can you turn it into a negative number? Like, is that possible? I mean,
Wait, what does that
maybe,
even mean? If you have an unknown number, can
yeah.
you?
Like, how would you do that?
Oh,
Maybe if you just like, maybe it's like if you just subtract half the integer limit or something like that.
no,
I
I was
don't
gonna
know.
say there has to be
Like,
like an
or like
algorithm.
add half the. I don't. That doesn't seem like it would work though.
Why? That seems like it would work to me.
Well, because I'm just, I don't think that would work, like subtracting a constant amount, because you have a variable distance between those two values. Like with like -1, the distance between them is 2. -2 and 2, the distance between them is 4. So the amount that you have to add or subtract
What?
changes depending on what the number is. So it's not, you can't just use a constant. I don't think it would work.
Yeah. Well, you just need to know what you said, like how big your limit is that you're working with before you find
Yeah,
halfway
I
point.
think that's why like subtract is Turing complete, but addition isn't.
Subtraction isn't considered. Wait. Subtraction is considered Turing complete, but addition's actually not considered Turing
I
complete.
think it's subtraction, or if it was some other variant of the
Oh.
subtraction operation that is fully complete, like you could do everything on your computer with it.
Okay,
But
maybe.
addition, you can't really, like you can't even turn like x. Like if x is a number from one to 127, you can't consistently turn it into a negative number. I don't think using only addition.
Oh, cause you're just saying like cause you but consistent. You just mean you won't know how much to add to get there, cause it will be different
Yeah, like
depending on. Okay, that's what you mean.
you have to
But
read
subtraction
into
is
the
always
number and
subtract
make it
one.
work.
You'll go where to that point.
Yeah,
Okay, is this a fair point?
yeah, and of course that's assuming you don't have access to instructions like jump or anything, or compare or jump. You only have the add instruction. You can't.
Mhm. Okay.
Like whatever you do to get 127 to be negative 127, you can't do the same to turn 48 into negative 48 or negative 48 into positive 48.
Got you.
It's gonna be, you're gonna do it for the numbers. Yeah, it won't work.
By the way, once I get to the bottom of this page, you want to do like Phasmo and play like 2 rounds or so, and then we can go to bed. If
Sure.
you're not dead by the time I get here, depending on how long it takes me to finish the page, of course. But yeah, if I do. Okay. Yay. Okay. That's where it was. Right. Sys exit. One thing I'm enjoying about assembly is every time I do ask you like the same question or a similar question and then you explain something, it makes more sense. Like the next time you explain it, I'm like, oh yeah, yeah. Like it just like more things click, which is cool. That's fun for me.
Yeah, it's all gonna start making sense.
Yeah. Okay. So sys exit 1, and now from now on for standard input they're always doing 0, so it definitely was a mistake when they did 2 that one time. They screwed up,
I guess.
probably.
Could be.
Sys speed 3,
I mean, I
constant
wouldn't be
4.
surprised if it wasn't, but
Sys right constant.
because I'm sure, like in the kernel, you could probably have it be 2 instead of 0.
Standout. Standard output, not std out though. Constant 1.
The SPVs go out and out.
Oh my god. Message defined by enter a digit. Okay. And then we have new line. Move the cursor to the beginning of the line. Length. Oh yeah, and then the length for this is equal to the end point where the cursor is minus the start point of the message. So now I know what this is. Cool. Same thing with message 2. Same thing with message 3. Just the same thing repeated. Enter digit. Enter second digit. The sum is right. Segment.bss. Definitely, if I'm not like able to use the like, if you're not gonna let me use data and you're not gonna let me use BSS, then I'm gonna be writing like so many comments like blocking things in with my semicolons. Like, this is supposed to be the string for, like, damn.
Imagine if I said you can't use comments either.
That's too much, because then I can't
be,
even like remember where
much,
things are. You know that's easy. Yeah, that would be crazy. Number one, rest.
Like be like a regular high school programmer. Don't put comments anywhere.
Oh my god. Wait a second.
Like your teacher is gonna tell you a million times to comment your code, and you're just gonna be like, okay.
Yeah.
Oh, sorry, I forgot to comment my code.
I love comments. I make use of them a lot now. I remember when I first started, though, I didn't comment anything, but then later on, when I went to read my code, I didn't understand what anything did. And then I was like, oh yeah, comments are actually pretty nice. So now I just comment everything. I like comments. What is rest?
Yeah, when you're coding in assembly, everything's gonna look the same, so...
Yeah. I already forgot.
You're gonna need to comment it.
Oopsie. Oh, reserve. I forgot about the reserve thing. Reserve a byte. The reserve to single operand specifies the number of units of space reserved. Oh, yeah, and the reason I didn't remember what this does, I didn't remember it because they didn't give an example. Like, they showed the chart, but they didn't, like, most of these, they're giving you a code snippet, but this time they didn't. That's why I forgot. Reserve byte. You know, one thing, I kind of remember watching this because I don't know why, it was like very satisfying, but I remember in the past, like sometimes I'd see videos of like people like opening up those MREs, you know? You know what those are, right?
Yeah. Well,
Yeah.
imagine if I didn't.
But okay, exactly, that's what I mean, like, okay, good. But anyway, they're really satisfying to watch people like open them up and like make the stuff inside, and some of the stuff actually looked really good. I was just... like, surprisingly, it was really satisfying.
Chef Boyardee is an MRE.
Is it really?
Yeah, it was actually made as an MRE back in many years ago. During some wartime period, that he was actually being used as MREs.
Okay, I love how
Chef Boyardee ravioli.
Yeah, I love how your response to me was like, "Yeah, imagine if I didn't." Like a good point, I guess. But you know.
Me joining the military. Like imagine not knowing what an MRE is. That actually reminds me. There was this one. The guy who was sitting next to me on the bus to MEPS was telling me about how like one of his friends joined the Navy, and pretty much. They almost didn't get through. They almost like completely broke down because their parents had told them that like in the military, they're going to treat you right. They're going to be nice to you and all that. And then once they got there to boot camp, they just tore his frickin' asshole open. And it's like, sad. And it's like they were not nice to him at all. So he almost just completely broke down because his parents lied to him about what it was going to be like.
That's actually pretty horrible for someone to do that. Because you should go into with expectations, knowing what you're going to expect. I feel bad for him.
Yeah, like expect it to be hell.
Mhm. It's good that you have those types of expectations. It's good. Because I really want you to be successful. Mhm. Yeah. Yeah.
I watched the videos, so I kind of know what to expect.
Hell
the one thing that's worrying me the most about it is not like all the stuff right now. What's worrying me the most is the
Will you get in?
Swimming.
Oh,
just
swimming.
The swimming, really.
I see.
Because that's like the one thing. I mean, I'll learn. They'll teach me.
You'll learn. Don't worry. Hey, I swim. I mean, this is my perspective. I mean, I've swam for like a long time, so I feel like it's not it's different. It's probably like a lot different for an adult who learns to swim, but I don't know. Maybe this isn't helpful to say, but I think it's like one of the easiest things. Like it's easy as walking. I'm not even running. But once you pick up on the pattern, what you need to do, the thing that gets people, that stops them from swimming, is when they're in the water, they panic. And when you panic, your brain shuts off. So as long as you pick up the pattern of what you're supposed to do, and you don't panic, like, you'll pick up on it super fast. That's what I think. Because it's easy. The actual motion you need to do it's easier than lifting weights, because like when you're lifting weights, I haven't lifted weights, but I know when you lift weights, you have to use a techniques so that you don't hurt yourself. It's a lot easier than that, and there's many ways to do it. Like it's not like you need this like super special technique like weights. So if you can already do stuff like that, like then swimming is like 1,000 times easier. It's like I said, walking. And then once you get the
But what
muscle
if my-
memory, you don't have to think about it. What? What if you what?
But what if my whole body is like as dense as gold and I just sink to the bottom like a rock and you just hear a thump as I go down there and like the lifeguards are unable to like get me out of there or something, you know what I mean?
No, they'll be able to get you out. Don't worry. And also, by the way, even if you did go underwater and swallow water and stuff, it takes quite some time to drown. Like you're not going to drown instantly. It'll just be a very uncomfortable experience. You're not really in any danger as long as you're not by yourself. Like literally, you have like 0% chance of dying from drowning. So don't worry about that. But you probably, if something like that happened and you went underwater, let's say you swallowed a huge mouthful of water, like you inhaled a bunch of water, it's going to be very uncomfortable. Like, because you're gonna you're probably gonna vomit. You're probably gonna be like, feel like you can't breathe. Like, it's not gonna be pleasant, but you're not gonna die. So you don't have to worry about that dying.
Yeah, it'll be fine. They'll help me.
They will.
They'll scream at me for being stupid, but you know.
They might, but don't listen to them. That's just what they do in the military. Don't take it to heart if that. Yeah.
Yeah.
Yeah. One thing I will say though is it can be a little harder if you don't have a lot of body fat, because body fat like makes you float better. If you have a lot of, if you generally you just are like muscle mass, you sink more. So you do have to apply a bit more energy to stay up. But like I said, you'll learn how to do it. It's not.
So I weigh 108 pounds at 64 inches, 5'4" height.
Well, it doesn't necessarily matter how much you weigh. It matters what's the ratio. It's the ratio of your body fat.
Yeah, I don't have body fat. I don't have like any body fat.
That just means you literally have to put in energy. It's not that hard. Once you learn the technique, all I'm saying is it means you have to move your legs.
No, clearly that means I'll just sink.
That's why, but literally anyone, regardless of how much body fat you have or don't have, if you don't move your body, you will just end up going like face down or floating the way you don't want to. So regardless, you'll still have to learn swimming technique. It just means you just need to put more energy, but I think you'll be fine with that, because by that point, when you're in the military, I mean, they're going to be working you really hard. You're going to be running like courses. You're going to be jumping things. Like, damn, like I would die if I even tried it like for a minute. So you'll have enough fitness to do it just fine. Swimming will be. I wouldn't be surprised if you come back from the military and you say to me, like, guess what? Swimming was the easiest part. The hardest part was the other crap, like the gas and stuff. Like, trust me, that would not surprise me at all.
Well, I mean, the gas is probably going to be good for the rest of the time in boot camp. It's going to be like I'm never sick again after that.
But yeah, or just the thing. Honestly, the part that looks really intense is like the whole. Like sometimes they'll push you if they see, just they want you to find what your limits are. So sometimes they push you really hard, even more than. Just to get so everyone has that experience of getting pushed. So but you know this, like the idea that they'll run you until you might collapse. Like they'll have you run laps over and over and over again. It's like, oh, good job, you ran the lap. Now do it 5 more times. Like that stuff is actually really freaking intense. So you're much more than swimming. So
yeah, he said they might, like they will.
Yeah.
There's no might about it.
But yeah, like I said, I think you'll be good with the water. Keep a positive attitude about it. Mm-hmm.
I mean, well, keeping a positive attitude about it is what screwed over the other guy.
Well, I didn't say unrealistic. I said positive, as in like look forward to learning something new. It might be hard, but that's what I mean by positive. Like
I look forward to being stabbed with a pugil stick.
Okay, that's what I'm talking about. Because I look forward to being crushed by assembly syntax, as I already am getting like destroyed. But
that's not where my mind. The follow-up to that was not where my mind was going.
Okay. Anyway, segment BSS. That's right. Reserve bite 1, reserve bite 2. So 2 bytes, 2 bytes, 1 byte.
Res.
I know,
res,
it looks
one.
messed up. This is like reserved. This is where they're gonna store the result of the addition. Is gonna go. They're gonna put it in res in the end. Section.text start must be cleared. Oh, now they're using GC. Oh, they called it something different. Well, they said linker, but I guess linker is part of GCC. Wait, GCC is used to compile. Oh, this is used for C and C++, so I guess it makes sense that you can also use it to compile assembly into bytecode or machine code, whatever. Maybe I really should download GCC as a compiler so that I can, so then I could like code in assembly not through JDoodle but like on VS Code. That could be really convenient. Anyway, start till linker entry point, blah blah. Move.
Oh, not right now. It's not going to be convenient. I don't think. Maybe
not right now, but maybe in the future if I'm like spending like a whole freaking month trying to code one of your thingies that I'm getting like, you know, instead of like spending.
It's just going to be logic. So the only way that it would be easier for you if you were using GCC on like coding it in MS in Visual Studio on your computer.
I meant
is if it gives you access to things and it makes you able to do things.
Or don't forget, if I want to code,
everything that I'm going to give you is all just logic. It's pure logic. So
yeah. Well, I didn't mean make it easier. Like it's going to give me more tools. What I meant by easier is like, okay. Let's say I'm already, because I'm planning to use Visual Studio Code for most of my stuff. So let's say I'm already in Visual Studio Code and coding Python, and then I decide, I want to work on my assembly thing that I'm working on, and then I can immediately switch and open my assembly project without having to open a browser window and type in jdoodle.com and find my jdoodle thing. Like I can just switch back and forth.
Have you ever tried using Visual Studio instead of VS Code?
Well, Visual Studio doesn't support assembly. It's only C and C++.
Really, it doesn't?
I think so. Well, you could look. You're the Visual Studio guru. You should know if you look in it.
I'm not a Visual Studio guru, but
yes, you are, because every time we play anything,
you can get extensions for it. So if it doesn't support it, then there are probably extensions that allow it to support it.
Maybe. Visual Studio Code has all the good extensions. Also, I open up Visual Studio Code and it opens like instantly. And all my projects are open. That's nice.
Yeah.
Yeah, since it's just,
VS Code is a text editor.
Exactly.
Text editors are very expensive.
Yeah, but that's convenient as hell for small projects. Like, it would be too much. If I was doing like a big project, I would definitely use Visual Studio Code because you can't have all your stuff linked nicely.
When you're coding, when you're doing Unity, don't use VS Code.
It's pretty bad for Unity. You know they have a Unity extension for VS Code though. But yeah, Unity projects get big.
No, it's gonna be better to use Visual Studio for a lot of reasons. Like especially stuff like autocomplete, like when you're typing, it's going to give you like suggestions and all stuff. I don't think VS Code does that.
It does have that.
It does.
It does. Yeah, I installed that extension. IntelliSense, they have it. They support it officially.
Maybe it does. I don't know.
It does now. It might not have in the past, but now it does. So it's pretty nice. Movie.
I mean, I don't know. You try them out, figure out which one you think is better for it.
Yeah, I have both installed. Well, I kind of shouldn't have done this. I didn't realize. So Visual Studio 2019, I didn't realize if you uninstall it, you can't reinstall it. So I uninstalled that and installed Visual Studio 2022, and then I regretted it because I was like, oh, I would have rather kept the 2019 one. But whatever, it's too late.
You can't install the other one back?
You can't, unless you... Well, you can, but not officially. I found a source where I can install the EXE for 2019, or the installer, the EXE installer. I found a source, but it's not official. But you're not supposed to. They removed the download for it. And it says, Microsoft says, like, older versions of Visual Studio, you can only access them with a subscription. So it has to be Visual Studio Professional 2019. It can't be community, which is really stupid. Microsoft's mean sometimes.
Yeah.
Isn't that crazy? See, look at this. Isn't this crazy? It really shocked me. Visual Studio Watch this. Video Studio 2019. Install. Wait, are you running 2022? I'm just curious. Or 2019?
I have no idea what version I'm running. I'll have to go check.
Okay. But look at this. Older versions, this is what I mean. Older versions of Visual Studio require an active Visual Studio subscription. So you can't download Community anymore. You can only download Professional and Enterprise. That's it. It's the only options. But I found a source to download it if I want it later. Just saying. Isn't that crazy?
Yeah.
I know. Blew my mind. Where was I? Yes.
Yeah, imagine owning what you didn't pay for.
Imagine. But Community already was free. Like, it's the free version of Visual Studio. But I have the 2022 version now, so it should be fine. Move ECX, message 1. Move EDX. Oh yeah, this is a link for the message, blah, blah. Right, so write the message. Enter a digit. Move EIX to read. Read is 3. Okay. Standard input. Move EBX standard input. Equals 0. Move ECX number 1. Where was number 1 defined? Oh yeah, reserve byte 2. So 2 bytes for the number they input. Move EDX2. For 2 bytes. 221. Yeah, this was 2. Right, this is the input. Then it's gonna be the same thing for message 2. Get the number. Read the number. Well, no, sorry. Ask for the number. Have the user input the number. Write third message, which is the sum is sys right message length. Sum is okay. Finally, this is where the actual addition happens. This will be fun. Okay, move the first number to EAX register. And second number to EBX. Okay. Move EAX number 1. Move EBX number 2. Or rather... Oh, yeah. The number, actual number. Because it's in brackets. So move the actual number to EAX. Move the actual number to EBX. And subtracting ASCII 0 to convert it into a decimal number. Oh, wait, you told me something like this. Like, if you subtract...
Yes.
Something, but I'm trying to remember why this happens.
I'm gonna want to remember this.
Yeah, you said this would be really helpful. Because it turns it into a decimal.
4 different problems.
Oh, yeah, I remember. Actually, I remember your reasoning. I remember. You do this on 0 because the ASCII chart, each thing is, like, stored in a different, like, place.
Yeah, it's stored in order specifically to make this easy.
So when you subtract the 0, you're subtracting that number in the hexadecimal, and then you subtract that, and then it turns into, yeah, whatever. It turns into a decimal number, and they line up. I know I'm not looking at the chart right now, but I remember it had the pattern. It was really cool, so, okay, cool. Subtract EAX 0. See, if you didn't show me that chart, I would be so confused right now. I'd be like, why? I don't get it. It makes no sense. But it's because the chart is cleverly designed. Which is cool. Subtract EPX 0. And come decimal number. But this only works for 0 to 9, right? Or something? I think that's what you said. That you can do this for.
Yeah.
Yeah. For these only. Add EAX and EBX. Add EAX and EBX. Okay. Add 0 to convert the sum from decimal to ASCII.
Yeah, and then the next question is, how do you do it for, like, 2-digit numbers?
Oh, okay. Well, okay. It's probably something like for, I don't know. I don't know what it is. I would have to like think about it, but it's probably something like you subtract 0, but you like add a certain number to it for the 2 digits to get it to loop back. Actually, I don't know. Or it's like you subtract. I don't know. Or then you like subtract 0, adding a certain number to 0, and then you like add a certain number to that or something, or I don't know.
Well, whatever you're doing, it needs to work up to
All 2-digit
integer
numbers.
limit.
Oh wait. Oh, okay, up to the integer limit. Integer limit. Or just it needs to work for all the 2-digit numbers, right? Because you literally just said 2-digit number.
Up to integer limit includes the 2-digit numbers. Yes.
Yes, but then it goes above.
Yeah.
It could go above, but then.
So,
Okay.
so pretty much that's one of the things that you're gonna need to do, because you won't just be able to use like a fixed number to add to fix your problems, because you're gonna have like 1, 2, 3, 4, 5 digit numbers or whatever, and you need to be able to handle them all with a good sequence of steps.
Okay.
But
Recursion.
I can tell
No, I'm
you
just kidding.
your line of thinking was wrong, and you're gonna figure it out.
Okay. Well, maybe something like that sort of works if you do something like recursive and then until you. I don't know. I literally just don't know. But move. Where was I? Add EAX and EBX, right? EBX, EAX add. Add 0 to convert the sum from decimal to ASCII. Oh, yeah. Okay, add EAX. Add 0 to EAX. Storing the sum in memory location. Reserve. Move EAX. Reserved. Okay. String. The variable reserved. Print the sum. Move EAX system right. Oh yeah, it's just gonna do this again for printing. System right. Standard output. Move. Oh yeah, res to ECX. Or well, to move the memory location of res to ECX, because it's not in brackets, so it's not the value. Move EDX1. 0x80. I think this is supposed to be the message length. It's going to be 1. Exit. Move EX system exit, EBX, 80, yeah, end the program. When the above code is compiled and executed, it produces the following result. Enter a digit. Please enter second digit. The sum is 7. The problem with hard-coding... Oh, you did say there's a problem. Because remember I said to you, why don't you just hard-code everything? Or, I don't know, hard-code stuff you want. And then you said, like, that's a problem. There could be a problem. Section.text. Tell link or entry point. Move 3. Yes.
Well, what does it say about that?
Turn 3 to integer. Oh, I don't know. It says read the code and figure it out yourself. That's kind of what it said. So I'm reading the code to figure it out. Oh, it does say. Okay. Yeah, it doesn't say. It just says the problem with hard-coded variables, and that's it. So I guess this demo will show me what the problem is. Move EBX4, sub EBX0, so integer. Add EBX, EAX. So it should be 7. Turn it back into a string. Okay. Move EAX to sum. Yeah. As the value into this memory address. Move EAX sum. 7. Sum is now 7. Wait. Sum? Was this defined? Oh. Sum reserved byte 1. Yes. Message defined byte. The sum is new line, cursor beginning, length, constant, end of message minus the start of message. Move message ECX. Or memory location of message, move it to ECX. Memory on the, oh yeah. Move length EDX. Length message. Move EBX. Wait, one EBX file descriptor. Or EAX. Okay, so print. Is this right to stand out call kernel? Okay, so you're printing the message. The sum is move sum ECX. So now the memory location to ECX. EDX1, EBX1, EX4. Call kernel. Wait, what is this one doing? This one's oh, another print. Message one. Yeah, this is printing again, but the number. So print the number. Move one EAX. System call. Oh yeah, exit. What the hell? This code did not explain the problem with hard-coded variables. Like, what? It didn't explain anything, but it just says the problem with hard-coded variables. That's funny.
Yeah, I don't know. I'm not looking at it right now, so I can't tell you what the problem is.
Yeah, well, there's no problem with this code. This code looks fine. So it's just fun. It's just funny they titled it the problem.
When they're saying the problem with
But there's no
hard-coded
problem.
variables, it probably means that it's probably not like it doesn't compile sort of problems. Like, no, the code is going to be valid, but there's probably something else like more obscure, some more obscure problem that you can't see.
Maybe, but there is. Oh, look, I'm gonna like put this in.
Like we're talking like variable, like user input variables versus hard-coded things. One thing I'll tell you for sure, like there's an example of the other thing, like let's say it's like 3 plus 4 gives you 7 or something like that. Like you hard code 3 and 4. But then if someone changed that to like 5 and 6, with the method that you're using, you wouldn't get 11 as a result, or even like that. You would get some random character.
That's a good point. Well, they should have just said that because there's nothing wrong with this code.
That would be my interpretation, but like I don't know if that's what they're looking for. Because I'm not looking at the code, so I don't know what's going on.
Well, there's nothing wrong with this. I just ran it and I went through each line. There's nothing wrong with it. So yeah, trust me.
I'll take a look at it after.
Okay, it's fine. Like you could probably glance at it for like 1 second and tell like, oh, there's nothing wrong with this because there's nothing wrong with it. Lol. Okay, so anyway, MUL, IMUL. But I think it's probably what you said. They just didn't they were just too lazy to write the section about what they were gonna say. I feel like this section is unfinished, but that's fine. MUL, IMUL instruction. There are 2 instructions for multiplying. Oh god. Oh, this is the multiply thing. Okay. For multiplying binary data. The multiply instruction handles unsigned data, and the IMUL, integer multiply, handles signed data. Oh, this is what you had to look up because you weren't like sure. Like, which should I have you multiply or integer multiply? Both instructions affect the carry and overflow flag. Syntax. The syntax for the mul and imul instruction.
Yeah, that I didn't use that I kind of wish I used, so I'm gonna make you use the instructions.
Lol.
The not imul and not idiff instructions. I guess it's good for. I think maybe alright, but.
Okay. It's as follows: multiplicand.
I want you to use both of them and then figure out how to use them, and then like use mul
Oh,
and
Jesus
div
Christ. Dude, look at the. I'm sad because like if you look at this part, it's probably not gonna be super well explained, but like this is math stuff. Like they're literally showing diagrams of math stuff. Like no, not more math stuff. God. Anyway, I was gonna say what else was I gonna say? What was I gonna say? Multiply. Oh yeah, this word. Where is it? Oh wait, I scrolled down too far. That's what happened. Oh yeah, multiplicand. I've never heard it before. It's my first time hearing the word multiplicand. That's all. Does that just mean like one of the numbers being multiplied is a multiplicand?
Probably.
Lol. In both cases will be an accumulator, depending upon the size of the multiplicand and the multiplier. Okay. Operand.
Of me says
So the
operand.
multiplicand is the thing on the left, the multiplier is the thing on the right.
Okay. Depending upon the size of the multiplicand and the multiplier, and the generated product is also stored in 2 registers, depending on the size of the operands. You did say this, I remember, in your cheat sheet. Depending on the size, store it in a... Yeah, 2 registers. Following section explains multiply instructions with 3 different cases. Okay. Scenarios. When the divisor is 1 byte. Okay, divisor's on the bottom. I guess dividend's top. Dividend is assumed to be in the AX register, 16 bits. Wait. Sorry, I'm supposed to be multiplying. The multiplicand. Okay, scenarios. When 2 bytes are multiplied. The multiplicand is in the AL register, and the multiplier is a byte in the memory or in another register. Okay. AL. So it goes HL because half-life. So L is the last half because half-life is my mnemonic. And the multiplier is a byte in the memory or in another register. The product is an AX. And then AX is the whole half of the, thingy. AX is the 2 byte one. And AL is 1 byte. No. AX is 4 bytes. Yeah, AX is 2 byte. AL is 1 byte. 2 bytes. 3. Okay, I'm counting in my head.
That is correct.
That sounds right. AX 2 byte.
One of the things you said is probably right.
Okay, let me think. EAX is 4 bytes. So AX is 2 bytes. I think so. AL is 1 byte.
No, EAX is 7 bytes and AX is 3 bytes. AH and AL are -1 bytes.
No. -1 bytes? Bro, that would be funny. If that were true. AL's -1 bytes. No. I disagree. Okay, let me look at my picture. EAX is 4 bytes. AX is 2 bytes. Yeah, AH, AL are 1 byte. 2, 3, 4. Not -1. The product is an AX. Yeah, high order 8 bits of the product is stored in AH. Half-life. And the low order 8 bits are stored in AL. Okay. When 2 one-word values are multiplied. Oh, so these are bigger, because word is bigger than byte. Word is 2 bytes, right? Byte is byte. Word is 2 bytes. Double word is 4 bytes. I think that's how it goes. Quad word, I think that's what those are called, are 4. Where was that section? Addressing lists? I was gonna look at the chart again, but I forgot where it was. Yeah, quad word 16. That's how I said. Byte 1. Wait, byte 1. Wait, what? Ah, God. After byte word, 2 bytes. Double word, 4 bytes. Yeah, quad 8. And then you have T byte 10. the best one.
Which is the one
The
weirdest
funniest.
one. 10 is the weirdest one out of all of them.
10 is the funniest one. It makes me laugh. Because you were like, what the hell is a T-byte?
Like, why 10? 10 just doesn't make sense in computer stuff.
Mm-hmm. Because why not? Because it's funny.
It's stupid.
It's great because you get to wrong. Oh no, because you get to meme people with it. It's like, look at it's a T-byte.
Bad.
It's awesome.
T-byte all over you. Like, shut up. Come on.
Oh damn. When two one-word values. Oh yeah. So the multiplicand should be in the AX register. So this one was this was the AO. So AX, because it needs to be, it's a double word, so it needs to be bigger. So it starts, I get it. It starts in the AX this time. Because it's a one word value. Wait, so it should be in it's a word. It's 2 bytes. And then AX is
It's a
size.
Microsoft Word.
Exactly. AX is 2 bytes. That's why it needs to be in AX. Because otherwise it would be, AL is too small for a word. A Microsoft Word. And the multiplier is a word in memory or another register. So for example, for an instruction like multiply dx, you must store the multiplier in dx and the multiplicand in ax. That makes sense. The resultant product is double word, nice, which will need 2 registers. The high order leftmost portion gets stored in dx, and the lower order rightmost portion gets stored in ax. Oh. Wait, I'm kind of curious. In this example, is it stored in dx only because the what did they call it? The multiplier was already in dx, or is it stored in dx? Like, let's say the multiplier was not in dx. It was in, I don't know, ax. Wait, not ax. We're using ax. Okay, it was in cx. Okay, if the multiplier was in cx, does the result still get stored in dx, or does
the result get stored? It would be stored in AX and DX.
Even if one of them was
regardless
CX.
of whatever
Always.
you're using, it's stored in AX and DX.
Always. Good. That's good. Okay. When 2 double word values are multiplied. Okay. So we can go all the way up into double word, which is 4 bytes. Wait. Yeah. Wait, no, double word. Wait. Word 2 bytes. 4 bytes. Double word. Wait, no, quad word is 8 bytes then. That's right. When 2 double word values multiplied. AX, I was thinking A, B, C. That's weird. I feel like they should use BX instead. I don't like that they use DX, because it's like A and then you have to remember, like, it goes in D.
Yeah, I don't like that either.
Yeah, it should be AB. So AX, BX would be less dumb. When 2 double word values are multiplied, the multiplicand should be in EAX. Okay. And the multiplier is a double word value stored in memory or in another register. The product generated is stored in the EDX, EAX, registers. I.e.
Okay, I'm back to looking at the screen. What's going on? What was the other thing that you were asking me about?
Wait, I didn't ask you anything.
Oh yeah, the problem with constants or something,
Constants?
or like whatever the thing you were asking me about before. Like, what you didn't see the problem, and I didn't.
There
know the problem
wasn't.
was
Oh yeah, but because there wasn't a problem. There's nothing wrong with this code. This is not a problem. Like, it's genuinely.
Wait, go up a little bit. What is this? Let me read that again.
It just says the problem with hard-coded variables, and then it doesn't give you any text. It just gives you this code, but the code.
Program with hard-coded variables.
Oh, I can't read. Maybe I'm dyslexic. Damn. The program.
So what I've learned.
What did you learn?
That,
what did you learn?
You're fucking dyslexic.
Wow. Okay. So I have. Okay, that's worse than this calc. Is that worse? That's maybe worse than this calc.
How many times did you read that before you didn't figure out that it said program?
At least 10. At least 10. So,
Yeah,
where was
crazy. That's going in a clip. I'm
You're so mean to me. The high order 32 bits get stored in the EDX register, and the low order 32 bits are stored in the EAX register. Oh yeah, so it breaks it up into like parts, which is kind of cool. So here's my example. Move AL 10. Oh, so move 10 to AL, move 25 DL. Molt DL dot.
Corrupt converter says the problem with hard-coded
No,
variables.
no, the program with hard-coded variables. Program. Multiply DL. What's this? Move DL 0 FFH. So this is like -1 in hexadecimal. Where's my little converter? I wish I didn't close that now.
That's...
Sorry.
Yeah.
It is.
Why does it start with 0?
What? Oh yeah.
Why does it start with 0?
They forgot to give the hexadecimal indicator thing. Aren't you supposed to put that 0x? That's weird.
Well, they had the hexadecimal indicator with the H.
Oh, I didn't see that. Oh. Okay, so 0FF. So what's wrong with this then? Nothing, right?
I just don't know why they put the 0 there. It works. It should work, I think. I just don't know why they put the 0 there.
Oh.
I mean, it should work. It would be like writing 0, 100 to write the number 100.
Lol.
Or 0, 128. Like, it just
so if I
doesn't make
delete
sense
this, it'll still be 2... Oh, yeah, it doesn't matter. That's weird.
Yeah.
Why did they do that? You're right, because any zeros in front of numbers, it kind of, like, doesn't mean anything. That's funny. And they did it here, too, with 0BE.
Yeah, I don't know. I really feel like it was, like, 15 different people who coded all these different examples.
Yeah. Wait, so I could just... Could I genuinely...
Like, this is the thing that I was talking about, with, like, how...
Okay.
Like I was talking about, like with the Pop-Tart box, where there's certain where it refers to one thing as one thing and different, and the same thing as something different somewhere else. This is like different coding styles from different people. Like you have uppercase everything there, you have lowercase everything down below.
Yeah.
You have different like comment conventions. You have like the zeros there, and you don't have in any other places. With spacing, like this, like all these are like coded by different people.
It's so funny.
It's coded by different people.
Yeah. Anyway, I was gonna, So wait, if I, I know the 0, you said the 0 doesn't matter, but could I, like, write, like, 1,000 zeros and the code would still run, or is there, like, a limit to what I can put in? Like, how many zeros I could put at the beginning?
It'll probably still work.
Okay.
As long as you don't put a number bigger than 255 to store into a single byte number, I think it doesn't complain. I don't know if it complains with that. It probably does.
Okay.
But I think if you don't put a number if you just don't put a number too big to store there, then it shouldn't complain.
Okay. Cool. The following, you know, it would be so sad. Imagine if in school, like, they never taught you the decimal system, and you do all your math in hexadecimal. Like, that's it. Like, from kindergarten, like, you start counting in hexadecimal.
Well, you'd be perfectly content and happy in the in computer science.
Oh, I
You'd
guess.
be real good in computer science. You'd enjoy it. You wouldn't have any problems understanding hexadecimal.
That is true. Yeah.
Who cares about decimal? Just use hexadecimal, and then you don't have to think about it differently when you're doing computer science.
You're right, but you know what would be awkward? Now imagine they teach you only binary and only hexadecimal, and you never learn decimal, but then you become an adult and you don't know how to work with decimal, because it's like you have to like really think hard about how to use decimal.
That's assuming that everybody else is using decimal. Let's just assume that nobody uses decimal and everybody just uses hexadecimal.
Oh, true. Then it doesn't matter. But I'm just imagining you went to a weird computer science school that only teaches to kindergartners decimal and hexadecimal, and then you join the real world and find out like real people.
Yeah, 1 over E is 0. E.
Oh no!
Actually, it'd be 0.1111, I think.
Oh god. Oh no! I just realized like you could translate all those things like E to hexadecimal. No, just no. Don't do it. It's bad.
0.E all the way down should be 1, right? That should be 1. Should be technically equal to 1.
I'm in pain.
Some weird ridiculous proof probably limit.
I mean, this might seem simple to you, but you want to know something that blew my mind that I learned recently? Well, kind of
Why
learned.
who
Not,
when where when?
not. I don't fully understand it, but I kind of like grasp the overview a little, a little. So what blew my mind is, you know how like in decimal we have certain fractions like 1/3 that are like repeating because they don't go in cleanly.
Hmm.
But in binary, it's different numbers than the normal ones in decimal. Like it's specific multiples of other numbers that don't go in cleanly. But in decimal, it cleanly goes in, but in binary, it doesn't cleanly go in. So it's like something repeating.
That's just a property that happens in every base.
I know, but is it? I didn't know about that. That each base has its own like certain things don't go in nicely, and that's weird to me. Like what? What?
Yeah, like in base 10, you can divide
Mhm.
by you can divide by 2 and you can divide by 5 and it's fine.
Yeah.
But if you divide by 3 or 7
Then it gets
or
weird.
6 or any
Mhm.
of the other numbers, pretty much, you're gonna get problems.
Mhm.
If it's not a multiple of 5 or 2, you're gonna get a repeating decimal.
Yeah.
And the reason for that is because the prime factors of 10 are 5 and 2.
Mhm. But that just blew my mind. That each base like has their own special. What you say, like with the prime number. If it's like a prime number, whatever, then it won't
Prime
be.
factor of the base number.
Yeah. Yeah. What you said. I just can't say it
Also,
nicely.
something else, every base is base 10.
Wait, what?
And the reason why every base is base 10 is because the way you represent that base's number inside of that base is always 10.
Really?
3 in base 3 is 1 0. 5 in base 5 is 1 0.
It is? Wait, what is that? Wait, 5 in base 5. What does that even mean? 5 in base 5.
What's 16 in base 16 or hexadecimal?
16 base 16? What does that even
Yeah,
mean?
16
What does the
hexadecimal.
question mean? I don't even understand what the question's
What
asking.
what is 16 in if you like 16 as a decimal number, convert that to hexadecimal.
Oh. Okay. Is it 16? No, wait. Sorry, it's 10. It's 10.
Yeah.
So there's always going to be, the number is always going to be 10.
Yeah.
So,
Yeah, it's always that happens with every base.
oh yeah, because 2
Every single base.
in binary is 10 is 1 0. But that's weird.
Yeah.
Oh. So 10 is magical?
Yeah, every base is base 10, so how do you talk about anything?
Oh. Oh, that's like, it's like a joke, bro. I get.
But
Okay.
I mean,
That's
the
a
way
cool
you
pattern.
can kind of like unambiguously represent it is if you just do it as like a sum of ones or something.
Some of.
So like base 10 is 1 plus 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 1. And then that is
Oh.
unambiguous in every base, because every base is going to see that as the same number.
Okay. That's cool. So then, that's weird. Okay, okay. 1 plus 1 plus 1 plus 1. But that wouldn't change the way, would it? I don't know. I was gonna say, that wouldn't change the way, like it wouldn't make fractions less weird and repeaty, would it, by doing it like that?
No,
Yeah.
it has nothing to do with fractions.
Okay. Just the way I like the way you said it. I don't know. It's just funny. Like you're like, that's not related at all. You're like, why'd you bring that up, bro? It's funny. The following example multiplies 3 with 2 and displays the result. Start. So move AL and the spacing. Look how screwed up the spacing is here. Like I notice it. Like, it's really bad.
What the fuck is going on here? Even my original assembly code did not look that bad.
It did not at all. You're right. What if I submit all my assembly assignments to you looking like this?
I'm gonna go through and reformat everything
Okay. Fair.
so that I can like actually read it.
So you can read it. Okay, move.
I mean, most importantly, the most
AL.
important thing is that it just works. That's
true.
I mean, because like I don't really want to read assembly. As long as it works, it's good.
That's fair. Change to 3. Oh yeah, that's fair. So if you run it and then it works, you're like, okay, you win. But that's actually, wait, that's good, because then you won't know if I hit at the very bottom of 1,000 lines, I hit a BS section, like, you're not gonna look. It'll just work.
Me
Right.
run Control F.
I hate you. Don't do that. That's illegal. Don't use Control F. Move 2 BL. Subtract 0 BL. So turn 2 to an integer. Multiply BL. And it always multiplies what's in the AL. So add 0 to turn it back into a string. Or ASCII, whatever. An ASCII character thing. Move. Okay, so this was one multiplication. 3 and 2. Okay, right. So now move, oh wait, they do have a data section. Let me look at what they have. The result is new line, cursor beginning, length of the message, and then they have a segment. Oh, they're gonna store the result into, reserved byte 1, called res, reserved. Right, move AL to RES, store the value in the memory address of AL, which is the result. Oh, RES stands for result. Wow, I just realized right now. Right, and then they're going to print the message. Message lengthy DX 1 for, kernel, okay. So now they're printing out the message the result is. Now they're going to print out they're going to print out results. Move result to ECX. Move 1 EDX, 1 EDX4. Another print. Length of the message is here. And then end the program. The result is 6. Oh, one thing I think is kind of interesting, I guess, is... Oh, wait, never mind. It only goes to a new line because you have 0xa here. I was like, it moves to a new line, but that's only because they told it to. So it does, like, what you tell it. Also, wait, another thing. Wait, another thing I need to tell you.
Yes, the code does what you tell it to do.
Yeah. Is like, whenever they make a new line, they always use the .data section to do it. So I feel like I need data to make new lines. That's all.
No.
Okay.
What you're gonna do to make a new line in the code is you're gonna add the 0xa value manually.
Ew.
Like you're gonna make all of your strings by manually like pushing them onto the stack or writing them in or something.
Oh my god. I can do that?
Yeah.
Okay. I was like, that's allowed? That's legal?
I did that. I already showed you a code example of that of me writing hello world using push.
That's true, but you didn't do like a new lines and stuff. You just wrote hello world. That's different.
Well, if I wanted to add a new line, all I do is I just write 0xa, the number 0xa there.
Oh, that's it?
Or decimal 10. That's what that is. That's decimal 10.
Oh, it is? Okay. 9, 10. Oh, yeah, it is 10. A is 10.
Which I do have in my code.
10. A, B,
I use that
B,
in my
C, D. 10, 11, 12, 13. So D is 13. A, B, C, D, 10, 11, 12. Sorry. What were you saying? Continue.
I do that in my code, especially for my read line function, which reads a single line from the input.
Oh.
Up to some number of characters. So I use 10 as to find new line. If you hit a new line, then stop reading there.
Oh, you can you make it stop reading because when it goes to a new line, it'll just stop reading by itself?
Yeah, what I did is I was like, read one character at a time until either you hit the limit of whatever the person calling the function said is the max number of characters they want to read.
Oh, smart.
Or you hit the limit. Or you hit the limit of however many characters are in the standard input, or you reach a new line. Mm-hmm. So those 3 conditions.
Okay. Wait, there were 3. I only remember 2. Lol.
And the way that you can check, there's actually a way that you can check to see if you reach the end of the input.
Wait, how is condition 1 different than condition 3? Because weren't those the same condition you just said?
No. So So basically, the way I have it set up is
Yeah.
when you run the readline function, because I had to code up my whole readline function. When I run the readline function from another function,
Yeah.
one of the variables that I pass in is max number of characters that you want to read. So basically, if it reads like 30, let's say if there's like 32 characters, right?
Yeah.
So it
Okay, I
reads
see now.
32 characters, and there's more stuff to read after, and it didn't hit a new line yet. Then just stop reading because you don't want to just read infinitely.
Okay, so you're basically, it's like the user defined max versus the actual real max. Like the real max will also.
Like
Okay.
max. And the way you tell that you read to the end of standard input is there's a variable. I think it goes in EDX. I'm not sure. There's a variable somewhere that the kernel interrupt stores that tells you how many characters it actually read. So let's say you tried to read 8 characters from standard input, but there are only 4 characters in there. Somewhere, I think in EDX, it's going to store the number 4. Whereas if you read 8, it would store the number 8.
Okay.
So that's how you can tell if you reach the end. That number will be different.
Okay.
And that's one thing that's going to be very useful for doing readline.
That's cool. It's just storing the number so it knows how much it read. Because it's changing the counter as it reads.
Yeah.
Okay.
Basically, all I needed to do was just check to see and make sure that number wasn't 0.
And then what do you do when the user puts in like too many characters or whatever? Like what do you return?
Then you read until whatever the function told you to read until however many characters. Like I said, if it was 8,
okay, that's what
if you read 8 characters and you didn't reach the end and there were more characters to read, well then you just stop reading and return the result.
Oh, okay. I wasn't sure if you're going to do something like, oh, please put your number in again until you actually do what you're supposed to do.
This is basically just a function. So you wouldn't do that with a function. Like this isn't like printing out the console, asking user input, re-input, or whatever. This is just one single function that's going to be one of the tools that you make. It's just a simple read line function.
Oh, okay. Without all the bells and whistles.
And I'm using function for listing. It's just like, sorry. It's just like you use labels to kind of label your functions and then you set them up in a certain way. But it's all it does is it's just a tool for other functions to use for the rest of your code to use to say, read one line of code, one line of text up to some number of characters from standard input.
Mm-hmm.
And then I forget if I had set it up to just continue to just like only store that many, but if there was more, then continue reading until you reach the new line. I forget if I set it up to do that. I'll have to check.
Wait, why would you
have done that? I may not have done that. I don't know.
Wait, say it again. Wait, what did you forget?
I'm not sure if I set it up in a way so that like if you asked for 8 characters and there were 15 characters until the new line, then one of the things that I could think of doing is setting it up so that way what you do is you keep reading until you get to like those 8 characters and then you store those. You have those stored, but then you kind of have an option to either just return the function there or keep reading so that way you keep moving the read pointer until it reaches the next new line or the end of the string. Because every time you read from standard input using the interrupt, the hex 80 interrupt, it moves like the line that it reads from. So next time you read from standard input, it reads from where you left off. So something that I might have done, I don't know if I did it or not, is keep reading until you reach the new line.
Oh, so that you'll be able to read the next line. You're not going to accidentally start reading part of the old message. That's great. Oh, wow.
Yeah, so next time someone reads, they don't read from like the middle of the line. That's why you're
keep doing it. Oh, so you can get the... Okay. That's really cool.
Yeah, so the next time it reads from the next line.
Yeah. But I guess one of the things you could do, that's where that command hex, 0xd could come in handy, because you could just new line, move the cursor to the beginning. Well, you don't have to do that. You could just new line. Or something. I don't know. Well, yeah, I don't know.
Yeah, I'll have to check my code to see if that's how I did it or if that isn't how I did it.
Yeah, well, that's cool.
I wouldn't be surprised if I did do it that way. I imagine that, like, for the purposes that I was using it for, it probably would be more convenient to do it that way.
I see.
Just like long-term convenient to not have the problem of reading in the middle of a line later on.
Yeah.
But at the same time, I also wouldn't be surprised if I didn't do that if I didn't think of that.
Mm-hmm. But the division, integer division instructions. The division operation generates two elements, a quotient and a remainder. Oh, you did tell me about this. One will go into, I see, the remainder. It always, regardless of if you do mod or division, like in assembly, it's still going to do like both of these things and just return one,
Mhm.
which is so cool to me. In case of multiplication, overflow does not occur because double length registers are used to keep the product. Oh, yeah. That's true. However, in case of division, overflow may occur. The processor generates an interrupt if overflow occurs. An interrupt? So your program will just like end? What is it? What kind of interrupt is it giving you? Why are you getting
It's a
interrupted?
very good question. What is that condition? What condition is that?
Oh, well, in what condition will you cause overflow? Yeah.
When do you cause an overflow? I mean,
Fuck.
is it when you have something in the D register before you do the division? Is that like what it is? I'm not sure.
Isn't
I
it?
don't know. I don't know what the condition for causing an
Wait, what if you?
overflow.
Wouldn't it be
division
like
is.
if you divide 5 by like 0.0 something and then it will like go in like a
You don't have
trillion
decimal
times?
numbers. You don't have decimal numbers as an integer.
Oh, okay.
The closest thing that I can imagine is if you divide by 0, but that's just a divide by 0 error. That's not an overflow.
Yeah.
That's
But
a
this is
separate error.
weird.
I don't know.
Oh wait. Oh wait. Okay, yeah, you're right. Because it was okay. That's true.
Oh wait.
You thought of it
Yeah,
as
no,
case?
No, I'm just mocking you.
Yeah. Oh, that's mean. Okay, I see. But you know,
The whole time. Oh wait.
it's yeah. But you know, if anyone would know like a case where an overflow would occur, it would be you. So the fact that you can't think of one because you're good at math and numbers means like I feel like it doesn't
the way
exist.
I think about it is if you have A divided by B, the only thing you can get is A or smaller.
You're right. Oh yeah, because 3 divided. But wait, what if you divide by a bigger number than? Oh wait, no, it doesn't matter. You're still. It doesn't matter.
I don't see how you get an overflow.
Yeah, you're right. And you
Because
can't divide.
You can't get. Well, if you divide by a bigger number, you just get 0.
That's true. Damn it! You're right. You're right. Then it's impossible. Because you can't go below 1.
Also, this is gonna be important. This is one of the things you probably might want to use like idiff for. But then again, I might also put in a stipulation: don't use idiv or imo. Figure it out without idiv or imo.
Bro, I feel like you're gonna end up doing something by accident where you like don't read your code and you think you didn't use idiv and you're like don't use idiv and then I'm like stuck on it for a long time.
I know what stuff I use, and I know that everything I gave you is possible with all the stuff.
Okay, and then later on, like you're like, oh sorry, I actually did use idiv and I'm gonna like strangle you.
Yeah, one of the things though is one of them I did use regular division until I figured out that I could use idiv, and then I used idiv and it made the code a lot shorter.
Okay.
A lot shorter and simpler because idiv lets you do like divide by negative numbers like more easily, but div is unsigned pretty much. So if you want to divide by negative numbers or divide a negative number using regular division, you have to go through a whole process of setting it up in order to do that.
Yeah. I do feel like, okay, one thing is, if I code something at least once, then I shouldn't have to do it all over again. In the sense of, like, for example, if I do something, like, if I work with division with unsigned, you know, and use negative numbers, but I go through the whole extra process, then later on, if I have to do a different program that uses division, then I'm allowed to use idiv, because I already did it once.
Use regular division for the
first time I do it or something. What'd you say?
Use regular division for the simple calculator.
Isn't that the ultimatum?
Everything else, don't care. Just use it for the simple calculator.
Okay. Isn't that like
because that's the one where it's gonna matter. That's the one.
Oh,
where
it's the only one where it matters. You mean?
That's the one where it's gonna be trickier, especially trickier if you use regular division. Because like with the other ones, it's not gonna be too big of a deal, but that one's gonna be especially tricky.
Yeah, but you actually for the calculator only use div. You didn't use idiv.
I used div before and then I switched it to idiv.
Okay, but you used div and you finished the entire calculator in div.
What I did is I wrote all the code in div using regular division, and then I commented it all out and wrote the same thing with idiv, and it was shorter, a lot shorter.
But I mean, like, I know you wrote the code, but like you finished the whole calculator with div, and then later on, after the code was completely done, you commented it out. Is that what the order things took place in?
Yeah.
Okay, then it's
much. I
fair.
figured out I did like a while later, I think.
Okay, because the only time I was gonna say it's unfair.
The one thing that I might have done in between that and in between finishing it and then changing it to idiv, or after that, actually, I mean, or after I changed it to idiv, was make it so that way I could add parentheses. So I did addition, subtraction, multiplication, division. The only thing I didn't do at the time was parentheses, and I added parentheses afterwards.
Okay, so as long as I keep that order,
I
then
think if I got my order of operations right, I think that's what it is.
your order of operations. Okay, but yeah, what was it? Okay.
And like I recommend doing addition, subtraction first, and then.
So I'm allowed to code my thingy without parentheses, basically, and with I'll use div and not use parentheses.
You're gonna code it. So here's what's gonna happen. You're gonna code it without parentheses, and then after you coded the whole thing without taking into account parentheses, what you're probably gonna find is that it's actually really easy to add support for parentheses because because like doing that is pretty much the same thing. It's gonna be pretty similar to just saying. Just convert a string to an int. It's going to be as simple as converting a string to an int for making that call.
But that's so. I feel like that adds so much more complication because you don't know where in the equation you don't know where they're going to put the parentheses.
You're gonna be reading it until you're not going to be reading the whole thing all at once. You're going to be pretty much reading it one character at a time.
Yeah.
Or something like that. Or reading it until you get to certain things and then saying, handle that. Like
I get it now. Okay, that's not as bad as I thought.
The number and you call the string to num and you're saying, turn this string into a number. Give me that number.
Okay, because you're doing it in order, because order of operations, PEMDAS. So you're just adding the new part, parentheses. Right. Okay.
So like you're not just doing the whole thing. You got to go left to right and PEMDAS.
That's not so bad then. I don't know why. I thought you were just like looking at it as a chunk and it's like find parentheses. Like, but you're right. It's one. You're processing it one at a time. Yeah, it's true.
There are only a couple things that you kind of like chunk together. Which is really just saying put this thing somewhere that it's safe and then worry about it later. And that's just multiplication and division.
Okay.
Being separate from addition and subtraction.
Mm-hmm. The division operation generates 2. Oh yeah, question mark. In case of multiplication, this part was weird, but it's weird. But because overflow shouldn't ever happen. The divide instruction is used for unsigned data, and the integer divide is used for signed data. The format for the integer divide instruction, divisor over. Wait, no, sorry. This is just.
I don't think I'm gonna play fast, so I'm probably gonna go to sleep after you're done with all this.
Oh, that's okay. Next time. Sleep's important. I'm tired too. I'll probably like get a snack and like go to sleep as well when I'm done. The format for the
get a light snack like a whole
Shut up.
Steak.
Okay, yeah.
Get like a
light snack. I didn't say I'd finish the snack. I just said I would start eating a snack. You said I would finish. Divisor.
Listen, just make sure that you don't end up looking like queso.
Yeah, that would not be good. Oh yeah, queso, that guy.
If I look like queso, it might be a little. Well, I mean, if I look completely like queso, I would be disqualified from joining the military. But if I look closer to queso than I am right now, it'd probably be a bit better.
Yeah, maybe just slightly. Don't go all the way to queso size.
Slightly, slightly. Like being
divisor.
Being like less underweight is a little bit beneficial.
Mm-hmm. Divisor. Wait, divisor's in the bottom, so. Okay. The dividend. Okay.
Dividend goes in EAX.
Is an accumulator. Oh yeah.
And one thing that's gonna trip you up. Should I just let you figure it out? I wonder if I should just let you figure it out on your own. It's gonna be annoying, I think.
Yeah, you should tell me then. Go ahead. It'll still be hard no matter what.
Always set EDX to 0 before you do division.
EDX? Interesting. Oh wait, but this one has
always set the D register to 0 before
you do division. For at least these two, EDX is going to be affected. Well, They're using stuff in the register that are inside EDX, so if it's not
Oh,
zero,
so
it's
that's
gonna
what. Oh, yeah.
weird
Okay,
stuff
you know what? That
happen.
makes sense.
See?
Okay, I
EDX
wonder.
and the
I wonder
you
if
got it?
that's why they have like the whole like overflow. Okay, so that's why they have overflow.
Oh,
That makes
because you
sense.
can
That's why
have
they have overflow
numbers that aren't
because
supposed to
because it does
be
that.
in there.
But yeah,
Oh,
that's also why you want to clear the D register before you do division.
okay.
And if you
Oh.
don't, well,
I'm still, but even, okay, I know that there can be like leftover bits and stuff where they're not supposed to be, but I kind of still don't understand how it can cause an overflow. Like, trying to think of like a scenario where it would do an overflow.
imagine if you have a number that's
Why
like
would it?
4 times so pretty much EAX is like it's a 64-bit number, pretty much.
Okay,
It's those
imagining.
two 32-bit registers and it's reading as a 64-bit number.
Okay.
Let's say you do that and you divide by 2. Or something like divide by or even divide by 1 even, right?
Oh.
It's when you have stuff in EDX. What you're trying to do is you're trying to store. You're gonna if EDX is not 0, it's gonna give you like a 64-bit number, so a number that's too big to store in 32 bits. You're gonna try to store that quotient into a 32-bit register, which is gonna give you an overflow.
Oh, damn. Wait, I thought that would be normal though. Even not even talking about leftover bits right now, but I thought like, oh, okay. Oh, 64-bit. Oh, so you couldn't even do 60 whatever the number is divided by
It's doing
1?
64-bit. It's doing a
Just
64-bit number divided by a 32-bit number.
okay.
So like if EDX is something like three or something, and you divide it by 2, it's gonna turn that into 1, and then the other thing is gonna get put into EAX or whatever. But that's still too big to store in a 32-bit number because you
Oh,
have
wait, I get what you're
that
saying.
extra
So
bit in there.
previously you didn't realize like the top one can be a higher bit than the lower one, and that's why weird
Yeah,
overflow can occur. Because if it was 32-bit over 32-bit, it's impossible
yeah.
to
If
have
it was just
overflow,
EAX over
right?
the 32-bit divisor, then it
I
would have
get
been
it.
fine. But
I
since it's
see.
more than that, yeah. But
Okay,
yeah,
cool.
so that's why you always want to zero out the D register because you don't want to have to think about that.
Yeah.
If you don't, it's gonna screw you up.
Mm-hmm. That's true. Yeah, you're right. Yeah. Watch it happen. It's still, you warned me, but it will still happen probably at least once. Like it will, because I'll just forget like the process, and it'll
Yeah,
happen.
it'll happen.
It'll be. Don't laugh at me when it happens. The when the divisor is 1 byte, the dividend is assumed to be in the AX register, 16 bits.
Yeah, it's gonna happen. It's gonna happen, and I'm gonna be
No,
like,
don't.
what?
Bro, no, that's so mean. What if I'm just like really good and it doesn't happen? No, haha. What if I just do
Mm.
everything? But then if I do like perfectly, you're just gonna not believe me, which is really sad. But what if I was good? And it's like I didn't cheat. And you're like, yeah, you did. I'm like, no, I didn't. And I didn't. Yeah.
Like, show me your Chrome history,
Oh
and
no.
like show me a Chrome history on screen, and then type in Godbolt.
Okay, okay.
Like, let me take a look at this and these dates here.
These dates. Hmm.
Let me get a. Let me get a. Yeah.
Look through my ChatGPT history, and I literally am like, ChatGPT, code this in assembly, code calculator in assembly, copy paste.
Yeah, I'll put it into a thing and be like, did AI write this? And it says yes.
And that's how you, yeah, exactly. So you know, when the divisor is 1 byte, the dividend is assumed to be in the AX register, 16 bits. I think it's like similar to the multiplication. Oh wait, no, it's eight. Never mind. It's different. AX is for the second one here. These are different. But anyway, sorry. Dividend is assumed to be in the AX register. After division, the quotient goes to the AL register, and the remainder goes to the AH register. So these are 1 bit. AX divided by 8-bit. 16-bit divided by 8. Okay. I don't know why. It's okay, to me it like feels weird that for every division, shouldn't they just do like the same number of bits over the same number of bits? Because then you won't ever have the overflow problem. Like why is this useful to have double the amount of bits as a divisor, do you think?
Maybe it's that way. It
Yeah.
could be like a true inverse to multiplication.
Oh
So like
damn.
I'm thinking is that like if you like
Huh?
have like something
Inverse.
and multiplies and it goes over the integer limit, and then you divide by the same thing, it goes back to the original value. I guess it does that.
Multiply by. Wait, what does that look like? You have a number and then you do what to it to get true inverse? Oh,
So
you're
it
so
goes like
sleepy.
some number multiplied by some other number, like a times b goes over the integer limit. Then you divide by b, and it goes back to a.
Oh, that happens. That's cool. Wait, I want to like plug in numbers like 3 over. I don't know. What's a good number? It's like not hard. 2 over 6 times what would we do?
Well, it needs to go over the
Oh,
integer limit.
into over. Oh damn it. Okay, so
For
what?
for it to be relevant to this problem, it needs to go over the integer limit.
Okay. Okay, 64 over 1. And then it's like 64, but let's pretend it has to be 32 or lower. I don't know, maybe that doesn't make sense. Isn't that what you said? Is there a good example? Because you go over and then divide by. Go over the integer limit. Okay, well, I guess we could pretend it's like 2 bytes divided by 1 byte, because it keeps the ratio, like having it. So pretending like the integer limit is. Oh god, but then the
Yeah,
integer
it's
limit would be
probably
like
just
zero point
making
0.5
sure
byte.
that you can have that proper inverse to multiplication. That's probably what it is. Other words, yeah, it is pretty weird
Oh, okay.
and inconvenient.
But that's really cool what you just said, like how you were able to quickly like identify, oh, well, you would need it to be bigger for to do a true inverse. Like you're good at math. Like, damn. Like that's cool. You multiply by. So it goes
I mean,
over the number.
it was kind of like one of the
And what do
only
you
reasonable explanations. Like I just kind of run through a couple of things like why would they do that, and that was really the only thing that made sense because like that's the only other thing that stores values in that way is multiplication, and multiplication is the opposite of division.
But it doesn't do like one number. One of the multiplicands or whatever, the multiplier isn't bigger than the other. They're like the same size. Oh, but it is true they store it in two values like this.
It stores in the two, yeah.
Yeah, that is weird. Oh yeah, I didn't. Oh yeah, why did I never notice that? You're right. High is an 8. Oh. Oh, so that it can connect to. Okay. So they definitely have a relationship. Then I think you're right. I still don't exactly see why it's useful. What happens in the event of, um. Okay, so a number goes over. Oh, just pretend. I'm just gonna pretend that you divide something, and then there's oh no, there's too many bits. Like stuff's gonna get dropped off or something. Like then, what would you do? You said you can actually multiply it or divide it by one of the numbers, and then it will go back or something to what it's supposed to.
Yeah.
What is it?
Yeah. I mean, A times B divided by B equals A.
That's why A times B divided.
That's probably what they're doing.
Oh
What they're aiming
yeah,
for
you're
here.
right. A times B divided. Okay, that's good enough for me. A times B divided by B. A. B. It's cool. To the AH register. After division, the quotient goes to the AL register, the remainder goes to the AH register. When the divisor is one word, 2 bytes. Dividend is assumed to be 4 bytes long, and in the DX AX registers, dividend DX dividend should be. Oh, okay, DXA. Oh, yeah, high order, low order. Oh, God. The high order 16 bits are in DX. Low order 16 bits are in AX. After division, the 16-bit quotient goes to the AX register. The 16-bit remainder goes to the DX register. When the divisor is double word, the dividend is assumed to be. Wait, double word is 4 bytes. Divisor. Yeah. Dividend is assumed to be 64 bits long. So 8 bits. 64, yeah. And in the EAX register. The high order 32 bits are in EDX, low order 32 bits are in EAX. After division, 32-bit quotient goes to the EAX register, 32-bit remainder goes to the EDX register. The following example divides 8 with 2. The dividend 8 is stored in the 16-bit AX. Oh yeah. It's 32 bits. Wait, no, AX. Oh yeah, here. So, word, 2 bytes. 16-bit AX register. Divisor 2 is stored in the 8-bit BL register. Wait, oh yeah, divisor. Wait, divisor can be anything. I think. Can be stored anywhere. Okay. BL. I forgot about this BL register. Okay. One word. Start must require for using GCC. Tell linker. 8AX 0. Oh yeah, turn it to an integer. 2BO. Subtract BO. Integer. Divide BO. Add AX 0. Move AX to the memory location of result message, length of message. This will be this again. Repeating stuff. Print result. Print the result. Yeah, this has a new line. End program. Could was kind of execute pieces of final result. Result is 4. Yay. Okay, now you can go to sleep. Oh. But yeah, if you're even awake still. Yeah, good night, Croft. Oh my god, I bet you're sleeping. I don't know. I feel like you're sleeping. Okay. Good night. I'll see you later. Bye, everybody.